Are you ready to embark on a transformative journey into the world of microservices with Spring Boot? So this is a complete masterclass that covers everything you need to know about microservices and Spring Boot. So in this particular course, we will first learn how we can build a traditional monolithic application, and then we will convert that same application into microservices. We will first begin with the very basics of Spring Boot, where we will set up things and we will dive into the magic of Spring Boot. Then we will move beyond basics, where we will create a couple of projects using Spring Boot. And then when building a monolithic application, we will learn about things like JPA, Spring Boot Actuator, and tools like Postman. We will then understand what microservices are, and we will begin converting the application that we have built into a microservice. Now, when building microservices, we will learn about concepts like service registry, distributed tracing, Zipkin, RabbitMQ in a hands-on way. We will also cover topics such as API gateways, fault tolerance, circuit breaking using RabbitMQ. This course will also cover things like packaging your microservices, containerization using Docker and Kubernetes. Well, this course has hours and hours of content that is really valuable and will bring in a very comprehensive learning for you all. And this course is the ultimate roadmap to master Spring Boot microservices. So this is going to be a complete hands-on session where we will be actually doing things in a hands-on way practically. Now, if you have been watching my videos and if you haven't liked or subscribed yet, I would highly recommend doing so, because every subscriber or every subscription that I get on my channel motivates me to bring in more such amazing content for you all. The support and love that I get from my viewers impacts my ability to bring in more such amazing free content for you all. So I would highly recommend that you hit the subscribe button, like this particular video, and turn on the bell notifications. Also feel free to leave a comment to let me know what kind of videos I should bring for you all. Now, without a further ado, let's jump right into the session. Hello everybody, let's start talking about APIs. So, in today's world, interactivity and connectivity between the software systems are key, and APIs have become a crucial part of many modern software systems and applications. But what exactly is an API? So API stands for Application Programming Interface, alright, and API is a short form of this word where A stands for application, P stands for programming, and I stands for interface. Now, what does it mean? So APIs are nothing but a set of rules or protocols, you can say, that allow one software application to interact with another. So with the help of these rules and protocols, two software applications or two software systems can communicate with each other. So you can think of it like a messenger that delivers your request to the provider that you are asking a service from, and then it delivers the response from the provider back to you in the form of the response. Alright. Now, API is not a database or a server, but it is a piece of code that governs the access points to the server. Alright. Now, you can think of APIs like a restaurant menu. So if you go to any restaurant, a menu provides a list of dishes that you can order, along with the description of each dish and the price. And when you specify what menu items you want, the restaurant kitchen will prepare those items for you. It will do the work, and then it will provide you with some finished dishes that you can consume. Alright. Now, you don't know the process of how the restaurant prepares the food in the kitchen, and you don't really need to know. Similarly, an API lists a bunch of operations or a bunch of URLs, you can say, or in more technical terms, they are called as endpoints. So these are endpoints along with the description of what they do, and you as a developer can use them to build, or you as a developer can use them in your application for whatever purpose you need them for. Now let's talk about why do we need APIs. So the number one reason is to share data. So APIs allow different software applications to interact with each other and share data. And this functionality would have been impossible otherwise without the presence of APIs. The next benefit or the next need for API is to speed up the development. So with the help of APIs, you as a developer can use pre-existing frameworks or pre-existing functions that are already built somewhere else, and you can consume them with the help of APIs. Okay, and you don't have to write that piece of code or that functionality from scratch. So this saves you time, and ultimately it will end up boosting your speed and productivity. Now APIs also allow you to extend the reach and functionality of a software. So if you are a company, API can allow a company to give their APIs to third-party developers, and third-party developers can consume these APIs and build on top of this. So let me give you some examples of some of the popular APIs that exist. So the number one API would be Google Maps API. This is quite popular. Twitter API. Then we have Facebook's Graph API, and Amazon S3 also has an API. So let us head over to our browser and let's take a look at these. So here in the browser, I am having some tabs open over here, and you can see like this is the API of Google Maps, okay, where you can see. So here you have different functionalities like maps, routes, and places. So you can see like all the SDKs and everything related to maps. You have the routes API. So if you click on this, I'll open this in a new tab. And you can see over here, this is used to plot routes on Google Maps. All right. And you can use this API to build a ride sharing platform or anything like that. So Uber and other ride sharing apps use these APIs in their application. So you can like take a look at the documentation here. Okay, so you'll see everything as to how you can access the endpoints and what are the results that you will get. So you can play around with this. You have Twitter as well. So they also expose their APIs, and this is the page like developer.twitter.com, wherein you can go and take a look at what all they have to offer. So you can take a look at the getting started page, about Twitter APIs, and so on. All right. So this is Twitter, and it helps Twitter to expose the functionality of the Twitter app. And you as a developer can use these APIs and build on top of this. So if you want to build, let's say, an app that displays analytics of Twitter profile, so you can use these APIs and consume them in your application, okay, without having to build everything from scratch. And for Twitter, it enables them to expose their functionality to the outside world, and anyone in the world can come and consume these APIs and extend the functionality of Twitter. Okay, so it helps Twitter as well. So this is about Twitter API, and then we have this Facebook APIs, which you can access on developer.facebook.com, and you can see there are quite a few categories here, like the app, gaming, business messaging, AI, and so on. You have authentication. So if you are planning to implement authentication in your application, you can use Facebook login. Okay. And how do you use Facebook login? So you have different options. So within Facebook login, you can see like iOS, Android, web. So if I go to web, okay, you will see how you can use them and how you can build this functionality. So this is all about API. Now back to our presentation. Let us talk about the different types of APIs. So the number one type is the internal APIs. So internal APIs are APIs that are built for internal teams' purpose. So within an organization, there will be scenarios wherein one team might want to expose the functionality or anything that they have built to some other team or the rest of the organization. And in such scenarios, that particular team can expose whatever they have built with the help of APIs. and the rest of the teams or the other teams in that same company can consume these APIs. Alright. For example, a very good example of internal APIs is, let's say you have an infrastructure team that is working on the notification system. Okay. Now notification is common for entire organization. So let's say the organization has a product and it's a ride sharing app, and there are different teams there. Like there is the ride app team, like there is a user app team, partner app team, and so on. Okay. Now every team would want to send notifications to their customer. So what they can do is they can make use of these APIs that the infrastructure team has built, and these APIs are used to send notifications to the user. So the other teams can consume these APIs and they can skip the functionality of building the notification system. So the system is built once and being used by everyone else within the organization. Now, this kind of API cannot be exposed to the outside world. Like you don't want outsiders to send notifications to your users, right? That would be crazy. Like you just want your internal organization members to send like notifications. Like for example, marketing team might want to send some notification from the marketing dashboard. So it's internal to the organization, and that is what internal APIs are. So these APIs are internal to the organizations and are not supposed to be exposed outside. Then we have external APIs, and these are public APIs. So external APIs meaning they can be used by anyone in the world. And some examples of external APIs are like Twitter APIs, Facebook APIs, Google Maps APIs, and so on. So these are the APIs that can be used by anyone across the world. And then you have something called as partner APIs. So these APIs are built for specific partners. So let's say if you're working at an organization that is building a ride sharing app, and if you have partnered with someone, and as a result of the partnership, both the companies are doing some sort of integration. Now in this case, both the organizations might want to expose some functionality to each other. And in this case, the APIs that are built are only for this partnership and are to be used by the partners within this deal. Okay. And that is what partner APIs mean. Okay. So partner APIs are built for specific partners for a specific use case. They are just open to that partner itself and not to the rest of the world. All right. So this is about API, and APIs are crucial for modern web development, and they play a key role in software communications and functionalities. Okay. And understanding how APIs work is really important for you as a developer and anyone that is working in the tech industry. So that's about this class, and I shall see you all soon. Thank you. Let us start talking about status codes in APIs. Now, when you communicate between systems with the help of APIs, there has to be an indicator which indicates the result of the request. Now, this can sound like an acknowledgement. So when you communicate with someone, you need some sort of acknowledgement from that person. And this is exactly how it works in the case of software systems. And this acknowledgement in case of APIs is status code. So when APIs communicate, they use status code to indicate the result of the request. Okay. And these status codes are part of the HTTP protocol, and they can tell you whether the specific request that you did to a particular server has been successful or there were some failures or issues along the way. Now, let me give you an example. So let us say you have a cloud server here, as you can see, and you have two clients. So one is the mobile phone, and you have an application that is running on the desktop. This is how a typical application looks like. You have a remote server, and then you access the data on this remote server with the help of a client, which can be right from the mobile app or it can be through the browser. Okay. Now, when you want to interact, you will send a request to this cloud server. Okay. So this request goes to the cloud server and then you expect a response. So you get a response along with the status code. And this code tells you whether it was successful, like the request was successfully processed or it was not. And there are different codes that indicate what happened with your request. Okay. Now here, status codes are important because whenever we make a request to the server, okay, we receive the response, of course. So response we'll get, but who will tell us whether it was successful or it was not? So with the help of status code, and status code is that identifier that helps you understand this. Okay. So status codes are 3-digit numbers that represent the status of the HTTP response. And they help us identify the outcome of the request. And status codes can be classified. So there are 5 categories in which status codes can be broadly classified into. Okay. And the first digit of the status code defines the class of response, while the last 2 digits do not have any role in the categorization. Okay. So for example, you have this one category which starts with 1, and this means informational, and it indicates that the request was received and the process is continuing. Then you have 2XX, so it can be 200, 201, and this indicates that the request was successfully received, understood, and accepted. Then you have 3XX, and this indicates redirection. Okay. Now, this will tell you that the further action must be taken in order for the request that you have sent to complete. Okay. So if there are redirects, like 301 is the code to redirect. So you will receive a response starting with 3. Then you have status code starting with 4, which indicates client side error. So you as a client are requesting something from the server, and if there is an issue from your end, that is what a status code starting with 4 means. Now, an issue from your end meaning like you can send requests that might have bad syntax or like incorrect parameters, or the request is not formatted properly in the right format. So all these kind of issues are arising from the client's end, and that is when you get the request response with the status code 4XX, and this indicates client error. Then you have 5XX, which indicates server error. So like there will be scenarios wherein the server failed to fulfill an request, like there is an error or there is an exception that has happened or the server crashed or something. This response code will start with 5XX. Okay. Now let us take a look at some of the commonly used status codes. Okay, so the number one status code is 200 OK. Okay, and this is like the most commonly used status code, and this is standard response for a successful HTTP request. Then you have 201, and it indicates the resource is created. Okay, so whenever you are sending a request to the server to create something, like for example to create a user or create a product or something like that, then you get 201, which indicates that whatever your request was, it has been created. 204 means no content. And what this indicates is the server has fulfilled the request, but there was no representation or nothing to return. 301 indicates moved permanently. Okay. And whenever you try to hit a URL or an API call which does not exist or it has been moved, then you send the status code as 301. And this tells you that the requested resource has been moved permanently. Then you have 400 bad request, which means the server could not understand the request due to an incorrect syntax. So if you as a client are sending some request to the server and the syntax or the parameters are not right, then you get 400 bad request, which tells you that the request you sent is not valid. Then you have 401 unauthorized. So this indicates that the request that you send does not have authentication credentials or it's not authorized. So there will be scenarios wherein some APIs will be authenticated. Okay, so if you try to access, let's say, Twitter APIs, those APIs need to be authenticated because you cannot access users' information without authentication. Now, if you try to access the API without authentication, that is when you get 401 unauthorized. And this tells you to include the authentication information as a client into the request that you are sending to the server. Then you have 403 forbidden. Okay, so this indicates that the server received the request, it understood it, but it refused to authorize it. Okay, so it's something forbidden that you cannot access. Then you have 404 not found. So this means like you're trying to access something that does not exist, and that is when you get 404. So if you're trying to access a URL that does not exist, you get 404 error. Then you have 500 internal server error. So this means that whenever you're sending a request to the server, and there has been an unexpected condition, okay, because of which an error has occurred on the server, and that is when you get 500, okay, which indicates that some issue has occurred on the server. So these are different commonly used status codes. Okay, now understanding status codes is crucial when you're working with APIs, because they help you understand the essential information about how a request is processed, and it also tells you what happened to your request. Okay, so it gives you a clarity as to what is happening behind the scenes. All right, so that's about status codes, and I shall see you all soon. Thank you. So when talking about APIs, it's also important that you understand the different types of API requests that exist. So what are the types? So the number one type is the GET request. Then we have the POST request, PUT request, and DELETE request. So API request that you are doing to a server can be categorized to any of these four types. Now let us understand each one of them. So we have GET request, and this request is used to retrieve or get something from the server. Now this can be any resource, any data, or any kind of information that you need from a particular server, and server will help you fetch this from the database. And GET requests are only used to read data and not change it. So like the word says, GET. So it is just used to get the information and not to modify anything on the server. And whenever you're using this kind of request, you will get status codes like 200 OK, or if you're trying to access something that does not exist, you will get 404 not found. Okay, so this is GET request. Then we have POST request. Now POST request is used to create a resource on the server. So if you are allowing users to sign up through your mobile application, you will have access to the create user API, and with the help of that API, if the user signs up, you can create a user onto the server, which will in turn get saved in the database. So this way you are making use of this API to save the user's information and credentials, and you can do this with the help of POST request. So you cannot use GET request in this case, you will get an error. So the request type has to be POST. And when using POST request, some common status codes that you will encounter is 201 created, because when you create anything on the server, that is what server will respond generally. And if you're trying to access something that does not exist, you can get 404 not found, or you can even get bad request status code if you are not calling the API correctly. Alright, so this is about POST request. Then we have PUT request, and this type of request is used to update something that already exists on the server. For example, if you are allowing users from your mobile application to update their personal information, so if they have an edit profile page, they will update the information, and once they hit save, you as a mobile developer can call the PUT request, which you have been given access to. And with the help of PUT request, you can save the information and update it against the user. Okay. And keep in mind, PUT request is not used to create anything. not to get anything, but it is used to update something that already exists on the server. And when you're working with put request, you will normally get 200 OK if your request was successful. You can get 4 not found, or you can get bad request, which is 400. So this is about put request. Then we have delete request, and delete, as the name suggests, it is used to delete resources from the server. For example, if in your mobile application, you have a way for users to delete their account, for example. So this way you can make use of delete request. If the user presses that button, you might want to delete the user account details and everything that user has done in your application. And you can make use of delete request for this particular purpose. And keep in mind, delete is just used for deletion purpose. It is not used for post, put, or updating anything, or getting anything, or creating something on the server. Alright, and normally you will get 200 OK if your request is successful. You might get 404 not found if you're trying to query something that does not exist. Okay, or you might get 400 bad requests if the format is incorrect. So this is about delete requests. So these are the different types of requests that exist and you can make use of in your application. Alright, that's about this class. I shall see you all soon. Thank you. Hello everybody, let's start talking about what is a web framework. So first, let's get into the specifics of why do you need a web framework. So if you look at most of the web applications that exist today, they have a lot of things common in them. For example, all web applications need to serve the web page when a user tries to access a certain URL. All web application needs to have the aspect of security. All web applications need to have databases, authentication, and so on. So there are lots of common elements that exist in the different web applications that exist today. So these are just the standard list of things that I mentioned over here. But the question is, should you build this thing as a developer every time when you build an application right from scratch? So think of this as building a house. So if you build a house, you would need some blueprints and tools, okay? And for web development also, that is how things work. So you need set of tools, like some set of pre-built things that you would be incorporating in your web application. And developers earlier had to build these things right from scratch, okay? So if you have to build a web application in Java, you have to manage things like security, authentication, and everything, like how a URL is accessed and all these things manually. So this was the case early on, okay? And this was written manually by the developers every time they create a new web application. There was no boilerplate or a starter template that they could use. And this was very effort taking and is required by almost every website out there. Like, developers cannot say no to this, okay? So you can compare this with the analogy of building the house, okay? What if you had a set of tools, a blueprint ready, okay? Because every house needs that, okay? They would need certain tools. They would need some sort of a blueprint to set up things quickly. And that is where web framework comes into picture. So what if I would tell you that you could have some prefabricated components that you could use, okay? And you could just use these prefabricated components that you could assemble to make a house with fewer errors a lot more faster. So by prefabricated components, I mean pre-built walls, doors, windows, and so on, okay? Now, you could assemble these faster, yes, right? Like if you could get a list of prefabricated components, you could put them all together really, really fast. And you could also reduce the number of errors that you would get during the process. So this would make the entire process a lot more easier, faster, and you could focus on important things rather than doing repetitive things. And of course, this would make you fast. Now, this is what a web framework does. So what is a web framework? So web framework is nothing but a collection of tools and modules that is needed to do standard tasks that are required across every web application, okay? So web framework consists of some standards. Like for example, every website needs to serve web pages, interact with the database. They also need to interact with the web host. And hence, web framework take away these repetitive tasks and have a standard defined which you as a developer can follow and use that as a starting point. So rather than creating a blank new file when you start creating a web application, okay, you can use something called as web framework, which has some set of things already pre-configured. And this makes you a lot more faster. The benefit of this is you get to focus on important things rather than focusing on or doing a lot of repetitive things. For example, you can focus on business logic rather than setting up things and the boilerplate code. So that is what web framework is, and it makes your life a lot more easier. So you can compare this with the analogy of house building. So if you could have pre-built house, like a pre-built wall, pre-built windows, and so on. Like windows you would need for every house, right? You would need them in different sizes. So what if you could have a set of windows with different sizes and you could just pick the window that you want whenever you're building a particular house, okay? So if you want a window of 3 feet, like 3 feet wide, you have a list of windows, like you have 3 feet wide, 4 feet wide, 6 feet wide. So you could just pick 3 feet wide window and you could use it in the house. And that makes your life much more simpler rather than building things every time from scratch. So that is what web framework is. So let's talk about the popular web frameworks that exist in the market today. Now there are many web frameworks available for different programming languages, and each has its own strengths. Okay, we'll talk about some of the most popular ones. So the number one is Spring Boot. Okay, so Spring Boot is a Java-based web framework, and it is used to build a lot of enterprise applications out there. Okay, and it allows you to build them really quickly. So it takes away the hassles, a lot of auto configuration, and there are a lot of good features that Spring Boot offers to the developers. Okay, but yeah, Spring Boot is one of them, and it is Java based. Then you have Django, which is a Python based framework. Now Django is also known as batteries included web framework, which means it includes a lot of common functionalities built in. Okay, so if you learn more about Django, or if you read more about Django framework online, you will see this term batteries included being used at a lot of places. Then you have Flask, which is also a Python framework, but it is much more lightweight, flexible, and it is great for small projects or when you need more control over the code. Then you have Express, which is a JavaScript based framework, and it's a part of Mean Stack or Mern Stack. Okay. Now, what I mean by Mern Stack is Mongo, Express, Angular, and Node. Okay. So this is widely used for building APIs using JavaScript. Then you have Ruby on Rails, which is also called as ROR, and it is based on this Ruby programming language. Okay, and it is known for its philosophy of convention over configuration. Okay, and it helps you increase your productivity once you understand its conventions. So that's Ruby on Rails. Now, a lot of these frameworks are being also used by top companies. For example, Instagram and Pinterest use Django internally. Twitter and Airbnb have used Ruby on Rails. LinkedIn uses Express.js for server-side rendering. Netflix uses Spring Boot and so on. So if you learn and Google a bit more about these frameworks, you will know there are a lot of companies, big tech companies, they are using these frameworks for the day-to-day life. Okay. So that's about web frameworks, and I shall see you all soon. Thank you. Let's start talking about Spring Framework. So Spring Framework is a Java-based framework, and you have Spring Boot, which is based on Spring. Okay, so Spring takes away the hassle of building applications. So there are lots of things and lots of manual things that developers had to do before Spring came in. Of course, a lot of hassles were taken further by Spring Boot, but Spring also was a good enhancement to the traditional way of building application. So with Spring Framework, building enterprise grade applications is really easy. And let us take a look at some of the features which will help us understand what are the benefits and values Spring Framework provides to the developers like us. So the features of Spring Framework. The number one feature is the inversion of control. So Spring manages the lifecycle and configuration of objects. So if you're building an application, you will have a lot of objects that you use. So the lifecycle, the configuration of these objects are managed by Spring. It reduces the dependency and increases the flexibility for developers. Now, when I say Spring Framework manages the lifecycle of objects, these objects within application are known as beans. So the objects that are managed by Spring Framework are known as beans. And inversion of control is a design principle that is commonly used in software development, but it is a very valuable feature of Spring Framework. Okay. So in traditional programming, objects were responsible for creating and managing the dependency, but with inversion of control, the responsibility is inverted. Okay. And here the framework, which is the Spring Framework, takes charge of this. Now, how does Spring do this? So Spring does this with a feature called dependency injection, which allows it to define the dependency of the class externally, and it provides them to the class whenever the class needs it during the runtime. Okay. So let us take a look at one of the example which helps us understand this better. So let's take a look at this particular source code where you have an interface called message service. And what you're doing is you are implementing the message service to this particular class. Okay. And you have this particular method which is defined over here. Now let us say you use message service this way over here in SMS client. Okay. So in SMS client, you need this object message service. Okay. And you're creating the object of email service and assigning it to the message service. And message service over here was an interface, as you can see. Okay. So this is source code and you're using it properly in your method over here, send message. All right. Now over here, what is happening is SMS client class creates its own instance of email service over here within the constructor. The dependency between the SMS client and email service is tightly coupled. Okay. As SMS client explicitly knows about and creates the instance of email service. Okay. Now without IOC, so here in this example, we are not using this feature of inversion of control. Okay. So without this feature, the responsibility for managing the dependencies lies with the class over here. Okay. So this particular class is taking care of managing the dependency. It is creating the dependency since it has the dependency on this particular object and it is using it in its source code. Okay. Now this makes the code really tightly coupled and it makes it harder to modify and replace dependencies in future. And there are lots of problems that are associated with this approach. Okay. So with inversion of control, Spring takes care of managing these dependencies which are being managed manually as of now. And what Spring Framework also does is it injects them into the class. By injecting, what I mean is it makes it available during the runtime to the class so that the class can use it. And this allows for a more flexible and a modular version of the code, as the class itself does not need to be concerned with creating and managing all of this. Okay. By all of this, I mean dependencies. So Spring Framework simplifies this. Okay. Now imagine here you have just one dependency. Let's say if you have hundreds of dependencies, the source code will become a lot more complex, large, and the benefit of inversion of control will become much more evident. So let me give you an example of the same source code with the inversion of control in Spring. So here you have these two methods that we spoke about, and now let us take a look at this version over here. Okay, you can take a look at this version where you have declared this particular object message service. So here in this constructor, SMS client has dependency on message service, but instead of creating the message service instance within the SMS client, we are providing it through the constructor. Okay, and Spring's inversion of control container manages the life cycle of the bean. Now what I mean by bean is, so bean are the objects that are managed by Spring Framework. So what happens is during runtime, when you run this program, Spring Framework automatically injects the appropriate implementation of message service into this constructor, such as email service over here, and it makes it available for SMS client class, which it can use in this particular constructor and ultimately within this particular program. So with the help of this feature and by using the principles of inversion of control and dependency injection, Spring allows for loose coupling between components. It promotes, you can say, modular design. Okay, this design is much more modular, and it also makes maintenance a lot more easier in future when your code base grows. Okay, and it also separates the concerns and facilitates faster development and higher modular scalable applications. Okay, now this is inversion of control, and this is one of the powerful features of Spring Framework. Okay, so I hope you have a clarity over here. Let us jump to the next set of feature. Next is data access. So Spring Framework provides a consistent and a easy way, which is a lot more simplified, to handle data access. So what I mean by data access is accessing data from different data sources. Okay, like you might want to access data from PostgreSQL, MongoDB, MySQL, and so on. So Spring Framework has things like JDBC, Hibernate, JPA, which makes your life a lot more easier when you are building database-driven applications, and it enables you to work with databases or data sources in a easy and simple way. So that is about data access. MVC framework. So Springs has web MVC framework that provides a clear separation. So it provides a clear separation between the model code. Now what I mean by model code is the code where your entities are there, and also the web form. So code where your entities are stored, basically that is created for the database purposes. And then you have the view, which is responsible to interact with the user. Okay. So in model view controller design pattern, you have a model wherein you have all the entities out there. You have a view which handles the UI related logic, and then you have controller which handles everything in between and makes sure that everything works smoothly. So in this MVC model, Springs makes sure that it provides clear separation between all of this. Then you have transaction management. Okay, so it provides a unified way to manage transactions across objects. It also has an aspect of security. So Spring Security is a module that exists in Spring Framework, and it is highly customizable, feature-rich security framework that helps developers like you to secure their application. Okay, so it provides features like authentication. It enables you to protect against common site vulnerabilities, and it enables you to define authorization in your applications. Then testing support. So Spring Framework also has good support for unit testing and integration purposes. So it provides features like Spring Test Context Framework. Okay, it has good integration with frameworks like JUnit, Mockito, and so on. Okay, you can write test cases, do mocking, and so on. Then internalization and localization. So it provides support for both of these, allowing developers to build applications that can easily be adopted to different kinds of languages and locals. Let's talk a bit about history of Spring Framework. So Spring Framework was developed initially by Rod Johnson in 2002, and Johnson's goal was to create a lightweight alternative to Java Enterprise Edition, which is JEE. And he released the first version of Spring Framework in March 2004 with lots of core features. Okay, so the goal here of Rod Johnson was to simplify the development with JEE, which is Java Enterprise Edition, and it wanted to provide a lightweight approach to JEE. And that is what the Spring Framework was. So since 2004, Spring Framework has gone a lot of changes. Okay, it was first released in 2004, and since then it has gone through major developments, and a lot more versions have been released with a lot enhanced features. So that's about Spring Framework, and I shall see you all soon. Thank you. Let's start talking about what is Spring Boot. So Spring Boot by definition is an open source Java-based web framework which is used to create standalone production grade applications which are built on top of Spring and Java. So it's a Spring based web framework, okay, and it runs on Java. And also one thing to note over here that it's open source and freely available. Now, what is the benefit of using Spring Boot? Like, why would you use Spring Boot over Spring? And what is the advantage that Spring Boot gives you? So, here's the difference between Spring and Spring Boot. So, with Spring, there were lots of things that were involved in setting up, configuring, writing boilerplate code, and also deployment of the app. Okay. So of course, when it came to building apps before Spring, like before Spring was invented or created, there was a lot of boilerplate code and Spring reduced that to a lot more extent. Okay. So a lot of boilerplate code was eliminated with the help of Spring. But with Spring Boot, the boilerplate code was further eliminated. Okay. So with Spring Framework, you had a lot of things available readily. But still, there was some configuration to be done. There were a lot of steps that were involved in setting up and also in the deployment of the app. For example, if you're building an application, a web-based application, you're building it on your local machine first, right? Because that is a development environment. Now, to test your application, you need to have a local server running on your system. So with Spring, you had to set up a local server wherein you deploy that app and you configure the app that you're building with that particular server. And you had to do this for every application you build. Of course, a lot of things were automated and pre-configured, but yes, there were some things that were left out. And that is where Spring Boot came in. So Spring Boot offered a set of pre-configured components and defaults, and it eliminated the need for a lot of boilerplate code that was involved in setting up a Spring application. It went a step further. So you can think of this as, so analogy that I can give you over here is of a Maggie. Okay, so if you're building or if you're cooking Maggie, let's say, okay, and how do you cook a Maggie? Like you have a sachet with a pack of noodles and you just put it in hot boiling water, you boil it for 2 minutes and you're done. So that is pre-configuration. Okay, it's pre-configured. So you didn't have to do anything. You just had to get a pot of hot boiling water and you had to tear the packet and empty the noodles into the boiling water, and that is it, you're done. So the packet had a lot inside, so it was pre-configured, okay, to be cooked this way. All right, so it reduced the effort at your end and you could enjoy your meal quickly. Okay, so this is one analogy that I could give you when it comes to Spring Boot. Spring Boot operates in a similar way. So you just get the source code, you create the Spring Boot application, okay, and you can run it with a single click. It's that fast, okay. It's ready to be built, okay. So you can think of Spring Boot as Spring Framework plus a lot of pre-built configuration plus embedded server, okay. So Spring Boot is equal to, you have Spring Framework, pre-built configuration and embedded server. So for running the application, like I said, you need a server, okay, and Spring Boot has that pre-configured, okay, and embedded within it. So when you create a Spring Boot project, you don't have to set up a server where you would be testing your application and running locally. It's all embedded. You have to just create the project, okay, write some source code for your application and run it, and it will run on the embedded server, okay. Also, there is a lot of pre-configuration that goes, which we will talk about, okay. So this is Spring Boot, okay, and it eliminates the need for a lot of boilerplate code like I mentioned right now. It levels up essentially the development that you are doing with Java and Spring, okay. So if you're using Spring Boot, you are much more faster. You get to focus a lot on business logic rather than doing these daily tasks like embedded servers, and these are all manual things which can be taken care of. You as a developer can focus on the business logic, which is really, really important. Let's now talk about the components of Spring Boot. So the number one component is Spring Boot starters. So what are these Spring Boot starters? So these are a set of convenient dependencies, okay, that can be included into your application, okay. Like you can say these are ready to use ingredients, okay. So for example, if you're building a web project or if you're building a REST API, you know you will need to create some REST endpoints, okay, and for that you have a starter. If you're building a web application, you have a web starter, which signals that you're building a web application and all the configuration that is related to a web project is pre-configured and included. Okay. If you're building a database driven app, you have a starter for that. So whatever is needed for a web application that interacts with the database is pre-configured into that. So you have to just include that and it's done. So this is what Spring Boot starters are. It's a library or a shop, you can say, which has a lot of components ready to be included into your Spring Boot project to accelerate your development. The next step or the next component is auto configuration. Now, Spring Boot auto configuration attempts or it configures automatically your Spring application based on the dependencies that you have added. So if you have added, let's say, a dependency for database, so all the configuration that is needed for database is automatically taken care of. So Spring Boot determines that, hey, this particular application has database related dependencies. So guess what? It's going to use database. So I need to configure things like things that are needed for database, and it will take care of that. You don't need to do manually. Okay, you just need to set some properties like username, password, or the host where it can find the database and so on. But they are very minimal, and Spring Boot does the heavy lifting over here. So that's auto configuration. So based on like whatever dependencies that you have added in your application, it configures or auto configures things for you. Okay, you don't have to deal with the configuration manually. So this reduces a lot of hassle. Then you have Spring Boot Actuator. Okay. Now this is one of the non-functional features. So if you're building a Spring Boot application, you would need a way to monitor that application. You would need to gather some metrics like how many requests are coming, is the application up and running. So all these kind of monitoring things, these won't be the requirements that your client is going to tell you. Nobody is going to tell you these requirements. From the developer standpoint, these are needed for you. Okay. So Spring Boot provides Spring Boot Actuator, which you can add to your project, and it will enable the production ready features like monitoring your application, metrics gathering, tracing your HTTP request, and so on. Okay. So that's Actuator. Then you have Embedded Server. So Spring Boot includes an embedded server like Apache, Tomcat, Jetty, and it allows you to run your application as a executable standalone Java file. Okay, and this eliminates the need of you deploying your application on a separate server and testing it. Okay, so it simplifies the process. Then you have Spring Boot DevTools. So DevTools is a set of development tool that enhance the productivity during application development. So for example, if you make some changes, you might want a automatic application restart or redeployment, like live reload of static resources and so on. You might need some better logging or enhanced logging for faster development. So all of this is provided by Spring Boot DevTools, and you can include it into your project. Let us talk about the advantages of Spring Boot. So number one advantage is it's standalone. Now what I mean by standalone is it can be started using a command java-jar, and it does not need to be deployed on a separate web server. Okay, and it allows you to get quickly started, offering rapid application development. Okay, then it has or it provides you with starter code. Okay, now Like we discussed, startup projects enable you to get started quickly. It takes care of configuration and dependencies that are predefined, okay, and that are needed for every web application. It needs less configuration, okay, which means like since the configuration is taken care of by Spring Boot itself, there is very less need or no need to do configurations manually. And because of all this, it enables a company to reduce the cost and the application development time, and it helps them to go to market really, really faster. All right. So these are some of the advantages. And because of these advantages, a lot of developers love Spring Boot. And some of the reasons are it's Java based, which is one of the most popular programming languages out there. And it's fast and easy. Yes, it enables faster development and it's easy to use. Comes with an embedded server. It has various plugins and a lot of boilerplate code and configuration is avoided. All right. So that's Spring Boot for you. Thank you. Let's talk about Spring Boot architecture. So Spring Boot has a layered architecture wherein one layer will communicate with the other layer. And there are a few layers or a few tiers that exist in a typical Spring Boot web application. Following are the different tiers. We have presentation layer, we have service layer, and then we have data access layer. Let's talk about each one of them individually. So what is presentation layer? So presentation layer presents the data and the application features to the user. This is like the front end view, and this layer is the layer wherein all the controller classes exist. Okay. So what does controllers do? So controller accepts the request from the user, validates the inputs that the user has given, and passes it to the next layer, which is the service layer. So like I said, presentation layer does the job of presenting data and information to the user. Then we have the service layer, wherein the business logic resides in the application. Now, things such as evaluations, decision making, processing of data, all of this is done at this particular layer. This layer also does the job of interacting with both presentation and the data access layer. So this layer sits in between and does the job of communicating with both the layers, and they are frequently being called by presentation layer, and they will call the data access layer frequently. Now, what is data access layer? So data access layer is a layer where all the repository classes reside, and these repository classes are responsible for interacting with the databases, like performing the operations to read, retrieve, save data. And underlying databases can be any database, like it can be relational database or like NoSQL databases, but it is a job of data access layer to access the data and interact with the database lying under it. Okay, so this is how a typical Spring Boot architecture looks like. So these are the three different layers in which the application exists. Now let us take an example. Let's say we are building a library management system. So we will have a browser from where the user will be interacting with the application, since it's a web-based application. So this is our application, and user will be sending a request, and that request will be handled or received by the controller. Okay, so user interacts with the controller. Controller, it will take a look at the request and it will forward it to the service layer. Now, service layer classes interact with the repository classes, and repository in turn interact with the database. Now, service layer is the layer that will be responsible for all the logic that is related to our business, which is the business logic. So that will reside in the service layer. Controller and repository will do the job of interacting with the user and interacting with the database respectively. Then once the data has been fetched from the database by the repository layer, okay, what repository layer will do is it will pass the data to the service, and eventually the data will flow to controller and user will see it in his or her browser. So this is a flow in which a typical Spring Boot application works. The request comes through the controller from the user, then service, repository, and then it travels reverse back to the controller. All right. So this is a typical architecture of a Spring Boot application. So that's about this class. I shall see you all soon. Thank you. So let us start talking about Spring Initializer and create a Spring Boot project. So what is Spring Initializer? So I'm here on this website, start.spring.io. Now this is a website for Spring Initializer, which is a tool that enables you to generate or create a Spring Boot project. So if you're using free version of Intellij IDEA, which is the community version, that particular version does not have the ability to create a Spring Boot project. Okay, so you can create a Spring Boot project using Intellij if you're using the professional version of Intellij. But for free version, it does not have that ability. So for that, you need to make use of a free tool which is openly available over here on start.spring.io. Now this particular website asks few questions about your Spring Boot project. And when you hit generate, it will generate the complete project structure, which you can then import in your Intellij IDEA. Okay, and you can start coding over there. So this is a really handy website. You should bookmark this website because you will need this website every now and then if you are working consistently with Spring Boot, and provided you don't have the professional version of Intellij. So what I would say is you should head over to this website, Spring Initializer, which is here, start.spring.io. You need to select the project. So here it will ask you a few questions like what sort of project are you creating? So I'm creating a Maven project. So these are different build tools that exist. So I'll use Maven for proceeding with this project. Okay, you can use Gradle if you wish to, but I'll choose Maven. Now language, of course, will keep Java selected. And here it is asking you for the Spring Boot version. So here there are different versions of Spring Boot that are available. Okay, and you can choose any one of them. Now here you will see some versions that are labeled as snapshot over here. So you can see 3.2.0 snapshot. Okay. Now using the snapshot version of Spring Boot is generally not recommended for production environments. And the reason is snapshot means pre-release versions, okay, which means that these are still under development and they have been opened up for preview and they might be incomplete. They might have bugs and other issues. Okay, so they are intended for testing development purposes if you wish to try out some new versions of Spring Boot. Okay, but snapshot version is generally not recommended. So I'll be selecting this version, which is a non-snapshot version. You have other version too, which is 3.0.8, but I'll choose the latest one. Now, another thing is when you see this lecture or this website, when you visit this, you might see a different version, like different numbers over here. Okay. Now, that is perfectly fine. You can choose whichever is latest available because these versions keeps on changing as Spring Boot keeps on pushing new versions out there. Okay. So don't worry about the changing version numbers over here. Okay, so you can select the Spring Boot version starting with 3. Now 3 indicates you're using Spring Boot 3 version. Okay, so just make sure you're selecting the version that starts with 3. Okay, so once you've selected the version, here this particular tool will ask you for some project related information. Okay, now it's asking you for group. Now what is group? So group is nothing but the package name of the project. Okay, and this is usually the reverse of the domain name. So the default one here is com.example. So I'll say com.embarkx. Okay, so this is a website that I have. And then you have artifact. Now artifact is nothing but the name of the project. So the project name I can say as first spring here. Okay, you can enter any name that you wish to. Okay, so the this artifact name, and this name will also get updated over here. Okay. Now description is the description of the project. So you can say first project for Spring Boot. Okay. And you can see the complete package name over here. Okay. So this package name is automatically generated based on the information that you have given over here. Okay. So this is about the project metadata. Now there are a couple of fields more that have been pending. So here you can see packaging. So applications can be packaged as jar file or war file. So I'll keep jar as selected. Okay. And here it's asking you which version of Java you wish to use. So I'll keep Java 17 version selected, which is the long-term support version or the LTS version that is available. If you have some other version of Java that you wish to use, you can change it over here. That is perfectly fine. Okay. So this is about the configuration over here, the project configuration. Now on the right hand side, you see the dependencies. All right. Now if you click on add, you will see some dependencies that exist. Okay. So you can see like Spring Boot DevTools, Lombok, Spring Boot Web. So if you are building a web application, you need to select the Spring Web, and what this will do is this will include everything like RESTful applications, like things needed for Spring MVC and an Apache Tomcat, as well as the embedded container inside. So whatever is needed for you to build a web application, all of that will be included if you select this particular part. So you can scroll through and take a look at different dependencies that exist over here. So there are different categorizations, like you have web, then here you have developer tools, then here you can see template engines. This is Timeleaf. Okay, so if you are like writing some Java templates which are server side and you want to display HTML into the browser, so you can use Timeleaf. So the dependency will be included. You have security related aspects and so on. So you can scroll through, you can see JDBC. Okay, so if you select this and this, like everything related to the database will be configured. Okay, and you can take a look at the different kinds of databases that you can use over here. Okay, you can see MySQL driver, PostgreSQL, Oracle, and so on. Okay, you have NoSQL options as well, which is MongoDB, Redis, and so on. Okay, so there is a lot. You can just go through this list. Okay, so this is about the dependencies. So what we are going to do is we are going to search for web, since we are building the web application. Okay, now if you scroll up, this is what will be added. Okay, Spring Web here. Okay, and then you can click on explore. So if you click on explore, it will show you the project files that it will be creating for you. Okay, so you can take a look at the structure here. You can see pom.xml. You can see this is the entire structure. You can just take a look. Okay, so you can either copy, download, or I'll say close over here. Okay, and also one more thing I wanted to talk about is, so not this one, but this one over here. So this is a mode, like if you prefer a different mode. Okay, this is like, I don't know if it's useful for you, but you can, like, if you wish to have a dark mode, you can use this. All right. Then after doing this, you need to hit generate. So when you say generate, this entire project structure will get downloaded onto your system. So just hit generate and save this particular file on a particular location wherein you will be creating the Spring Boot project. All right. So that's about Spring Initializer for you. Let us talk about dependencies in Spring Boot. So dependencies refer to the external libraries or modules that your application would need to function properly. Okay, and Spring Boot makes use of Maven or Gradle build systems to manage the dependencies. So if you remember, when creating the project, we had selected Maven over here. Okay, so this project is created using the Maven build dependency, and we have a pom.xml file over here. Now this is a file that manages all the dependencies that are needed by our project. Now if you want to add more dependencies, you need to add the tags over here. So this is a tag dependencies which tells that all the dependencies are to be specified over here. This is one dependency and this is another one. Now, Spring Boot provides a wide range of starter dependencies, which are curated collection of commonly used and commonly needed by developers for a specific purposes. Now, these starter dependencies makes your life easier as a developer, and by including this, you can reduce a lot of boilerplate code. And you don't have to manage these individual dependencies manually. You need to make use of pom.xml file. For example, when you say, like, I need the Spring Boot starter web dependency, everything that is needed for a web application to function is included. Okay. Now, apart from this Spring specific dependency, you can also include like third-party dependencies that your application might need. And this could include some database connectors, some certain frameworks that you might need, or some libraries that you might need to do caching, or some other functionality that you might require. Okay. But by making use of this pom.xml file and specifying the dependencies here, you can easily save time and effort. Okay. So I'll show you. You can go to like maven.org. So since we are using Maven, I'll say search Maven. Okay. So you will see this link over here, search.maven.org. Now this is a link for Maven Central. And it says, if I zoom in, it says official search by maintainers of Maven Central repository. So you can discover different Java packages and you can even publish your own. So I'll go to this Maven Central over here. And you see the welcome screen over here. I'll say close. Okay. Now what you can do is you can search over here. So I'll say Spring Boot Dev Tools. So this is a simple search that I have performed and you get to see all the search results over here. Now you can see over here Spring Boot Dev Tools. Okay. And you can see the different information like the latest version, when the latest version is published, licenses, and all of that. You can click on this and you have this tag over here. Okay. So if you're using Apache Maven, you can like copy this and you can paste it in your project. Okay. You can even change this to Gradle, or if you're using any other build tool system, you can switch it to that. Okay. And you also have a Maven pom.xml file. You can see over here. This is an example file that you can take. But if you just need to add it to a Spring Boot project, you can just copy this and add it to pom.xml under the dependencies tag. Now you can go over here and choose the versions as well. You can take a look at the version. Okay. So if you need a specific version, you can go and check that out. So I will go to 3.0.0 and it will open up the page for that. So this is the version and you can see the version number over here, which is specified. Okay. So this is about the Maven search repository. Okay. Now if I go back here. So here on the home page, you will see like some of the most popular packages that have been consumed by developers in last 90 days, some of the namespaces and so on. So you can like just play around with this if you wish to. Okay. And you can like just explore this a bit. Okay. Now you will also see some dependencies over here. So this is the official website of Spring Initializer and you're seeing some dependencies that you can add over here, and whatever you add over here. So I added Docker Compose. You will see the pom.xml being generated over here, like for that. Okay. Now, what is the difference in getting the dependency from Spring Initializer and Maven Central? So Spring Initializer provides a curated list of commonly used Spring Boot dependencies that cover a wide range of use cases. Okay. However, it may not have every single dependency out there that exists within the Spring ecosystem. So there will be scenarios wherein you might want something and that does not exist on Spring Initializer. Okay. So you could go for Maven Central then, or you can visit the official website of the provider for that as to how you can include it. Okay. But there will be several reasons as to why that dependency is not included on Spring Initializer. Okay. And some of the reasons that I could think of is the number one is it's a custom or a lesser known dependency. Okay, so Spring Initializer focuses on what is popular and what is commonly being used in the Spring community. So if a dependency is relatively new, niche, or it's less commonly used, then it may not be included over here in this particular list. Okay. Also, start.spring.io, like the Spring Initializer website, includes the latest stable versions of the dependency. Okay. So if a specific version of the dependency is not considered stable, then it may not be included in this list. Okay. And also, this particular website is maintained by the Spring team and the community. Okay. So they gather a lot of feedback from the community, and based on the community feedback, they make sure the dependencies are available. So these are some of the factors as to why you might not find all the dependencies over here. But if you don't find anything over here, nothing to worry. You can head over to Maven Central and search for whatever you are looking for. Or like I said, you can go to the provider's website. All right. So that's about dependencies in Spring Boot. So now is the time to start creating our first API. So we'll create a very basic API and we'll understand how things work with Spring Boot. And this will be a RESTful API endpoint. All right. And for that, we are going to need a controller. So I'm going to go to the project structure. I'm going to scroll up, collapse everything. And here I'll go and I'll say new. I'll say new Java class and I'll call this as hello controller. And I'll press enter. Now, if you have Git configured, you will see this pop-up. And if you don't have, you might not see this pop-up. So I have Git configured on my local machine, and that is why it's asking me to add this file to Git. So I'll say don't ask again and add. Okay. Now here in this controller file, I'll start writing some code. Okay. And I've called it hello controller because we are going to just create a simple hello world API. All right. I'm going to first say @REST controller. So you can see this auto suggest, and this is the annotation, which means that we are ready to use Spring MVC to handle web requests. All right. So we need to specify this annotation if you're building a REST API. And now we are going to create a GET request. So I'm going to say public. I'm going to define a method. I'm going to say string hello. So it's a very simple API, and I'm going to return hello world. You can return anything you wish to, but I'm returning a simple string. And now here we need to, so we have this method here. Now how do we map this to the URL? So we can map this using annotations. So we have defined this as a controller using annotation. We will use another annotation, and you will say @ and I'll say get, since this is a get mapping. So I'll say get mapping. Okay. And as a parameter, I'll specify hello, like so. Okay. So what we have done is, if any request comes on our domain with /hello, so domain name /hello, we will be invoking this method, or Spring Boot would be invoking this particular method and executing the logic that we have written inside. All right. Now, let's take a look at REST controller. So REST controller annotation is a specialized version of controller annotation. So you have this annotation as well, controller, okay, which you can see, right? But I'll delete this, and I'll delete the import as well. We don't need the import. But REST controller annotation is a specialized version of controller, and it combines two annotations, controller and response body. And if you wish to see, you can hover on this and press Control or Command. So if you're on Windows, you will press Control. On Mac, you will press Command. And I'll go into this annotation, and you will see you have controller and response body annotation here. So there are other annotations as well, but these are two main ones. Okay. And this indicates that this class is responsible for handling HTTP request and return the response in the form of a RESTful representation. Okay. So that is what this specifies. And we have specified this annotation which means that we have informed Spring Boot that this is what we are doing over here. And then we have this get mapping annotation with which we defined a get mapping. All right. Now what I will do is I will run this particular application. So I'll go to first Spring application.java and I'll say run over here. So this will run the Spring Boot application. Okay. You can see some processing happening over here. Okay. And you will see this message here. Tomcat started on port 8080. All right. So on your local machine, this application has been deployed on the Tomcat web server, which is now available on port 8080. So what you need to do is we will switch over to our web browser. So here in the web browser, I'll say localhost :8080. So of course, we'll get an error over here. So we get an error, white label error page, and this is a default error page that Spring Boot provides. And it says that there is no mapping defined for this particular URL, which is correct. So we have defined the mapping for /hello. So we need to access that. And you can see over here, we have the first Spring Boot application working up and running in our browser. All right. So what we did, we literally just wrote some small piece of code, a very basic method, and we have the output in the browser. All right. So that's how you can create a Hello World API using Spring Boot. Let us understand how our API worked. So when we executed our application, okay, we have kept our application running so far. So if you want to keep accessing your application from the browser, you need to keep the application running and don't stop the server from here. So this is how you can stop the server, but don't stop if you wish to keep accessing the application. Now, if you scroll up here on the console, the number one thing, when you start the application, you will see this Spring banner that appears printed on the screen. Okay, and this is the first thing that you would notice. And this is a Spring ASCII art banner. That is what it's called. And you will also see the Spring Boot version being printed. Now, after you scroll down, you will see that our application is starting over here. And it indicates that the application is being started. Now, if you scroll back, you will see the environmental variables are being set over here. Okay. So here we don't have any active profile. Okay. And it's using the default profile over here. That is what it says. Now, what I mean by profile is you can set variables like environmental variables in application.properties file. You can define some properties over here. Okay. So we have not defined anything and we have not done anything over there. So it's picking up the default one. So that is a default property file that we have and that is being picked up and that's empty. All right. So environmental variables have been set. Now, after environmental variables have been set, Tomcat server is being started. So you can see over here, Tomcat is initialized with port 8080. Okay. Now, if you scroll down further after the initialization of Tomcat, you will see like servlet engine and everything is being initialized. Okay. And then the Tomcat was started on port 8080. All right. So this indicates that our application was ready to access. Okay. And then we went over to the browser and typed in the URL to access the API that we have created. Now, what happened when you tried to access the API? So when you typed in this URL over here in the browser, like localhost 8080/hello, the request was prepared, and this is a GET request that is being prepared from the web browser, and it was being sent to this particular port number on this particular URL. And you have the Tomcat listening over there. Okay, you have your web application listening over there. And once the request was sent, the request was accessed by the controller over here. So if you come over here, you can see that we had defined this controller, and this is what intercepted the request, and it processed and executed the method over here and returned the response. So this was the entire controller action that happened over here. So if I disable this, if I hide this, So you can see this controller came into picture and it served the request that was being fired right from the browser. Okay, and the response was sent. Now, when sending the response, this particular string was packaged into a HTTP response and it was shown onto the browser. All right. So this is what the entire process that happened. Okay. Now, there is a significant amount of to and fro that happened, and it happened within a fraction of seconds. Okay. Now, imagine if you have more layers defined, like if you have, this is a controller. Let's say if you have service and data access layer defined. So this all happens within a second. All right. So that's about how our application was executed. Let's talk a bit about how Spring Boot auto configuration works. So when you ran the Spring Boot application, you saw that there was a Tomcat server automatically set up. So this is one of the magics of auto configuration, and this magic is being done by Spring Boot auto configuration feature. So this was automatically configured, set up for you, and your application was deployed without you doing anything. We just created the project and imported it, and we wrote a simple controller function. Okay. The next thing I want to talk about is this dispatcher servlet that you see over here. So it said initializing servlet, dispatcher servlet. So dispatcher servlet is at the heart of any Spring MVC application, and it routes incoming requests to the appropriate controller methods. Okay. Now Spring Boot takes care of configuring this dispatcher servlet for you. It auto configures this servlet and it saves the effort of setting it up yourself. Okay. The next thing is the REST controller annotation. So REST controller annotation at the class level tells Spring Boot that this particular class is a controller, and it knows that it is a controller and it should handle the HTTP request. Therefore, it creates a bean for this. Okay. So a bean is nothing but an object that is being managed by Spring. Okay. So bean is created for this particular class in the application context, and it is being mapped to the controller. Okay. So this is all handled by Spring Boot. You just have to specify this annotation and tell Spring Boot that, hey, I will be defining all the endpoints in this particular file. Then we defined the get mapping annotation. So here in the controller class, Spring Boot auto configuration detects that get mapping annotation is specified for this particular URL, and it automatically executes or maps this particular method whenever you call this particular URL. And that is what we saw in action. Okay. So another thing that Spring Boot does for us is default error mapping. So if you access any endpoint other than what you have specified, so like we tried to access the root URL here. So you got this error page. Now this is by default generated error page, and this is pre-configured for you. Okay. It's a simple page. Now, if you want to have a custom page, you can definitely modify this. Okay. But this is also one of the magic of Spring Boot auto configuration. All right. So this is about Spring Boot auto configuration and how Spring Boot makes your life easy. Let us start talking about application properties. So in Spring Boot project, we saw this file application.properties, which exists under resources folder. Okay. Now this properties file is used to do configuration in Spring Boot. So you get a pre-configured application with Spring Boot, which you can then customize by using this particular file and specifying the key value pairs. Now, what are the key value pairs that you can specify over here? So for that, you will head over to the browser and you can search for application properties Spring Boot. So I can say application properties Spring Boot. Now you will see this first link over here, which is the official link that I have opened. And this depicts the common application properties that you can make use of. Okay. Now you can see this is supposed to be specified in application properties or application.yaml. So .properties is one format, and then there is another format called YAML format. So if you wish to use YAML format, you're free to use, but we will stick to .properties. So here are the properties that you can take a look at, and this is the categorization of the properties on the left hand side. Okay, so now you can scroll down, and if you scroll down a bit, if I say Control F, I'll say server dot. So if I select server properties, you can see this particular property here, server dot port. So this is a property that is used to specify the server port. So when you executed the Spring Boot application, it was by default accessible on 8080 port. Now, for some reasons, if you wish to customize the port, you can do that by specifying this particular property. Now let me show this to you. So I'll head over to our IDE and I'll say server dot port is equal to 9090. Okay, and I'll hit save, and now let me rerun the application. So I'll stop and rerun. Now if you check the console logs over here, you can see it's running on 9090. Okay, and if you go to the browser on 8080, if you refresh, you won't see anything. So it's like site cannot be reached. And if you enter 9090, like over here, you will see this error appear over here. Okay, and you can go to hello and you will see the endpoint working perfectly fine. So this way you can customize the defaults that you have got using this particular application.properties. Okay, so you can go over here and you can specify this. So I have some properties pre-written over here. So these are some of the properties that enable you to specify or configure a data source connection or a database connection. So you can say, so this is an example for configuring a database connection for MySQL database. Okay, and suppose you have a Spring Data JPA application which interacts with the database. So you can say the database URL is this, username is this, password is this, and you're specifying DDL auto update. Now what this means is you are telling Spring Boot to connect to this database. Okay, and this last property is telling Spring Boot to automatically create or update the database schema as needed. Okay, so with update, if there are any changes, it will simply update and create. Now, one important thing to note over here is that properties defined in the application.properties file can also be overridden by command line arguments. Okay, so you can run your application by command line, Spring Boot application. So since we are using an IDE, we are not doing that, but you can specify the argument as server.port is equal to 7070 while running. And this will make sure on command line the 9090 is overridden and it runs on 7070 instead, even though you have specified 9090 in your application.properties. So this way you can make use of application.properties file, okay, to like configure some pre-existing configuration that has been given to you by default by Spring Boot. Okay, so this is about application.properties. Let us talk about how you can create a post request. So the first thing, I will remove this server.port property and I'll let my application run on the default server. Okay, then I'll switch over to hello controller. So this is where we will be defining the post request. So we have a get request. Now post request is another type of request with which you can send some more information. Okay, so we have an annotation @get mapping to define a get mapping. Now what will it be for post? It will be post mapping, like so. And we will keep the URL same. So I'll say hello, like so. Now here I'll define the method. I'll say public, I'll say string, and I'll say hello post. So this is the method that will handle the post request. Okay. And here I'll return something. So I'll say hello. And let us return the name over here. Okay. And I'll add an exclamation at the end, like so. Now we are returning the name of the user or whatever is passed with this post request. Now where does this name come from? So we are getting an error right now that name is not defined. So we need to give this name as an input to this particular method. And this name should be accepted from this particular post request. So for that, I'm going to add an annotation over here. I'm going to say request body. So from the request body, give me string name here, like so. Okay. So in get, we did not have any parameters because get is just a method, like get is just a request call. Okay. But in post, you can send some data along with the request. Okay. So what we are saying is we are saying request body, and this request body annotation is used to indicate the request body that should be bound to the method parameter name. Okay. So with this, we are done defining the post mapping over here. Okay. Now what we can do is I'll rerun the application. But the question is, how do we access this using the browser? So we cannot access or we cannot execute a post request from the browser. And for that, we need a special tool, and a tool like Postman could help us do a post request to our application. All right. So far we have created the post request and we have returned the response. Now it's time that we should see it in action. So after defining the post mapping, we need to now figure out a way to execute this. So it's not possible to execute this from the browser like we did for get mapping, because we need to pass some additional information with the request. And there are some special tools that enable you to execute post queries. So for that, we are going to head over to the browser and I'm going to search for Postman. Now, Postman is a tool that enables you to work with APIs. So I'll go to Postman API platform and you can read and learn more about this particular tool. Okay. Or what I'm going to do is I am going to straight away download Postman. Okay. So I don't find the download link over here. Okay. So you have to go to product and you can say get started for free, and you will be taken to this page where you can download Postman. Now it will automatically detect your OS, and since I'm on Windows, it's telling me to download for Windows 64-bit, or you can even try it on web if you don't want to install it onto your system. And this is what it will look like, the interface. Okay. So what I'm going to do is I'm just going to download this particular tool for my Windows machine. So as you can see, it's being downloaded. Okay. And it's been done. Now what I can do is I'll double click on this and I'll get this installed onto my system. Okay. So I believe we downloaded the portable version. Okay. So it didn't install, but it just directly launched, and I'm going to add it to my taskbar as favorites. Okay. So you can hit download button over here. Okay. And download the respective version for your operating system and get it installed. The installation steps are very, very easy. Like it's just like any other software with no complexity. Once this is installed, so I already have this installed onto my system. So once you launch this for the first time, you will see an interface like this. Okay. Now you can see on the left hand side, you have this pane which talks about history. And this gives you the history of all the requests that you have executed. On the right hand side, you have this pane to execute a request. And along with the request, you can pass in additional parameters, authorization information, headers, body, and so on. So a lot of information you can send along with requests. And this particular tool is just for working with the APIs. So what I'm going to do is I'm going to head over to 8080. I'll copy this URL and we need to write a post query. So I'll paste this URL here. I have get selected over here and I'll say send. So you can even run the get request. As you can see the output. I'll just zoom in a bit. So the output is hello world, and this is the exact output that you were getting from the browser. Switch this to post. Okay. And now here in body, you need to add some body. So I'll select body. Okay. The reason I'm selecting body is we need to send the request body along with the request. So I need to add a body. So I'll go to body. Under none, I'll say raw. And I can specify anything over here. So I can specify hello Spring Boot. Like so. And I'll keep text selected and I'll say send. And you will see hello Spring Boot. And you can see 200 OK over here. So after execution, the default status code that you get after successful response is 200 OK. Okay. And you can see the time 16 milliseconds and this is the data. Okay. So here you can see the history appearing as well. Okay. So even if you fire get query, so if I fire a get query, you can see the status code as 200. Okay. So the status code for both was 200. Okay. All right. And you can see the response generated as well. So you can make use of Postman, okay, to play around with different API queries or different API requests, not queries. All right. And Postman is pretty handy and it is being used widely. All right. So that's about how you can work with post requests with Postman. Thank you. Hello everybody, welcome to this class. So this is going to be about the overview of the project that we are going to build. So this is what we are going to architect and this is what we are going to write code for. So we are going to build a job application, all right? And this application will be responsible for managing jobs. Now, jobs will be posted by companies and companies will have reviews. So typically on a job site, whenever you visit, you have a job posted and that job belongs to a particular company. And then reviews are there against that particular company as to how that workplace is. And this is usually posted by the employees who are the users of the website as well. So we're going to keep things simple. We're going to have controller, service, and repository. So let's start talking about the repository first. So we are going to store jobs. Okay. So jobs is going to go to the database. We will have company that will be stored in the database. And then we have review information against each company, which is going to be stored in the database. And we are going to have 3 repositories that will manage each one of them. All right. So we have job repository, company repository, and review repository. All right. Now, this repository will communicate with service and service will also communicate with this repository. So service is where the business logic will reside. So we will have like job service, company service, and review service. So we'll keep these 3 services different. Okay. They will be in different files and we will manage them separately because they are managing a particular entity in the application. So this is going to be about service. And then we will have the controller over here, which is responsible for handling the requests that we are getting from the users. So we will have 3 controller files over here or 3 controllers that we'll create. One is the job controller, the company controller, and the review controller. Now, it's pretty clear and evident from the diagram as to how this application will work, but I'll still give you a walkthrough. So there will be a request that will be triggered from the user, right, from the browser or from an application like Postman. Okay, so we are going to create APIs. So this is going to be a browser or like something like Postman. So we are going to get a request over here and controller is going to take hold of that request. and that request is going to be routed to the service, and service is going to be the place where our business logic resides, and service is going to make use of repository, and repository in turn will get the data from the database. So we are going to have a database as well that will be configured with this application. Now once the request hits database and it's processed by repository, we get a response back that you can see over here, and response is given back to the client or the user who is accessing our service right from the browser or from an app like Postman. And this entire application is going to be hosted on a server, okay, and we are going to access this on localhost. So this is what we are going to build, and this is a short overview of what our project is going to look like. So I hope this was useful. I'm excited to get started on this. So let us get started by setting up our project. So to set up the project, we are going to head over to our favorite website, start.spring.io, which is Spring Initializer. So if you are a Spring Boot developer or if you wish to become, this has to be your favorite website. Okay, so we are here, and let's get started with the configuration and setting up the properties that we need for the project. So I'll set up this as a Maven project. I'll keep this version selected, and if you see a different version number over here, that is perfectly fine. Okay, just make sure you don't select the snapshot version and you choose the latest one available over here, which is written without snapshot. Okay, so I'll choose this one because this is available right now. And like I said, if you see a different version, that's completely fine. Okay, just select that. The project will work normally as expected. Now group, I'll say com.embarkx. Okay, and artifact, I'll keep the artifact as first job app, something like this. And here I'll say job app to learn. Okay, or I'll just keep it as job application, something like this. All right, and I'll have the packaging as jar and Java version 17 selected. From the dependencies, I'll add one dependency, which is of Spring Web. Okay, so this is going to be a web application, and I'm just going to include one dependency, which indicates that we are building a web application, and it's going to include RESTful services, Spring MVC, and Tomcat as the embedded container as well. I would request you all to click generate and download the source code. So you will get a zip file, and you can store this zip file on your system at your preferred location. All right, so that's what you can do. So that's about setting up the project. So let us start talking about the job application that we are going to build, and let's set some expectations. So this is the app that we are building, and this is the complete app that we would be having. All right. So this has three layers: controller, you can see service, as well as repository, which in turn talks to the database. But to begin with, we are not going to implement all of this, but instead we are going to implement only this part. So we are going to have just the controller for job and the service for job, and we are not going to have the database right now. All right. And this is because we are going to go step by step. So we are first going to understand and learn how a controller works with the service and how the response travels back from the service to the user. Okay. So once we are done with this, we will move and we'll add a new layer, which will be the repository layer for job. And then eventually we'll do the same for the rest of the application, which means the company and the review as well. So we will be going step by step so that it is not overwhelming for you. Okay. And we'll keep things simple in the beginning, and then we will work incrementally to improve this application. Okay. So this is what I wanted to mention and set the expectations as to what we are going to do with the app. All right. So are you ready? Let's get started. So we set up everything on Spring Initializer, and we hit generate. Now hitting generate will give us this zip file, okay, which I have downloaded over here. Now what I will do is I will extract this file over here. Okay, I'll say extract here. And we have this project folder, my first job app, okay, which has all the files that is needed. Now what we need to do is we need to head over to Intellij IDEA. So in Intellij, I need to go over here to file. I need to say open, okay, and I need to select the first job app over here, okay, which is what we extracted right now. I'll say okay. And I'll get this opened in this window. You can even choose the new window if you wish to keep this window open. But I'll choose this window, okay, and this project will be closed, which I had opened initially. Now this is loading and it's resolving the dependencies, as you can see here at the bottom. Okay, I'll just close all of this. So now we have the entire project structure over here. Okay, now what I'm going to do is I'm going to head over to the Java folder. Okay, I have my package here and my first job application over here. Now what we are going to do is we are going to create the project structure. So I'm going to create a new folder. Okay, I'm going to say a new package and I'm going to say job over here. Okay, so all job related files will come in this particular folder. I'm just going to keep things a bit organized. And within job, I'm going to say new and I'm going to create a controller over here. And I'm going to call this file job controller. Like so. Okay. Just mind the spelling. So I'm calling this job controller because we are going to have more controllers in future, like the company controller and the review controller. All right. And I wish to keep things separate for company and review. So I'll call this job controller and I'll have all the endpoints related to job over here. So I'll say enter. Okay. I'll say don't ask again and it will add this file to the Git. All right. So we have created this file. Okay. Now what am I going to do? So I'll collapse this. Now here I'm going to start defining our controller over here. Okay. So I'm going to say public class, sorry, not class. I'm going to return something over here. So this is the endpoint that we are creating to return all the jobs. Okay. So I'm going to return something over here, a list of jobs it will be, and I'll say find all, like so. So whenever we call this particular endpoint, you get the list of all jobs. Okay. And I'll say all jobs, like so. Okay. Now over here, this list has to be of a particular type. Okay. And I'll say this list has to be of job type. Okay. Now job is something that we have not created and we have neither created this particular variable over here. Okay. So what we'll do is we'll first create the job class. Okay. So I'll say more actions. I'll say create class job. And it is asking me for the destination package over here. Okay. So whether you want to create it over here. So I'll say yes. And I'll say okay. So this class is created now. Okay. Now we need to define what all we need in this class and what all information we need to store against a particular job. So I'm going to say private. I'm going to add long ID. So first is we are going to have an ID which is unique to every job. Okay. Then I'm going to say private long title. So every job has a title. Then I'm going to say, okay, so title need not be long. It has to be string and I need to have string again and we need to have description. Okay. So I can say description over here. Then we need private string and I'll say min salary like so. And I'll duplicate this line and I'll make this as max salary. So what we are doing is we are collecting the salary range with the help of min salary and max salary. And I'll duplicate this line again. So a shortcut to duplicate in Intellij is Control D if you're on Windows and Command D if you're on Mac. Okay. So it will simply duplicate the line like this. Okay, so I'll just delete this. Now here, last thing I'll have is location. So these are the fields that every job is going to have. So it will have an ID, title, description, minimum salary, maximum salary, and a location. All right. So here in this class now, I wish to generate the constructor and some getter setters for these fields. So I'll right click, I'll say generate, and I'll say generate a constructor. I'll select everything. Okay. And I'll say okay. So we have a constructor over here. Okay. Now let us generate some getters and setters. Okay. So I'll say right click, generate getter and setter, select all. Okay. Done. So we have this class now set up. Okay. Now let us head over to job controller. Okay. We have job coming up over here. Now we are getting an error on list. Okay. Which is fine. So we need to import list. Okay. Now here what we need to do is, so we are returning this list. Okay. And we are returning this jobs. Now this is not defined. So we need to define this. So what I will do is I'll say private list, and this will be an object of job type like so, and I'll say jobs is equal to new array list like so. Okay, so initially, since we don't have a database, we are going to manage things with the help of a list over here. Okay, and here I'm going to map this to a mapping, and I'm going to say get mapping like so. Okay, and I'm going to say /jobs. Okay, so whenever we hit this URL, this method gets called, okay, which is find all, and you get the list of all the jobs that exist in the application. I'll hit save. Okay, and we can run this particular application. So I'll go over here and I'll say run. So we'll wait until this application is up and running, and you can see it's running now. Now we can head over to the local host and we can access this URL over here. So now here I'll go to localhost :8080 like so. And this will definitely give an error. I can say /jobs. Okay. So /jobs also gave an error. And what is the reason for the same? Okay. All right. So I got the reason. So one thing that we missed over here is we didn't map this particular controller as REST controller. So I need to say REST controller over here. I'll save and I'll rerun the application. So the application is up and running. Now if I go over here and if I hit refresh, you can see we get an empty list or an empty array. You can say this is an empty list in fact. So what we have done is we have defined an endpoint. So first we set up the entire project into Intellij, and then we defined an endpoint which gives us the list of all the jobs that exist in our application. And we are managing jobs right now with the help of a list. All right. So this is how you can fetch all the jobs in your application. Right now we are getting an empty list, which is fine. We don't have anything defined yet, which will define gradually. Okay. But this is how you can map an endpoint. So let us move forward in this job application and let us create an endpoint wherein we can add jobs into our job app. Okay. So we have one endpoint which gets all the jobs in our application. Now, what all can be the different endpoints that we will be building? So I'll paste some endpoints over here. Okay. So this is what we are going to be building. We are going to have a get endpoint, which is to get all the jobs. We have get endpoints followed by the ID, which will get a specific job by ID. So this is going to be a get request, wherein we append the ID and we are just going to get that particular ID. Then we have a post request using which we can create the job, a new job into our app. And then we have a delete request using which we can delete a job. Additionally, we have a put request using which we can update a specific job by ID. And then we have an endpoint using which we can get the company associated with an ID. But since we don't have the company entity as of now, I'm just going to skip this part for now. Okay. I'll just delete it from both the places. And here below, I have example API URLs as to how you can call these endpoints. So you have the base URL, which is localhost :8080 right now, /jobs. It will be get request and so on for all the other endpoints. So these are all the endpoints that I'm going to have pasted over here as a comment. Okay. And we are going to refer over here whenever we build a new endpoint. So we have this first endpoint done. Okay. It's a get request. You can see over here. And we even tried calling it from the browser. Okay. Using this. So now we need to add a new job into our application. Okay, now how do we do that? So we are going to use the same endpoint wherein we have defined the get request, but this time we are going to have a post request that is going to handle this particular endpoint, and it is going to take the details of the job and it is going to add it into our application. Okay, so let's head over. We'll scroll up over here. Okay, and to save time, or I don't think I'll copy this. Okay, the method is going to be a bit different. So I'll just end up typing over here. I'm going to say post mapping first. Okay. Post mapping. I'm going to say /jobs. Okay. And then I'm going to say public string create job. Okay. So this is going to be the method that we are going to define. And this is going to be add. Okay, so what we are doing is we have a list that is maintaining all the jobs. Okay, now whenever we get a request over here to add new jobs, we are simply going to get the job data and we are going to add it to this list. Okay, so I'm going to add the job over here. Okay, now we need to define this variable here. Okay, so this variable is not defined yet, so I'm going to accept this variable as a parameter. So I'm going to say job and job like so. And this is something that we are going to get along with the request, which is the post mapping. And I'm going to get in the form of request body. So I'm going to specify request body over here. Okay. And I'm going to have a string return over here, which is going to be a success message. So I'm going to say return. And the message can be job added successfully. Like this is just a simple message that I have. You can have any custom message of your choice. Okay. Now, what we are going to do is I'm going to run this. Okay. So this is getting deployed now and it's done. Okay. It started. Now, since this is a post request, we cannot use browser over here. Because with post request, we need to send some additional field. Like in this case, we have request body here. Okay. And there are a set of specific tools that we need for this. Okay. And one of such tool is Postman, which we have already installed on our system. Okay. So I'm going to make use of Postman over here and I'm going to use this to query our job application. Okay. So here, instead of hello, what I'm going to do is I'm going to modify this to job. Okay. Or the endpoint name was jobs. So I'm going to keep it jobs. And here in the body, instead of Spring Boot, I'm going to have some JSON over here. Okay. So this is going to accept the request in the form of JSON. Now we need to construct a JSON with all the fields that we have. All right. And how are we going to do that? So we can make use of a tool. Okay. So I can go over here and I can say JSON lint. So you can search for JSON lint and you will see this first link over here, which helps you create JSON. Okay. It helps you validate JSON in fact, but you can even use it to create JSON. Okay. And this is one of the best tools out there. All right. So I'm going to have a JSON out here. Okay. So here I am going to say, so what are the fields? We have fields like ID here. I can say I have title. Okay. I have description. like so. I have min salary, all right, and then I have max salary, like so. Okay, and I also have location. Okay, so I have all the fields that I have defined in my entity. Okay, so here this is the job class that I have, and here I have defined all these fields, and I have just added all of this over here. Okay, now I'm going to add values against these items. So I'm going to say ID is 1. Okay, title is like a new developer opening. So I can say, or I can say software engineer needed, like so. Now description is, I can say a test description, like so. Okay, and everything needs to end with a comma, so I'll also add a comma in the end. So we are constructing our JSON right now. Minimum salary is, like, let's say I'll say 30,000. Okay, and I'll say 40,000 here, maximum salary, like so. Okay, and then I'll have the location. So location you can have as New Jersey. Okay, once you're done with this, you can say validate JSON. So I can just say here, and you will get this message. It's a valid JSON. Okay, now if you're getting errors, you need to fix the issues. So if you miss any comma over here, let's say I miss a comma over here, and if I say validate, you'll get an error. Okay, so you can see it's also highlighting the error, like test description, and then you have directly min salary. So your test description and you have min salary, you are missing a comma here. Okay, and keep in mind the last thing over here, the location, does not end with a comma. Okay, if you add and if you say validate, you get an error. So just be careful about this. Okay, and have a same format. Okay, so that you have this valid message coming over here. Now we are going to copy this like so. I'm going to head over to Postman over here, and I'm going to paste this JSON in the body. So this is the body I have. So it's a post request. I've selected post. This is the URL. Within body, I have pasted this over here. I've selected raw. Okay. Now here instead of text, I need to change this to JSON because we are sending JSON data over here. All right. And with this, I can say send. Now the moment I say send, I get this message, job added successfully. Okay. Now if we head over to our browser and if we call this URL, you can see this is what is being sent as the response. And this is coming directly from our application, which indicates that the job that we had sent with ID 1, title software engineer needed, this was the description. So all of this has been saved into our application. Okay, so it's working perfectly fine. All right, and if you go over here in our application, if you click on run, okay, if you scroll down, okay, we don't have any error message or anything over here, which means that it's been added. All right, now you can even run this get request right from Postman, so that you don't need to juggle between two tabs over here. Okay, so I can say new HTTP request. So click on new over here. On the top left, you have this new, and you make sure you have get selected, paste this over here, and you get a well formatted JSON. Okay, and you also get 200 OK. So this is working perfectly fine. You can add as many jobs you want. So I can send this request once again. Okay, and you will see 2 jobs coming up over here. Okay, so this is how you can add jobs. So that is about this class, and we're done setting up the post request wherein we can add a new job into our application. So I hope you all enjoyed this, and I shall see you all soon. Thank you. Hello everybody, welcome to this class. So in this lecture, we are going to do some setup related work with Postman. Of course, we have installed Postman. We are calling the APIs. It's working well. But there is some additional setup that I believe needs to be done. And if you do it, it would be beneficial for you. So what is happening right now is we are seeing this history tab and all the requests that we have created over here. Now, the thing is, we are not saving these requests. Okay, so if you close this, it is coming in the history format. Okay, so if I close all the tabs, it's coming over here in the history form. And if you delete Postman or anything happens, you have essentially deleted all these requests that you have created. And you might want to reuse these requests later on or whenever you are testing something. Okay, so what we can do is we can save these requests. Okay, now what I would recommend is you can say add to collection over here. Okay, you can see this button over here. Now, what is this concept of collection over here? So in Postman, you can save a request within collection. So collection is nothing but like a group of all the API requests within Postman. So within this collection, you can have like 10 API requests that have been saved by you, for example. Okay, and you can categorize API requests that you are saving in the form of collections. But you cannot add anything to collection right now. You need to create an account. So I would recommend you create an account over here. Okay, you can either click on this add collection, or you can say sign in if you already have an account, or you can say create an account from here. Okay, so it will take me to the browser over here, and I can say I can put in my email. So I'll say embarkxofficial@gmail.com, or instead I can just sign up using Google. Okay, so I'll just copy this email so that I don't have to type in again, and I'll say sign up with Google. I'll use another account. Okay, I'll add embarkx and I'll just sign up over here. So I've entered my password, and so basically you will be prompted with this particular pop-up here wherein you would be asked to accept the license. You can read through the license if you wish to, but I'll say accept. Okay, and we'll wait for the redirect and it will show you this pop-up now. So do you want to open this application? So I'll say open Postman. And once you open this, okay, so you will notice that you will be logged in. So this is taking a bit of time. Okay, so it's saying welcome to Postman and tell us a bit about yourself. So it is now onboarding us to this particular application. So now I'll say my name as embarkx official. I'll just keep it embarkx, and my role is I am, let's say, a full stack developer. I'll get started. Okay, and I'll say got it. Okay, now we'll have a history tab over here. So suddenly you will see we didn't have all these tabs. Okay, and now you can see we have tabs like collection. Okay, we have tabs like environments over here on the left hand side. You have history as well. All right, and what you can do is you can go to history. Okay, we have just added this particular request here, and you can see the save button enabled over here now after you logged in. Okay, so you can definitely save this, and it will ask you where you want to save this request. Okay, so it's telling you that you don't have any collections, and collections let you group related requests. So if you have multiple API requests that you are doing that are for a particular application, you can group them together, okay, using a collection. All right, now you can say create a collection over here because I don't have a collection, and I can name my collection. So I can say job application over here. I'll say create. Okay, and the save button is enabled now. Okay, I'll say save. So you can see this has now been saved to the collection. So this was the post request. I'll just close this. Okay, this is another post request. And I can go to the history and I can simply save the get request as well. Okay, here is a get request. So I'll save this get request and I'll save it to the collection. The collection is selected now by default. You can add a description as well if you wish to. Okay, but I won't. So I'll just get this saved. Okay, I'll save this hello application as well. So these API requests. Okay, and I'll change this. I'll create a new collection and I'll say hello world app, like so. This is saved, and I'll save the get request as well. You can save everything you need. Okay. And if you go to collections now, collections tab, you will see. So if I right click over here on the API request tab, I can close all the tabs. Okay. Now over here under collection, you will see these collections here, okay, which have been created. So these are like folder, and this does a really good job of organizing all the APIs. Okay. So you can click on this, you can have this saved. Okay. You can modify this and you can save it again. You can create a copy of this. Okay. So I can go over here as well. Click on 3 dots, duplicate this. Okay. You can duplicate this as well. So all these are the possibilities with Postman, and you should leverage these possibilities. Okay. So if something happens to Postman, and if you have not signed up and if you have not saved the API request, you have to create the API request again. Okay. You need to write the JSON again. It takes time. Okay. But this is much more easier, and we have this functionality, and you can leverage this by doing a simple free sign up. All right. So this is about Postman in how you can save the API requests. Welcome to this class. So let us start setting up the job service. So right now we have job control over here. And what is happening is we are handling the logic of adding job into our controller. We don't have a service created yet. All right. So what we are going to do is we are going to create a new service. So I'm going to go to our project structure here. Okay. And here I'm going to add a new file under job package, and I'm going to call this class as job service, like so. Okay. Now this service can be a class. Okay. But if you want to promote loose coupling, you need to define this as an interface. So I'll just change this keyword over here as an interface. Okay. And I'll have the implementation for this in a package. So I'll have a package again over here. I'll call this package as IMPL. Okay. And I'll create a new class here, and I'll call this as job service implementation, like so. So we created this as an interface to promote loose coupling. Okay. Now this depends on your requirements. Okay. You can have your service, you can have this as a class and have all the code written over here. But if you want to promote loose coupling and have some modularity in your code base, you can consider separating the interface and the implementation. And that is what I have chosen. All right. So here within job service, you will have like the methods defined. Now these are the methods that will mention like what all methods whoever implements this particular interface needs to define. Okay. So the first one I'll say here, find all. So this is what will return all the jobs. Okay. Then I'll have create a job. Okay. And this is the one that will create the job for us. Okay. Now I'll specify the return type. I'll say list here, and I'll add the return type as job, like so. Now here for create job, I'll say void, because we don't need to add anything to return over here. Okay. Now this is done. The interface definition is done. Okay. What we can do now is we can head over to this implementation class, and I'll implement the job service here, like so. Now, of course, if you're implementing an interface, you are going to get an error, and it will ask you to implement all the methods that exist within this particular interface. So I'll say like I want to implement, and it will create this boilerplate code for me. Okay. And I need to provide my own implementation here. Okay. Now what I need to do is I need to add the logic which I had written in the controller over here. Okay. And I need to move this logic into the service. All right. And what I can do is I'll move this declaration first. Okay. So I'll have a declaration here like so. Okay. And I'll return the jobs. And here, instead of create, okay, so this create job will have a parameter which we have not defined. Okay, so we need to have a parameter. So I'll define the parameter in the interface as well. Okay, I'll say job, and here I'll say job like so. Okay, and I'll say jobs dot add job like so. Okay, so we have added this, and I'll just format this code. Okay, so yeah, we are done defining the service over here. Okay, now we can refactor the controller as well, because since we have moved all the logic to like add and return the job into the service, we need some refactoring here. So I'll delete this over here. We don't need this. Now instead of get mapping here, what I'm going to do is I'm going to call job service. Okay, so I can say, but before calling job service, I'll also need a job service object. So I'll say private job service. So I'll create an object of the interface, and I'll call this as job service like so. Okay, and I'll say over here job service dot find all. Okay, and here also job service, instead of add, the method name is create a job. Okay, so this is something that we'll do. Now the thing is, this is not initialized. Okay, we have not initialized job service yet. Now how do we initialize? Now this is where Spring Boot's magic comes into picture. Okay, and you'll see how it makes your life easy. So now if you go to job service implementation over here, okay, this is a service, and we need to tell Spring Boot that, hey, this class is a service, and you do that by using an annotation called service. You can see this annotation here. We'll add this annotation, and you'll see this import statement being added. Okay, like so. Now this is done. Now when you mark this as a service, what Spring Boot does is it will make this thing available on the runtime, and it will inject it to the controller. Now how does it inject? So we can say right click, I'll say generate. We just need to give or define a constructor over here, and during runtime Spring Boot will take care of making the job service object available to this particular controller, and it will get initialized over here. So we don't need to do tight coupling. Okay, so this is very loosely coupled. All right, and this is all done by Spring Boot. Like, we are just following the convention, and Spring Boot is doing the job behind the scenes. All right, so this is done. All right, now what we have done is we have refactored our code to add a service. Okay, and this service will help us by adding the job and also fetching the jobs. So I'll rerun this application. Let us see. So the application is started. Let us head over to Postman. Okay, so here in Postman, I'll say get the jobs first. So this is giving me all the jobs, and there are no jobs defined yet. Now I'll say create this job. Okay, so let us create. You can see job added successfully. Now let us fetch the jobs. Okay, you can see the jobs we had added, like the job we had added is being returned to us in the API. So this is working perfectly fine, and refactoring has been successful. So we have now moved all the logic that we had written. We had just a little bit of logic which we have moved to this service class, and now service is responsible for working on this. Okay, now one thing I wanted to show you, what happens if you skip the ID. Okay, so let us say if I try to add a job without ID. Okay, let me add this one. It got added successfully. Now if I try to get over here, and if I expand this a bit, you will see we have one job with ID 1 and another job with ID null. So null IDs are being added, and technically this should not be the case. Like, the application should take the responsibility of generating unique IDs to whatever objects are being created. All right. We should not rely on user, because user might give a duplicate ID or something like that. So this brings us to the point as to where we need to manage the IDs. All right. So that's about this class. Let us see how we can go forward with this app. Welcome back. So right now we have a small problem in our application. If we are sending a job with no ID, it is being added as null. Okay, it's a small problem. And what I want to do is, I want you all to take this up as a small challenge wherein you try to fix this problem. Okay, I'm also going to give you some hints as to how you can fix this. So if you head over to your service where you are adding the job. So this is the service class. So this is a service class where we are adding the job. So before adding the job, okay, you need to maintain an ID which gets incremented every time you add a new job. And this is something that can be managed by a class level variable. Okay, so you can attempt this particular challenge, come back and watch the solution. Welcome back. So I hope you all had a chance to attempt this one. All right. I'll start solving this myself and then you can compare this with your solution. So you need to have a list ID basically being maintained in your class. So you can say private long and you can say next ID. So this is a variable that I am using to keep track of ID that we have in our application. Okay, I'll say 1L over here. Now this is long value. That is why I'm appending it with L. Now before adding the jobs over here, you can say job dot set ID. So we have a setter and we are going to set this ID to our job. Okay, and we are going to say next ID plus plus. Okay, so what this will do is it will set the current ID to the job object and then it will increment it by 1. So the next object that we have gets the incremented value and then this value is again incremented. Okay, so I hope this clarifies and we will rerun our application now. Let us see how this goes. So the application is started. Let's head over to Postman. So in Postman, I'll go to get request first. So since we reran our application, okay, the job list is reset. So I'll create a new job, but this time without sending an ID. Okay, you got 200. Okay. And now if you say send, you get 1 as the ID. Okay. Now whatever ID you pass will be overridden. Okay. So if I press Ctrl Z and I bring back the ID field that I had present earlier. Okay. And if I keep the ID as 1, okay, and I say software engineer with ID 1, just to identify this particular object. And if I say send, you will see you get successful message again. Now if you go to get request and if you say get, you will see the ID that we had passed for this object is overridden with 2. Okay. So this is what happens. So basically what is happening is whatever you are passing over here is being overridden by the code or the setter that we have used in our application. All right, which is perfectly fine. We want to have control over the IDs and we don't want to give the control of generating IDs to the end user. Typically, that is not the case. If you're signing up for a bank account, you have a customer ID which is in the control of the bank and it's a ID that is generated with the logic that is set by the bank, and you as a user cannot decide that. It would be like just giving away the control. It would not be correct, basically telling users to like select the IDs. Okay, so this is something that application needs to have control on, and that is something that we have built over here. All right. So that's about IDs and how you can generate it on the fly from your application. Let us start talking about how can you start fetching a single job. So in our application, we have defined the all jobs endpoint. Now we need a way to get a single job or a specific job by ID. So every job in our application has this field ID. And we want a way to get a particular job using this unique identifier. All right. And we are going to achieve this with the help of a GET request. Okay. And we are going to have a parameter in the URL. So what is this parameter in the URL? So if you head over to your browser, so let me open up the browser here. Okay. Let me go to Google. Now on Google, if you search for Java, you will see your search query being passed in the URL. You can see over here. Okay. Now if I change this particular thing here, I can say Java 17 and search, you will see the search query also being updated over here. So this is the query, like the parameter. So whatever user has searched has been passed in the URL that is visible to the user. Okay. This is fetched by the Google server. Okay. So whenever this request hits Google server, there is a piece of code that checks for this particular parameter and it scans the database for the list of search results and it returns to the browser. So that is how this thing works. And you can see this clearly, this is being passed in the URL. Okay. And this is being passed in the form of a query parameter. Now, another thing, if you go to Amazon.com, okay, if you select any product, let's say I select Kindle, everything has a unique identifier over here. So this is the product ID or a unique identifier. So if I copy this and if I search on the entire page, you can see this is the SYN of the product, okay, which is one of the unique identifiers for anything on Amazon or any product on Amazon. Now, if you scroll down and if you open some other product, so let me check where the suggestions are. So let's say if I open this particular novel, you will see this has a different identifier. Okay. And if I copy and search this on the entire web page, you will see this is the ASIN again. Okay. So what is happening is this is the URL. Okay. Then you have the URL slug. Okay. Or this is the URL that is being constructed using the title over here. And then you have DP. And then you have this unique identifier which gives you the product. Now once this URL is hit, okay, even if you remove all this like a trailing thing, so let us say if I select all of this entire piece, and if I delete this, you will still be able to get the result. Okay, so those were some additional parameters that were being passed as to how you landed on this particular page, whether you came here through suggestions and so on, okay, or you clicked on ad and so on. So Amazon keeps track of all of this. So here you have this changing dynamically, okay. So the point I'm trying to make here is this is a URL and you have something dynamic in the URL which tells you what product to return to the user, okay. Likewise, in our application, okay, here you have jobs, which is returning all the job, okay, but you really want a new request over here. So I'll duplicate this, okay, and now here you can say job /1. So this should technically return the job having one ID. So here you have a job with ID 1, like you can see. So technically JSON should be returned when you fire this particular request. Okay. So this is what we need to define, and this can keep on changing. So this will change to 1, this can be 2, or this can be 1000. So any ID can be passed, and this part of the URL is completely dynamic, like we saw in the case of Amazon and Google. Okay, so this particular thing that is dynamic in the URL is known as query parameters. Okay, so we'll head over to our code and we will define this dynamic thing, okay, which will keep on changing. Okay, so I'll come over here and I'll say over here, I'll say public. So this will be a public method. And what will it return? So here for find all, we are returning the list of jobs. But since here we are fetching a particular job, this will just return the job object. Okay, and it will say get job by ID, like so. Okay, this method name can be anything, it's perfectly fine. And here you will say long ID. So I'll say long and I'll get ID. Now here we will need to write some logic, okay, which we will write in shortly, okay, but before that we will have to map this particular method to the URL. So I'll say get mapping, like so, here, and you will say job. So we need the URL as jobs, so jobs slash ID. So I'll say jobs slash, and I'll define this curly brace like so, and I'll say ID over here. So whenever you mention something like this, okay, this tells Spring Boot that this is dynamic, okay, and this is the variable name. So whatever comes in over here in this part of the URL should be assigned to this particular variable, and that is what we are accepting over here. Now to accept this properly, we need to add an annotation over here, which is called as path variable. So path variable makes sure that whatever variable you are getting in the URL path is being assigned to this particular variable that you have defined with this annotation. Okay, so once you have just defined this, Spring Boot will take care of the rest. So whenever you call the URL with this particular or any ID in this particular format, it will make sure that this variable or this method parameter has that value assigned, and it can be used within the method then, right? So I hope this makes sense. Now let's start writing the logic over here. So I'll say job is equal to, I'll get job service dot, and I'll say get job by ID. So we are going to have this method defined, okay, and I'll pass in this parameter. Okay, now this method does not exist, so I'll say create this method, and this method is created now. Okay, now once this method is created over here in the interface, and if you go to this particular class, you're going to start getting an error, and the error is you need to implement that method. So I'll say implement, okay, and you can see the implementation code come up over here. All right, now here what we need to do is we have an array list of jobs mentioned over here, okay, and here we need to fetch the job with this particular ID, and we need to return it to the controller. Now how do we do that? So we will be doing this with the help of a for loop. Okay, so I'll say for, okay, and we can have a for each loop in fact, and I'll say for each job, okay, and then I'll say from jobs. So this is the list that we are working with, and then I'll say if job dot get ID. So for every job we are comparing the ID dot equals. So if it equals this ID, okay, then what we need to do is we need to return the job. Return job, like so. Okay, and if the match is not found, we return null, like so. Now we are getting some error over here, missing return statement. Okay, so what is exactly missing over here? All right, so we are missing one round curly braces. Okay, so we have added the curly brace and still we have an error. So let me see. Okay, so this return statement needs to come outside the for loop. Like so. Okay. So what we are doing is, with the help of for each loop, we are iterating through the list and we are comparing every ID with that of what we have got from the query parameter. Okay. And we are returning the job over here. Now this is being returned to the controller, and controller takes this in this variable here and it will return it to the user. So I'll say return job like so. Okay. So once we are done with this, what we can do is we can rerun this application and we can check this output into the Postman. So the application is started. Okay. Now over here, I'll hit save. Okay. And I'll say send. Now you can see over here. Okay. So we didn't get any job because none of the job exists right now. Okay. Which is perfectly fine. So I will have the name changed over here. Okay, so since we duplicated this request, the name was not same, and I'll hit save. Now I'll create a job over here. So I'll send this. Okay, and then I'll go over here and I'll get that job. And you can see we are able to get this particular job. Now if I create one more job over here with ID, let's say 2. Okay, and if I hit send, job added successfully. And now if I say 1, you get the one with ID 1. And if I change this to 2, you get the one with ID 2. So this is indeed working perfectly fine. All right. Now if I make this as 3, you don't get any response. Okay. So I need to have some response over here. Okay. Now how do I add a response? So I can add some basic validation over here. I can say if job. So I'll do some comparison over here. I'll say if job not equal to null. Okay. So if the job is not found, we'll get null as the result and we'll return job over here. Okay. Otherwise, what we will do is we'll return new job over here. I'll say 1L. Okay. I'll say test job. And I'll just have some dummy values because I cannot return a string over here. Because if I add a string, the return type of this method is job. So I'll get an error over here. Okay. So I'll just keep everything as test. Okay. Like this can also be 2000, 2000, like so. Okay. Or this needs to be string like so. Okay. And press enter so that it's visible in a single screen. And I'll have the location as well added. Like so. Okay. Now if I redeploy, let me rerun this. So the application is deployed. Now if I head over to Postman, let me add some jobs. Okay, I added 1, 2, and 3 jobs. Now if I go over here, if I say 3, I get the one with ID 3. If I say 31, I get, okay, test job, and this is a dummy response. Okay, so we can add, like instead of test job, we can say not found, but that is not the right way. Like you're getting the response in the job format. Okay, so this is not the right way of doing, but we will fix this shortly. All right. But what I want to highlight over here is when you enter or when you try to find a job that does not exist in the database, you're getting the response code as 200 OK, which should be 404. So 404 not found. That is what should come over here, ideally. Because even if you are not able to find that particular resource with ID 31, you're still getting 200 OK. Okay. So this needs to be customized. All right. There has to be some enhancements that we need to do in our source code. But for now, we'll pause over here and we'll come back to this shortly. Hello, everybody. Let's start talking about the response code now. So we noticed that if you give an ID that does not exist in the database or any random ID, and if you say send, you still get 200 OK, and you have to pass this response over here, which is a job object. Okay. You might want to have a better control over this. Okay, this is not how it should be in real world applications, right? You should have a message ideally if the job is not found. So you should have a message like job not found, and the code should be 404. And if it's found, then you should have this JSON which relates to job. How do you control this? So this can be controlled better with the help of response entity. Now, what is response entity? So response entity is a class in Spring, and it's a wrapper that represents the entire HTTP response. So here you're seeing an output. Okay, when you send a request to the server, you are seeing a response which is being visible to you over the HTTP protocol. It's an HTTP request, right? So the response you are getting is an HTTP response. Now, response entity is a class that is available in Spring, which wraps this particular response and gives you a better control over the response. It allows you to customize the status codes, like if you wish to, and you can even have messages out there. All right. So essentially what I mean over here is it's allowing you to customize the HTTP response. Okay. And that is one of the important benefits and the problem that it solves. So here we are facing this problem and we can use this as a solution. And the benefit of this is, number one, the customization of response. It allows you also to handle the response in a flexible way. Okay. So you can handle different scenarios, different conditions within your controller method and return different status codes based on the success or failure of the operation. Okay. And you can include additional information in the response as well, if needed. All right. So this is all you can do with the help of this particular class. And using this class has one more benefit. So one benefit is customization of response. Second is it allows you to be flexible with your response handling. Third one, it enables you to do consistent API design. Okay, so by using this, let's say response entity class, you have a consistent design across the API. And how? That is something we'll see shortly. Now, this is about HTTP response entity. Okay. Now, if you go over here, it's a class. So if I go to the bottom of the page, if I type in HTTP, okay, it won't show up over here. I need to type in inside a method also. Okay. So I'll type in over here, HTTP response. Sorry, not HTTP response, it's response entity only. Like so. So you can see this is coming in from org.springframework.http. Okay, that is the entire package. Okay, now there is one more class that you need to know, okay, which is HTTP status, and it is coming in from the same package org.springframework.http. Now what does this class do? So this class is an enumeration, you can say, of all the HTTP codes that are present in an HTTP protocol and that you need to use with an HTTP response. Okay, so if I enter HTTP status, okay, and if I, let's say, press Control on Windows, or you can press Command on Mac and hover on this. Okay, so this will be converted into a link and you can go inside this particular class. So this class opens up. Okay, it's a .class file, as you can see over here, and it's being opened over here in the human readable format. Now, if you take a look over here, this is an enum object. It's enum. It implements status code, and you can see all the status codes over here. Like you can see accepted, created, 200 OK. 200 OK means successful, and the reason phrase is OK. The reason phrase over here is created. This is accepted, and so on. Okay. If you scroll down, you have like the status codes beginning from 3, like 300, 301, which is moved permanently, redirect, and so on. If you scroll down, you have 400 as well, like starting from 4. So bad request, unauthorized, and so on. So all the status codes are present in this particular, like this is one of the enum objects, not a class. So enum objects which you can use. Okay. And you can make use of this in your code to have better control on the response. Now, using this enables you to have one, standardization of status codes. It enables readability and maintainability as well. So your code becomes much more readable, self-explanatory as to what is happening, and we'll see this shortly in fact, okay? And it enhances the maintainability and eliminating the need to remember a specific number of status code. Okay, so it's all available within this particular thing here, HTTP status, and you don't need to remember the codes. It's all in there. Okay, it also helps you with error handling, error mapping. Okay, so there are these benefits. Okay, and we'll see all of this shortly. So let's start using this. Okay, so right now there is no standardization. If you take a look at our API, okay, the API that we have built. So here we are returning a job object. Now here we wish to return a string response, but we couldn't, okay, because the return type is job. Now here we wish to have, we are returning a string again, so there is no consistency. So what we are going to do is we are going to update the controller to return response entity. All right. So let's start with get job over here. Okay, so this is get job by ID. Okay. Now, instead of returning the job, I'm going to say response entity. Okay. And I'm going to have a pair of open and close brackets, and I'm going to say job like so. Okay. Now, we have added response entity and an import statement will be added over here. Okay. So you can see this response entity import statement. Okay. Now, I need to remove this red marks. Okay, so here instead of returning the job, I need to say new response entity. Okay, and I need to return the job over here like so. All right, now it's giving me an error again. Okay, and it is asking you, okay, so the error is because we are not passing the HTTP status. So I need to say HTTP status dot, and you can see all the status code appear over here. Okay, now the status code is okay. Okay, so I'll specify okay over here and the error goes away. All right, so what we are doing is we are creating a response over here with job object and the status code as well. So we are having a better control now on what is being shown to the user. So we'll modify this thing also. Okay, for the same, I'll say new response entity here, and I'll say HTTP status not found like so. All right, so this is done. All right, now I can hit save, and now let us rerun our application. So the application is started. Now head over to Postman. Now let us try accessing 31. If I say 31, you can see here 404 not found. All right, it's no longer 200. Okay. Okay. Now if I, let's say, create a job over here, and if I try to get a job with ID 1, and if I say send, you can see we have 200. Okay, and the job object. So this is working perfectly fine for different scenarios, like whether a job exists and it does not exist. All right. Now what you can do is you can even update the other controller methods in order to have a consistent design. Okay. So here we have added new response entity. I'll copy this. Okay. You can go over here. So let us do it for the create job method here. And I'm going to say response entity. This is going to be a string. Okay. And I can say new response entity here like so, and I'll pass in this like so. Okay, and I'll mention HTTP status dot okay. And there is one more way of like just rewriting the syntax. Okay, I'll do this for like all jobs over here. Okay, I can say response entity. I'll add this or wrap this within response entity. And now over here, I'll say response entity dot. So there are a lot of methods over here. You can see, okay, status, okay. You can see okay also as a method. Create is also a method created. So I'll say okay, like so. And I'll add this as the parameter, like so. Okay. So this is another way of doing the same thing which we did over here. Either you pass HTTP status okay, or you use the method within response entity class. It's perfectly fine. So I'll rerun this. Okay. Now after rerunning, let us test this. So we try to get all the jobs. You get 200 okay. Okay. Here we try to create a job. So you get 200 okay. Here you can even have, instead of 200 okay, so you can even have, since we are creating a job, you can say created as well, which is okay. Like if you wish to have created as well, otherwise 200 okay is also fine. Okay. And now if you get jobs over here, you'll get all the jobs with 200 okay. So what happened now is we have better control over like what user sees in the form of status codes, the messages as well. Okay. And we have achieved all of this with the help of response entity and HTTP status. All right. So you can see there is also a very good consistency in the API design. So everything is returning response entity and there is a consistent format that is being followed throughout. Now, if this code base grows really huge, okay, it's really important. Like that is when consistency comes into play. Okay. You don't want code that is scattered and is not consistent at all. Okay. It would be difficult for others to read and understand what's happening. All right. And you also now have a really good control over the status codes. So that's about response entity and HTTP status and all about having control over the response. Welcome to this class. So let us keep building our job application. Right now we have quite a few endpoints done and we have few endpoints pending. For example, we have this delete endpoint that we have not defined yet. And using this endpoint, a user who is using our application and calling the APIs should be able to delete a specific job by ID. And here is how this particular URL will be called. So we have defined a get, like two get requests, one post, and now it's time to define a delete request. So what I would want you all to do is I would want you all to take this up as a challenge. So like we have defined a get request, a post request, you can define a delete request which accepts the ID as the query parameters from the user, from the URL, and then you use that to pass it on to service, and service in turn deletes the job by ID and it actually gives a success response. All right. And if this particular job is not found, like for which the ID is received, you send out a 404 or not found status code. So it's pretty simple. It should not be a lot of challenge, but I would request you all to give this an attempt. If you're able to solve, that's perfectly fine and congratulations. But if you're not able to, that's also okay. So the goal of this challenge is not that you should be able to solve this challenge successfully. Of course, you should be, but the goal right now here is to get you started to write code by yourself. You should do the thinking and this will give you immense confidence in your daily job. Trust me, guys. So attempt this challenge. Even if you're not able to, that's perfectly fine. Like if you get errors and if you're not able to solve this one entirely, but give this an attempt. That will give you confidence. All right. So pause the video right now, come back and watch me solve this challenge. So welcome back. I hope you all got a chance. And how did it go? So let us solve this by ourselves. Okay. So I have a method over here which gets the job by ID. So what I'm going to do is I'm going to create another method which will delete the job by ID. Okay, and I'm going to say public. I'll say response entity again because I'm going to return response entity, and I'm going to say string, and I'm going to say delete job. Okay, so delete job. And over here, we are going to accept a long ID variable, which will be passed in as a parameter over here. Okay. Now here, I need to say boolean, and I need to say create a variable boolean deleted. Now what I'm going to do is I'm going to pass this ID to the service, and service will take care of the deletion. If the deletion is successful, it will return true. If it's not, it will return false. And that's the exact reason why I have created this variable boolean. Okay, now I can say job service dot delete job by ID. Now we need to create this method. We are going to see all red marks, which is perfectly fine. This is going to last for a while. This will go away as we fix the errors. So I'll say if deleted. Okay, so this should be deleted. Okay, and if this is deleted, then you can return new response entity, and what I will say is I'll say job deleted successfully, like so. Okay, and I can say HTTP status okay. So this is done. This is the successful scenario. Now what happens if this is not deleted or the job is not found? So you can say return new response entity, and I can say HTTP status dot not found, like so. Okay, so this is done. We have defined the logic in the controller which handles the deletion of a particular job for which you have received the ID. Now we need to get the ID from the path variable. Okay, and we need to map this to the URL. Now how are we going to map this? So we can say get mapping, post mapping, or we have something called as delete mapping. So you can see the suggestion over here, delete mapping. We are going to make use of this. This indicates that this is a delete request. Okay, I can say jobs slash, and I'll mention ID over here, like so. Okay, so this has been added and this method is complete. Now we can head over to service. So we need to create this method delete job by ID. So I'll hover on this and you'll see this option which is presented to you by Intellij. So what you can do is you can select this and save some keystrokes. So I'll use this, and you can see the method with the appropriate return type is created. Now this is created in the interface. What I need to do is I need to go to the implementation class, scroll up, and here you'll see an error, which is of course you need to implement the method which you have just defined. So I'll say implement methods, and we will implement this particular method over here. Okay, so this is a method where we are going to actually write our delete code. Okay, so what am I going to do is, what we need to do, we need to get this ID, we need to search for the job with this ID, and then we need to remove it from the list. Okay, so I'm going to say iterator job. Okay, this is something. I'm going to say iterator is equal to jobs dot iterator. So I'm going to create a new iterator object over here to iterate over jobs. All right. Now I'm going to say while iterator dot has next. Okay. And now within this while loop, what I'm going to do is I'm going to get the job. So I'm going to say job is equal to iterator dot next, like so. Okay, let me end this with the semicolon. So we have the job over here and we are just traversing through the list. Okay, now I'm going to say if job dot get ID here dot equals and I'll say ID like so. I'll say iterator dot remove. So I'll remove this particular object and I'll return true. So we will return once we find the object or the item with this particular ID over here. So once this is removed, we return true. And if this is not removed in the end, which means, so if this loop gets exhausted, it means that there is no job with this particular ID, and hence we need to return false. And if we return false, what happens? Here, this condition fails and this is returned, which means not found. All right. So I hope you have a clarity now. So we have created this method first, delete job by ID. We have declared this in the interface. Then we implemented this into our implementation class, which is the job service implementation. Now here, with the help of iterator, we are traversing through the list and we are fetching every item or every object that we have in the list. And we are assigning it to this job object. Then we compare the ID. If ID matches, remove. And once it's removed, return true. And if there is no match, you return false. And controller logic is fairly simple. Okay. So I'll just run this. Okay. So in controller, we are just getting this Boolean value and we are playing on this Boolean value. Okay. So if the Boolean is true, then we say it's deleted, or else we say not found. So application is started. Let's head over to our Postman. And now over here, what we need to do is we need to duplicate this request. So we need a delete request, right? Okay, so I'll change this to delete. I'll edit this. So this is the name that I wish to have a good name. And now we will execute this query. So we'll say 1. Okay, so we got an error. Now, why did we get an error? So the error is because there are no jobs right now in the list and there is no job with ID 1. So if you try to get a job with ID 1, you don't get any response. You get 404 instead, which means that a job with this ID does not exist, right? Now here, I'll create a job. Okay, so this is the job with ID 1. I'll hit save. Okay, this is gone. Now, if you say get 1, you have a job. Okay, let me add one more. I'll say job with ID 2. It added successfully. And now if you get all the jobs, you can see there are 2 jobs now. Okay, one with ID 1 and the other one with ID 2. Now what I'm going to do is, let us come over here to delete request. Let's delete the one with ID 1. So I'll fire this query and you get 200 OK. Okay. If you run this again, you get not found because it's deleted now. Okay. How do you verify it's deleted? You come over here, you fetch all the jobs. Okay. So if you say, give me all the jobs, you can see the one with the ID 1 is removed from this array and you just have one job with the ID 2. So I hope this was okay and I hope you all have a complete clarity as to how this worked. Now delete API also works in a similar way as other APIs. Okay, it uses response entity class. Okay, and if you are not able to find, or if the application is not able to find a job with a particular ID, it will return not found, else it will return 200 OK. So that's about the delete functionality that we had to implement. Hello everybody, welcome to this class. So we have get, like the get request, posts, and the delete mapping created. Now we need to have a put mapping wherein we would want to allow users to update the information for a particular job by ID. Okay. And as you can see over here, the request body should contain the updated job details. So how this would work is, you can call this URL this way. Okay. And if I take it to Postman, okay, let me duplicate the post request. So I'll duplicate this one. Okay, this will be put request, and instead of jobs, it will be jobs1 or whatever ID you wish to pass. And in the body, you will have the updated information about the job. Okay, and I'll just change this like so, and I'll hit save. Okay, so this is what the put request will look like. Now what we are doing over here is we are specifying which job we want to update by specifying the ID over here, and then we are also giving the updated job in the JSON. Okay, so let's head over to our ID and implement this. So here, what I'm going to do is I'm going to add a method. I'm going to say public, and we can have response entity over here, and this would be string. I'll say update job. Okay, and here I'm going to say boolean. So similar to delete, I'm going to say boolean updated is equal to job service dot, let me scroll up a bit. So job service dot update job. Okay, and I'll pass ID over here, and I'll also need to give the updated job information to this particular method or service over here, right? So we are calling this method from service, and we need to tell which job to update and also what to update. So this is the updated job object. Now how do we get both of this? So ID we can get in the form of path variable, okay, because that is how it is going to be passed. So I can say long ID over here, okay, and I can say request body over here, and I can say job updated job like so. Let me take this on the new line, okay, so that you can see. So if you scroll up here, we are taking path variable, okay, and in the post request we are taking request body. So here we are using a combination of both path variable as well as we need request body, which will have the updated job information, and we pass this to update job. Okay, now what I'm going to do is I'm going to say if updated like so, and I'm going to say return response entity, and here I'll have some string, and here I'll say http status dot okay like so, and here in the place of string I'll say okay, I'll say job updated successfully like so. Okay, now this is throwing some error. Okay, response entity. Okay, this has to be new over here. Okay, so this goes away, and now what I need to do is I need to create some room over here, and if the job is not found, what do we do? So I say new http response entity, sorry, not http, new response entity, and I'll say not found. So it's from http status dot not found like so. Okay, so we are done. Now we need to create a put mapping over here, which would be the update request. Okay, so you can say put mapping like so. Okay, and here I'm going to say jobs slash jobs slash, and I'll say ID over here like so. So we are done defining the controller. Okay, now what I want you all to do is I want you all to try and attempt to define this update job service. Okay, so take this up as a challenge, pause the video right now and define this, all right, and come back and watch the solution. So I hope you all had a chance to attempt this. So I'm going to continue solving this. So if you hover on this, you will see create method update job. I'm going to hit create and it will create this for me. Now I'll go to service implementation and I'm going to implement the methods here. Okay, now here what we are going to do is we are going to iterate through the job object or the job list, I should say, and then we are going to check every job ID with this particular job ID, and then if we found a match, we have to update all the values. Okay, so I'm going to say for each, I'm going to say job, and here I'm going to say jobs. Okay, and here I'm going to say if job.getID.equals, okay, it has to be ID over here, like so. And here I'm going to define the logic now. Okay, so it has to be this way, and let me press backspace. Okay, now what are we going to do? So if we find a match with the ID, okay, we are going to say job.setTitle. First we are going to update the title, and we are going to say updated job.getTitle. I'm going to duplicate this. We will say set description, and then updated job.getDescription. Duplicate again. Okay, we'll say set. So after description, you can say set minimum salary, then set minimum salary. Duplicate. So do this for all the variables that we have. Okay, and I can say set maximum salary. Okay, there are some semicolons being added, so I'll just remove that. Okay, and this seems incorrect. Okay, this should not be set, this should be get. Okay, get minimum salary and get max salary. Okay, like so. And there should be set minimum salary, set maximum salary, like so. Okay, so yeah, and one more variable is pending. So title, description, and we need to say location. Okay, so set, and here we need to get location. Okay, so we are done updating all the variables that exist, and here I need to say return true. Since we are returning a Boolean value, this is important. We need to say return true, and then here we are returning false. So what would happen is if the match is not found, so this iterates through the job list, compares for a match with the ID. If this is not found, you return false. If it's found, it's updated and return true. Okay, it's simple. Now, one thing to make a note over here is we are not updating the ID over here. Okay, and ID usually, whenever you're building software systems, ID is the unique identifier which is not supposed to be updated. It is like a primary key or a unique identifier that you wish to have constant for a particular record. Okay, if you are creating a bank account, you will have a customer ID which is not updated. If you want a new customer ID, you create or you become a new customer. Okay, so a new record has to be created. So I'm avoiding that bad practice and I'm not updating the ID over here. Okay, so we are done. Now let us run this application and let us test the results in the Postman. Okay, so the application is started now. Let's head over to Postman. Okay, so we have this. Okay, so let me get all the jobs now first. So there are no jobs. So I'll create a job first. Okay, job created. Get all the job. You have software engineer needed with ID 2. So let us update this. Okay, so I'll say updated. Okay, and I'll enter updated like this. Okay, I'll copy this. This has to be 1 instead. Okay. Oh, I'm updating it at a wrong place. 1 second. So this is there. This is a post request. I need to update it in the put request. Okay. So since we will be firing the put request, so let me close all the tabs here. Okay. All the tabs are closed. So if you do a get request, you get all the jobs, which is like this one job only exists. Now let us update this job. Okay, so what I'm going to do is I'm going to say title, and here I'm going to add updated like so. Okay, here also I'm going to add updated, and updated. Okay, let's see if everything updates successfully. You can see 200. Okay, now if I say 1 1 over here instead of 1, you'll get 404. This is working perfectly fine. Okay. Now what I need to do is I'll change this to 1 again and I'll save the request. Now I'll go to get all jobs and let us fetch all the jobs. And you can see everything is updated except the ID. Even if you pass ID over here, so even if I pass ID, like if I pass ID as 10, and if I send the put request, it won't work, like it won't update because we are not setting or we are not updating it in our code, right? We are just ignoring the ID, even if it's sent by the user. Okay. So this is about the put request and how you can get it to work in our job application. All right. That's about this class. I shall see you all soon. Thank you. Hello everybody, welcome to this class. So I wanted to spend some time talking about request mapping annotation. So request mapping is an annotation that is provided to us and it can be used at method level as well as class level. So at method level, you have different methods here now, you can see. And we have used different annotations like get mapping, post mapping, we have used delete mapping and then put mapping. Now, instead of these annotations, you can use request mapping as well. Okay, you can just comment this out, put mapping, and you can say request mapping like so. Okay, and you can specify 2 parameters over here. Okay, so one is value. Okay, this says the URL. Okay, you need to specify the URL in this particular parameter, and then you need to say type, which is with the help of method parameter. So you can say type, and the type over here is request type. Okay, so you can say request method is put. So you specify the path and the request type like this, and this is the mapping that you are using, request mapping. Okay, so you are using 2 parameters, one is value and one is parameter name method. Okay, so this is also something that you can use, and you can use it for everything. Like you can use it for get, you can use it for post, you can use it for delete as well. Okay, so you can create your URLs this way as well and it will work perfectly fine. But then why did we use this one, like put mapping and all? So the reason is request mapping exists. Okay, it's an option. But put mapping, get mapping, and post mapping, delete mapping, these are all specialized versions. Okay, when we use put mapping and all directly, it becomes really evident as to what the request is doing, and it also reduces some code. Okay, so this is about request mapping at the method level. So at the method level, request mapping annotation is used to map a particular method to a specific URL. Okay. Now, this is at method level. Now, how does it work at the class level? So you can use this annotation at the class level as well. So I can say request mapping. Okay. And I can say /jobs. Now, what happens when you do this? So when request mapping is applied at a class level, it sets a base URL or a base URL path for all the methods that are handling requests in that particular controller. Okay, what means is, like here, if you take a look at all the URLs, you have /jobs. You have /jobs here. You have /jobs again, /jobs again, and here also /jobs. So /job is the base URL over here. So domain name /jobs is the base URL for this entire controller. So I can just remove /jobs from everywhere like so. I can remove /jobs from here as well. Okay. So here I will delete this entire thing and from here as well. Okay. Now what we did is instead of having /jobs in every URL, we have just defined a parent or a base URL for this particular controller. So any request that comes at localhost :8080/jobs is redirected to this particular controller now. Okay. So this tells that URL ending with /jobs is supposed to be handled by this particular controller. Okay. And it reduced a little bit of repetition over here. Okay. Now, if in future you wish to change the base URL, you just have to change at one place and it's applied for all the controller, rather than going to every request, like every method, and changing it individually over there. For example, /jobs, let's say in future you want to remove the S. So in the older version, like we just removed the URL mapping that we had everywhere. Okay, there we had to modify every method. So you have to go to every method and change and remove the S over there. But this makes life much more easier. Okay, so this is what request mapping is. Okay, now if I run this, I'll stop and rerun. You can see application started and you can get all the jobs. It's working perfectly fine. You can see, you can post a job, you can put the job, you can get a particular job, and you can even delete the job. Okay, so everything works perfect. All right, so I just deleted the job and that's why the array is empty or the list is empty. So this is how request mapping annotation works. So always remember, it works at two levels, class level and method level. Class level, it's used to define or set a base URL for a particular controller, like we have done over here. And at the method level, it can be used this way. Okay, it can define the URL that this particular method is supposed to be mapped to. So that's request mapping annotation for you. Hello everybody, welcome to this class. So let us start talking about JPA and understand what it is. So we now have a job class and now we need to store that job class into the database. So what I mean by storing the job class into the database is whatever information that we are having in the application with the help of this job class needs to persist and gets saved in the database. Now, how would you do this? So one way is you create everything manually, like you have ID, title, description, like all the other fields that you have in this particular class, you can create it into the database. But there is a better approach with the help of JPA. So JPA stands for Java Persistence API, and it allows you to convert objects into relational table. Okay, so here you can see this class job has these fields and it will be converted into a table of this type. So all the fields will get converted into columns this way. So this is where JPA comes in, wherein this translation of objects into the relational tables is being done by JPA. So you can think of it like a specification that you specify, okay, and a blueprint, you can say. So this blueprint is then converted into relational tables. Now before JPA, you had to manually create these tables with the help of SQL queries. But now you can just mention the specification and table creation is automatically taken care of with the help of the specification that you have just mentioned. Now what is the advantages of using JPA? So number one thing is, of course, it's easier and it's simpler to follow. So it's much easier to write and understand than doing a handwritten mapping. So like I mentioned, the another approach was to do everything manually, but that was more cumbersome. JPA makes writing query easier. Okay, so if you want to query your data, it's much more easier with the help of JPA, and it helps us write queries in the form of entities rather than SQL. So you can make use of objects within Java to query the database. JPA also allows us to save and update the objects, and this is without using any DML language at all. Now what I mean by DML language? So DML stands for data manipulation language, like update and insert queries. So if you want to update anything or insert a new data into the table, you can do that with the help of JPA itself, and it takes care of everything around that. Another advantage would be it has easy integration with the Spring Boot framework. So there is a small dependency that you need to add and you are done. So Spring Boot has an inbuilt support for JPA and it can be just activated with the help of a dependency. So this way JPA is really useful when it comes to converting your classes or objects into underlying table. So that's about JPA. Thank you. Welcome to this class. Let us start talking about the data layer. So we have three layers like we discussed. We have presentation layer, service layer, and the data access layer. So we are going to talk about this layer which we have not defined yet for our application. So we need to create this layer and this layer would be responsible for performing the CRUD operation. So what do I mean by CRUD operation? CRUD stands for create, read, update, and delete. Like for example, you have jobs. So you are creating a job application. So you might want to create a job, read a job from the database, update a job, and delete a job. So that is commonly known as CRUD. So CRUD is a common set of operation that is performed on any database. So to do this operation, we will need a set of these methods. So you will need find all, which will be responsible for getting all the jobs from the database. You will need get job, which will give us a particular job depending on the ID that we give as a parameter to this method. So this is for getting all the job. This is for getting a particular job. Then we have the update job as well, which will update the job, whichever job you pass in. And then you have delete a job. So this is just an example that I am giving you. We also have create job, which I have not added here. But create job will also create a job for you. So instead of creating these methods into our application, okay, and these methods will act on the job class. So we don't have to define this. We need to create an interface and use something called as JPA repository, which is the part of JPA. And that repository has the standard implementations that are needed for a typical database driven application. So you need to define only special cases which are not standard and they are particular to your use case. But the standard ones on any class or on any object like updating, fetching, deleting, creating are all predefined. Now the question is, how can you create an interface using JPA repository? So this is a syntax. You can specify JPA repository, entity name, and the primary key type. And this is something that we are going to see shortly. So that's about the data layer. Let us start talking about the H2 database. So what is H2 database? So H2 database is a open source relational database and it has been written in Java and it's incredibly fast for building Java based applications. So that is something that we are going to use. So what you can do is you can head over to Google and search for H2 database and you will be shown this official website over here, H2 database engine. So you can go to this website and I have this open over here. So what is H2? So these are some of the features of H2. So it's an SQL database which is based on Java. Now what I mean by it's based on Java, it's written in Java and it can run anywhere wherever Java runs. And this makes it perfect for development testing or even deployment in certain scenarios. Now it is pretty lightweight and it is not supposed to be used for production-based environments. So as long as you're building applications for testing and if you need something that is really fast and get you started quickly, that is where H2 comes into picture. So as you can see, it's fast, open source. Now it has embedded and server mode. So what do you mean by embedded and server mode? So embedded mode means the database runs within the same JVM as your application. So that's what is embedded mode. While server mode means that it is running on its own, which means it has a separate process of its own and it's running as a server and it can accept connections from the clients over the network. So this embedded mode is beautiful and it makes sure that we can embed it into our application. Also, H2 database has a browser-based console application using which you can see what tables have been created and what data is being stored from our application into this particular database. Also, it is pretty lightweight, as you can see over here. It has a jar file of around 2.5 MB in size, which is really small. And it is also known for its quick start. Okay, so it's really fast and it also makes your application faster. So you can see over here, it's fast, open source. So these are more features that have been mentioned over here. So this is something that we are going to use. But right now, you don't need to download or install this database. So you can use this website to learn more about what this is and how does this database work. But instead, we will be activating this particular database within Spring Boot with the help of a small dependency that we will add. So that's about H2. Let us start talking about how can you configure your project to work with JPA and databases. So setting up JPA with Spring Boot is a fairly straightforward process, and thanks to auto configuration capabilities of Spring Boot. So to begin with, we need to first add the Spring Boot data JPA. Okay, so what I'm going to do is I'm going to head over to start.spring.io, our favorite website. Okay, I'm going to make sure that I have Maven selected here. Okay, and I'll go ahead and say add dependencies. Now over here, I'll search for JPA. So this is a dependency which persists data in SQL stores with JPA. So Java Persistence API using Spring Data and Hibernate. So within this dependency, it makes use of Spring Data and Hibernate. Okay, so I'll just select this. Now this JPA dependency also provides support for ORM in Spring Boot applications. Now what I mean by ORM is object relational mapping. Now this is the process of converting your objects in Java to the relational tables. Okay, that is what is known as ORM in simple terms. So whatever fields you have within the object are being converted or mapped into columns. Okay, and this particular dependency also allows you to define entities, repositories, and also utilize the JPA features that are needed for data persistence and retrieval. Okay, so it enables you to work with relational database and leverage the JPA functionalities for data access. Okay, so this is one dependency that we are going to need. Now another dependency will be H2. So since this is the database that we are going to use, so you can see it's a fast in-memory database that supports JDBC API with a small footprint, and it supports embedded and server modes, okay, as well as browser-based console application. So I'll just select this. So Data JPA provides a way for us to work with data. It makes our life easy. And H2 database is the database that we need in our application. So now what I'm going to do is I'm not going to download this project or create a new project over here, but instead I need these two dependencies, and we have already a project set up in Intellij. So I'm going to go to Explore. I'm going to make sure that I have pom.xml selected. Okay, and I'm going to scroll down here, and under dependencies tag, you will see two dependency over here. Okay, so these are the two dependency. So one is the Spring Boot starter JPA, and then you have H2 databases. So I'm going to copy these two dependencies. Okay, I don't need anything else. Okay, and I'm going to just close this. So make sure you have Maven selected over here. If you don't have Maven selected and if you click Explore, you won't see pom.xml. So let's say if you have Gradle selected and if you say Explore, you will see a build.gradle file. Okay, and the dependencies added in the Gradle format. So we are using Maven, so we need Maven dependencies. So I've copied this and I'll switch over to Intellij. Now in Intellij, just make sure you have your project open. Head over to pom.xml and I'll collapse this and scroll down. Just go to the dependency tag, okay, and add the two dependencies that we copied into this particular file. Just make sure you copy it under, or you paste it under dependencies tag. Okay, just make sure it is pasted along with other dependencies that exist. So now what happened is we have changed the pom.xml and we have altered the dependencies that exist in our project. Now the moment you edit or make any changes to pom.xml, you're going to see this icon over here. And if you hover on this, it says load Maven changes, which means that you have updated the dependencies or some changes you have done in this particular XML file. So you should reload the changes to apply them. Okay. If you're not seeing this for any reason, you can click on this Maven icon here. Okay. And you can click on this particular refresh icon. So reload all Maven projects. So that will also do the same job. Okay. But since I'm seeing this, I will just click on this and you should see all the dependencies being resolved here at the bottom right. So you're seeing it's resolving all the dependencies and getting all the files that are needed. So you can see everything is being indexed and the red marks have gone. Now we are done with this. Now what we need to do is we need to head over to application.properties file. Now why are we going over here? Because we have just added the dependencies for databases. We need to add and specify some configuration for database. Okay. So we are going to specify the data source URL and we are going to tell Spring Boot that we need the H2 console enabled. Okay. So I'm going to say spring.h2.console.enabled is equal to true. And another property that I'm going to specify is spring.datasource.url is equal to, so this is a URL of our database. I'm going to say gdbc:/h2:mem:/test. Okay, so this is the URL that we are using. So we are using the test database and this is the JDBC URL that we have to specify. We also have other parameters like setting up the username and password, but we are not going to do that right now. Okay, these properties are enough for us to work with right now. And this is just a basic setup. Okay, there are many other properties that you can configure, but we are not going to do that right now. All right. So that's about enabling JPA into your Spring Boot application. Let us start talking about entities in JPA. So what is an entity? So in the context of JPA, an entity represents a table in the relational database. And each instance of an entity corresponds to a single row within that database. So what I mean over here is, you take a look at the job class over here that we have created. Now, entities in JPA are nothing more than POJOs or plain old Java objects. Okay, so here we have this job class. It's a class which consists of some fields. Okay, and we are going to define this as an entity. And this is something that will be used as a template to create a table within the database. So this is the entity that we are mapping to the Spring Boot database, whichever database we are using in the background. So in our case, we are using H2. Now, whenever you create an instance of this particular class, for example, if you create a job object which represents a job, so that will represent a row in that particular table to which this entity is mapped. I hope I am able to make things clear. So if you are not clear yet as to what entity is and how it works, you will shortly be able to understand when you see all of this in action. So we will start defining this particular class as an entity. So how do we tell Spring Boot that, hey, this is the entity class that I want to persist within the database? So answer is simple with the help of annotations. So I need to say @ and I can say entity. So you can see you get an autosuggest which is from Jakarta.persistence package. So I'll select this and you will see the import statement being added over here. And this tells Spring Boot and JPA that this is a class that is supposed to be mapped to a table. And it needs to be treated as an entity. Now, whenever a table is created or whenever an entity is mapped to a table, the table name is same name as that of the class. So if you want to customize this, like if you don't want to have a table with the name job, what you can do is you can make use of one more annotation. You can say table over here. And here in the bracket, you specify name, and the name can be anything like the name that you want. So I can say job_table. So what will happen is the class name is job, but instead of having the default name job within the database, you are telling JPA that I need a table with this particular name in the database. So with this annotation, that is being taken care of. Now, every entity that you create needs to have a primary key in the database, and that primary key will serve as a unique identifier for each record in the table. So for example, if we have a table representing jobs, we will have a ID field in the database, which will represent every unique job post or every unique job that exists in our application. So how do you specify that? The answer is with one more annotation, you can say ID like so. So just make sure I is capital. If you specify small, you're not going to get the autosuggest. So you need to say I in caps and you need to select the one from Jakarta.persistence like here. So you can see it being imported. So these are all annotations that are coming in from this package Jakarta.persistence. Now this tells like this is the ID or the primary key. Okay. And now you don't want to manage primary key. So far we have been managing primary key in the service layer. So not in this class, but in the implementation. Okay. So here we are managing the ID and we are making sure that it gets incremented. So it starts with 1 and it gets incremented. So we are manually managing this. So we don't need to manage all of this with the help of JPA. Instead, you need to add one more annotation if you want JPA to manage it. Okay. So what you need to do is you can say generated value. So this is the annotation. Okay. And you can specify how you want the value to be generated. Okay. So you can say strategy is equal to generation type dot. So you have all of these various like fields that you can add. So I'll say identity. Okay. So this way it will be automatically managed by the JPA and you don't need to generate values for IDs. Okay. So while saving, even if you don't specify the ID value, it is automatically created. Okay. So that's the beauty. So what I'm going to do is I'm going to comment this table annotation for now. Okay. I am fine having a table with the same name as that of the class or the entity that I have. Okay. And one more thing that you need to keep in mind is we have a constructor that constructs this job object. Okay. But whenever you are working with JPA or whenever you are defining the entities, you need to have a default constructor. Okay. So I'll go over here. I'll say generate constructor and I'll say select none. So this will generate the default constructor without any parameters for me. Now, why is this needed? So this is because entities are objects that represent the persistent data in the relational database. Okay. And this is one of the requirements for JPA entities to have a default no argument constructor. This is needed because JPA needs to create instances of entity class during the retrieval of data from the database, and JPA uses reflections to create instances of entities. Okay, and it populates the properties with the retrieved data from the database. And without this default constructor, JPA won't be able to instantiate any entity object. So that is why this is needed by JPA. Okay, and it is important to note, like, this default constructor is needed, but along with this default constructor, you are free to have more constructors like this one that are needed for your own purpose. Okay, so they won't hinder in this particular job that JPA is doing. So that's about entities and how it works in Spring Boot. Let us start talking about the repository, and let's start defining a repository for our project. So what is a repository? In Spring Data JPA, a repository is an interface that allows us to perform various operations involving a database, like create, read, update, and deleting records without writing the boilerplate code. And let us see how we can define such a repository. Okay. So here in the job package, I'm going to say new, and I'm going to have an interface over here. So I don't see an option for interface right now. So I'll say Java class. Okay, so the option is over here. I'll say job repository. And I'll close this. Okay, so we have this interface created, which is a public interface, and it's called job repository. Now what I'm going to do is I'm going to extend. So I'm going to extend JPA repository. So this is the interface that we are going to extend here. Okay. Now you can create a repository using two repository interfaces. So one is the JPA repository, which we have just used. Okay. And you can even use CRUD repository. So this is another interface that exists. Okay. And you can see they both exist in, so this one exists in the JPA package, and this one exists in the data.repository package. Okay. Now CRUD repository provides CRUD functions like save, find one, find all, count, delete, and so on. It is useful when it comes to usage of some generic CRUD operations, which means we get basic CRUD operations with the help of this interface into our application. But you can make use of JPA repository. So JPA repository extends the functionality of CRUD repository, and it adds JPA specific methods like you have flush, save and flush, and so on. So if I say over here JPA repository, and if I press Control on Windows, or you can press Command on a Mac, and if you hover on this, it will convert into a link. And you can go over here, you can see you have different methods like save and flush. So it gives much more functionality, okay, as compared to the CRUD repository. So we'll make use of this one here. Okay. Now we need to make use of this repository with the job entity. So we need to tell that over here, or specify that. So I can say job. Okay. And we need to specify the data type of the primary key. So the data type of the primary key is long. Okay. And I'll remove this import statement here. So I'm going to optimize imports. Okay. So job repository interface is what we call a Spring Data JPA repository. And it's an interface in a sense that it's not a concrete class that we can instantiate with the new keyword. Instead, the Spring Data JPA will create an implementation of this interface for us to use. Okay. And you can see over here, we have also defined the two parameters that it needs. Okay. Which is the entity type and the type of the primary key that we have. And one of the greatest things of using a repository like this is we don't have to write any implementation code for the repository. So we have to just define like this and we are done. So Spring Data JPA will automatically generate the implementation at the runtime, and we can use it in our application. Like we can use it in our service class over here to like interact with the database, and we will see that how we can make use of it. Okay. So this is about the repository class and the data layer as to how you can work with it. So let us start working to make our jobs persistent. Okay, so what we are going to do is we are going to make use of this repository interface that we have created, and with the help of JPA repository, we are going to make the job entity persist into the table. So let us head over to the service class here. Okay, and not this one. So I need to head over to the service implementation here. Okay. Now, if you take a look at the implementation here, we are managing everything with the help of an array list. Okay, so the data in our application is in array list. So I will be first commenting this part. Okay, the moment you comment, you see red marks all over, which is fine. We have just disabled the array list based data store for the application. So we are going to get this red marks, but we are going to work to replace these red marks with the JPA methods. Okay, so first thing here, what I'm going to do is I'm going to define a repository object. So I'm going to say job repository like so, and I'm going to say job repository here, and I'm going to create a constructor here. Okay, so I'll right click and I'll say generate, and I'll generate a constructor, and this will be for job repository. Okay, so the reason why we are doing this is job repository is a bean that is being managed by Spring, and because of this constructor, it will be auto wired at the runtime. Okay, so you don't need to create and manage this object, and you don't need to create an instance and assign it and initialize it over here. It will all be done by Spring, provided you have a constructor defined. Now, what we need to do is here in the find all method, we need to say jobs repository dot find all. And the moment you do this, you see the error goes away over here. Okay, you need to scroll down and you need to modify the create job method as well. So here, instead of jobs dot add job, I'm going to remove this, and I can say job repository dot save job. Okay, I can say save, and I'll pass the job over here. You can see the auto suggest here coming in, like you have to pass the job object. So I'll pass this over here, and I'll add a semicolon. Okay, now we are done with create job. Now here we need to modify this particular method here. So to get job by ID, what we were doing is we were traversing the array list and we were comparing the ID with every object. Okay, and we were returning the object whenever there was a match. So we don't need to do this. Okay, so what we can do is I can say over here, okay, job repository dot find by ID. So here you can see all the methods that we are getting with the job repository. So the moment you say dot, you can see you can save, you can find all, you can find all, like find all has different implementations. You have equals, you can, let me say find. So you also have find by ID. So we are going to get this. Okay, and here I'm going to say ID. I'm going to pass the ID, and I'm going to say dot or else. So since find by ID returns an optional, okay, if you hover on this, it returns an optional. You can see java.util.optional. So I can say or else over here. So optional means you can use or else method, which says if the object is not found, you can return a null, like so. Okay, and then you can add the return statement over here. Okay, so you can see like a lot of code was reduced, and this way you can get the job by ID. So if the job is found with the help of ID in the database, we return the job, or else we are simply like returning null over here with the help of this. Okay, so this is about getting job by ID. Now you can even delete the job. So here we were again finding the job first, and then we were removing it from the array list. So we don't need to do this. I'll just delete this. Okay, now here we just need to say return, or we don't need to even return. So we can say job repository dot delete. So we delete by ID, and I'll say ID over here. Okay. And if this is done, I'll return true. Okay. And what I will do is I need to handle like what happens if this particular job is not found. So I need to add a try catch block over here. So if this job is not found, there will be an exception that is thrown. Okay. So I can add a try catch block, and I can say over here catch, and I'll add exception E. Okay. And if there is an exception, I return false like so. Okay. So if the job is found, you delete the job, return true. Else, if there is an exception, you return false. Okay. So you can see like delete method that was provided to us by JPA. Okay. You can even update the job and the code can even become simpler. So here you were using this particular for loop to traverse. Okay. So what I will do instead is I'll use optional over here. So optional job, and I'll say job optional like so, and I'll say job repository dot find by ID, and I'll pass the ID over here. So once we have the job over here, instead of for loop, I'll just remove the for loop. We don't need for loop now. Okay. I'm just going to delete this. Okay. And here I'm going to say if. So I'm going to say job optional. So if job optional dot is present. So job optional or the optional class has this method which is present, which means that the object is present. Okay. So if the object is present, it goes into this if statement, and I'll say job over here is equal to job optional dot get the object. Okay. So we are getting the job object now from the optional object over here, like object of the optional type. Okay. And then we are setting all the parameters over here like we did early on. Okay. And if this is done, it returns true, else it returns false. So you can see with the help of JPA, we were able to make a lot of changes in the service class, and we have actually made use of JPA to persist the data to the database. Also, I would request you all to spend some time exploring this object. So if you press dot over here, you can see different objects that exist. So you can see save over here. So this is to save the job object or any entity for which you have created the repository into the database. So imagine the life without this entire mechanism. You know what we would have done if this mechanism was not present, like this JPA was not present. So in the absence of this mechanism, we would have written SQL queries over here. Okay, so imagine writing like select star from job and handling all the syntax errors as well. So here life becomes so much easy with the presence of all these kind of methods over here. So you can see like all these methods that we get with the JPA repository. And what we have done is we have not done anything. We have just created a repository which extends this particular interface over here. And we have just said repository, please manage this job entity, and the primary key is of long type. And we have everything that we need. Okay. So this is how you can get your job to persist. So I hope you all found this valuable, and I hope you're enjoying learning JPA. Let us start testing our changes that we have done. So what we are going to do is we are going to test that everything works with the database perfectly as it was working earlier when we didn't have the database. Okay. So what I'm going to do is I'm going to first run our application. Okay. And we will monitor the logs over here. So I'll just expand this over here. Okay. Now, if you scroll up over here, okay, you will see this message somewhere. Okay. You can see there is a H2 console that has been made available at this particular URL. Okay. And if you scroll up further, so you can see there is a lot of configuration that is happening. Okay. So bootstrapping Spring Data JPA repositories in default mode. Okay. So It's adding all the dependencies and configuring JPA for you. Okay. And we have specified the database URL. So this is the database URL that we had specified, jdbc:/h2 mem test. And you can see this over here in the application.properties. This is what we have specified. And what it did is it created a connection with the user SA. So it has also given you the username onto the console. Okay. So we'll be using this user over here. And if you scroll down, you can see the console was available for this particular database. Okay. So you can even find this information by pressing Ctrl F over here and typing in H2. So if you type in H2, you will see like there are 9 occurrences, and you can just go down, press next occurrence, and you will see all the information about H2 and whatever is being printed onto the console with the letter H2. Okay. So what we are going to do is we are going to copy this URL. Okay. And I'm going to head over to my browser, and I'm going to go to browser over here, and I'm going to say localhost :8080/h2 console. Okay. So this is a URL that we got. And if you go to this URL, you will see a page like this open up. Okay. So you can see driver class, JDBC URL, username, and the password. Okay. So here is where you will specify the JDBC URL. So what I'm going to do is I'm going to copy this JDBC URL that we specified in application.properties, and I'll paste it over here. Username is SA. So it's mentioned SA over here. So if you scroll up, you can see user is equal to SA. Okay. So this is a default user. So SA is typed in and there is no password. And I'll click on test connection. And you can see the connection has been successful. Now what I'm going to do is I'm going to say connect. Now when you say connect, you're going to see a table has been already been created. Okay. Now what happened is when you executed the application, the queries to create this particular table were executed. And if you wish to see those queries, you need to add a property over here in the application.properties, which will enable those logs as to what is happening behind the scenes. You can say Spring JPA dot generate and -ddl is equal to true. Okay. And you can rerun this application. Okay. We didn't see the queries being printed because the tables were already created. So what we can do is we can ask JPA to recreate the table. Okay. And for that, I can say spring dot JPA dot hibernate dot ddl -auto, and I'm going to say create -drop. So we can tell the Spring Boot application to print whatever queries that are being generated with on the application startup when our database is initialized. So what we can do is I can tell that with the help of application.properties. So we need to add a couple of properties which will indicate and tell Spring Boot that, hey, please print all the SQL queries. So one of them is spring.jpa.show, and I'll say true over here. I'll specify one more property. I'll say spring.jpa.hibernate, and I'll say .ddl -auto, and I'll specify the value as create drop. Okay. So this first property indicates that SQL statements generated by Hibernate should be logged into the console over here. Okay. And setting it to true enables the logging of SQL statement, which can be helpful for debugging and understanding the executed queries. So since we are in learning mode, we are learning. So we can take a look at what all queries are being generated. And this property configures the behavior of Hibernate's schema generation tool. So behind the scenes, Spring Boot uses Hibernate, okay, to map or create tables. So what we are specifying over here is we are telling to create and drop the tables. So this means that Hibernate will create the database schema when the application starts, and it will drop the schema, like everything, it will delete everything once the application shuts down. So our database will restart and like it will recreate on every application start. Okay. And this is useful for development and testing environment. Okay. You can even disable this later on. But I have added this because we just created the tables. Okay. So we will recreate it. So I'll rerun this and I'll expand this a bit. Okay. So we are not seeing the queries being printed onto the console. And the reason for that is there is a typo in this property. So it is show-SQL. Okay. And not just show. Now, if I rerun this after making the change, okay. And if you scroll up over here, you will see some logs for Hibernate. And you can see this is the create table query that is being triggered. Okay. And this is the drop table query because we have specified create drop as the property. Okay. So you can see all the Hibernate related logs over here. Okay. So these were the only logs. Now, if you have more tables that were to persist in using JPA, then you would have seen many more queries over there. Okay. So this is how Hibernate and JPA work in the background. Okay. So our database is working fine. Now, since we have restarted the app, we will refresh this and we will test the connection and connect again. Okay. Because the connection is reset. Now, what we need to do is we need to test if everything, like all the APIs are working fine. Okay. So what I will do is I will create a job first. Okay. So let us send a post request and it will create this particular job and I'll send this. You can see job added successfully. We'll switch over to the table and in the H2 console, we'll click on this. Okay. So the moment you click on the job entity, you will see this query coming in over here and there's a select clause. Now I can run this and you will see the data being reflected over here. Okay. Now you can add one more job if you want to. So I can say job with ID 2. Okay. And I'll send this again. It's added. And if you run this query again, you will see the one with ID 2. Now over here, you will see that ID is being auto-generated. So we passed an ID of 1. Okay. But this was not taken into consideration. All right. Let us try the get request. So can you get all the jobs? Yes, you can. And it's working perfectly fine. Can you get a particular job? Yes, you can. And it's working perfectly fine as well. Now let us try deleting a job. So let's say I delete a job with ID 1. Okay. So job has been deleted successfully. And if you go to the browser and if you say run, you see you have job only with ID 2. Okay. You can add a job again. So I'll add a job again with ID, or I'll just remove this with ID part. So it's added and you will see the ID now is 3. So this is being auto-generated and auto-maintained. Okay. And now I can even update the jobs. Okay. So I can say updated. Okay. And I'm updating the job with ID. Let's try with ID 1. Okay. You will see 404 not found because the job with ID 1 is deleted. Okay. So I'll update the one with ID 2. Okay. And I'll update this to 2 and I'll run this. So you will see 200. Okay. And now if you do a select, you will see. Okay. So for some reason, I don't see the update here. So ideally this should have been reflected. So let me go to the console and let me run the select clause. Okay. So it's not being reflected and there has to be a reason for this. So let us head over to our source code and let us see our service class. So here in the job service, while updating, so what we are doing over here is we are updating the job entity, but we are not saving it. Okay, so we need to save as well, right? We need to save the changes. So I'll say job repository dot save, and I'll say job. Okay, and I'll add a semicolon, and let us rerun the application. Now, if you rerun the application, and if you head over here, if you try to get the jobs, you will see the schema is now reset. So we will have to create a job. Okay, we created this job. I'll create one more job. So 2 jobs exist now, and I'll try to update the one with ID 2, and I'll send an update clause. You see 200. Okay, let us head over to the browser and run this query. Oh, so the connection was reset. So I'll connect again, and I'll connect to this. I'll select this table, and you can see now it's being reflected. So what happened is we used this same method. So the save method was used for updating job as well, and also for creating a new job, right? So what happened here is we are making use of the same save method. So based on the ID, the job repository understands whether it should update or whether it should create a new object. So if the object does not exist with the specified ID, it will create a new one for you. Okay. Also, I noticed that we are still incrementing this, so we don't need to, and I'll just delete this next ID over here. Okay. Now the code looks much more cleaner, and now I'll rerun, and I'll head over here, and I'll connect this again. Connect. Okay. And here from Postman, I'll start creating new jobs. So this is job 1, job 2, and you can get the jobs. Okay, so the other job was, so let me add one more. So 2 jobs are created. Now if I get the job, I'm not getting all the jobs. So what is happening now is whenever you are sending or triggering an request, you're passing the ID as well. So what is happening is it's only saving the job with ID 1. So if you update this to 1, 2, and if you send, and if you try to get, you will get the same job object, which is the reason. So this ID is the reason why this is being overridden. So I'll just remove this ID and I'll send the query, and now you will see a new job being created. Okay. So you can keep on sending as many jobs and it will create for you. Okay. And you can update the job as well. So I can I'll remove the ID field from here as well. Okay. And I'll update the one with ID 2. Okay. And we'll try getting the job with ID 2. Okay. Okay. So there is no job with ID 2. Okay. I believe we got an error over here. So we will update the job with ID 4. Okay. And it's 200. Okay. So I'll try getting the job with ID 4 over here, and it works perfectly fine. Okay. So all the APIs are now working fine. Okay. So you can test it at your end. Okay. And you can save all the requests if you wish to. So I'll just save everything. Okay. So this is how you can make use of JPA to get your data to persist. Welcome back. So what are we going to build next? So this is our application in its complete form, and we have job, company, and reviews in our application. And here's how it should work. So far we have worked on job controller, job service, and the job repository, where everything works with persistent data, where we are persisting the job entity into the database. So now it's time to build company and review functionality as well. So here are the endpoints that we are going to define for company. So we have get companies, which will enable us to fetch the list of all the companies that exist in the database. Then we have put companies, where we can update a company with the help of an ID. Okay, so we have to specify the ID of the company which we want to update. And in the response body, like in the request body, not the response body. So in the request body, we will be adding the updated version of the company. So that's the put request. Then we have post request on /companies, wherein we will have the company object in the request body, and that will help us save the company. Then we have the delete request, where with the help of ID over here, we are deleting a specific company. And then we can get the companies with the help of ID as well. So this is the company's API structure. These are all the APIs that we are going to define. And then we have the reviews functionality, where we have reviews associated with companies. So you can see the endpoint. You have companies /company ID reviews. So for every company, we have a review. So we say companies / the ID1 / reviews. So this is going to give us, this GET request is going to give us reviews for a particular company and the company ID that you specify. Then you have post request, wherein you can add the review against a particular company using this post, and the review object goes in the post, like the request body. Okay. Then you have get, where you can get a particular review, okay, with the help of this ID against a particular company. Then you have put request, where you can update the review, a specific review against a company. And then you work with delete request, where you can delete a particular review against a company. So this is the review functionality. So these two functionalities are pending now, and they are much more similar like the job functionality that we have built. So if you have gone through the job functionality and if you are comfortable and have understood everything, what I would request you all is to take this entire set of APIs as a challenge, and you can try this yourself. And once you have attempted solving or adding all of these APIs to your application, you can come back and watch the video to get hold of the solution. Okay. And you can compare it with your solution as well. So that would give you some code writing experience and it will boost your confidence. So yeah, I would request you all to attempt that and like continue with the next lectures. All right. So that's about this class. I shall see you all soon. Thank you. So let us start working on companies and let us start set up the controller, service and repository layer for company. So what I'm going to do is I'm going to create a new folder here or a package. I'm going to call this company like so. And within this package, I'm going to have first company controller and one second. So I have job controller, job repository and job service. So I'll have company controller, then company service, and then I'll have the company repository like so. Okay, and this has to be an interface. So I'll add this. We will also need the company entity. So I'll say company like so. So we have done setting up all the files. Okay. We also need this implementation. Okay. So what I will do is I'll create a new Java class. Okay. I'll say IMPL dot. So I need this class to be created in the IMPL package, and I'll say company service IMPL. So I'll follow the convention of job and I'll say enter. So you can see this being created. All right. So we are done with the setup of controller, service and repository. Let us start building the functionality to get all the companies from the database. So what I'm going to do is I'm going to first start defining the company entity over here. Okay. And we are going to have quite some fields that we are going to store with company. So the field that we are going to need is ID, name, description. Okay. So I'm going to say private, long, and I'll say ID. This will be private string, and I'm going to say name over here like so. And then I'm going to have private string and description. So yeah. Now what we need to do is we need to map every company to the list of jobs. Okay. How do we define a mapping? So this mapping meaning there is a relationship between this company entity and the job entity. Okay. So every company has a list of jobs. That is how they relate in the real world. So I'm going to say private list, and I'm going to have job over here. So this is a job entity, and I'm going to say jobs like so. Okay. And I'm going to also mention an annotation over here. So I'm going to say @1-to-many. Now, one-to-many means that one company has many jobs, and that is the relation that we are creating with the job entity. And one-to-many annotation is coming in from the Jakarta.persistence one-to-many. So this is done. Now what I need to do is I need to also specify the one-to-many relationship with reviews. Okay, but we have not created reviews. So how it will work is every company has a list of jobs, and every company also has a list of reviews. So we'll define that later on. Okay. So for now, what I'm going to do is I'm going to have a constructor here created. Okay. So I'll say generate constructor, and I'll say select none. So this is for the GPA. Okay. And I'm going to also say like generate the getters and setters like so. And I'm going to mark this particular entity as entity. Okay. Here using the annotation, and I'm going to mark ID field as ID, and I'm going to say generated value, and I'm going to specify the strategy as identity like so. So this will be auto generated, and then we have a mapping created for jobs. Okay. So we need to create a mapping over here later on for reviews. So I'll say reviews will be listed like so. So I'll say private. So I'll just duplicate this, and I'll say reviews. So review over here, and this will be plural like so. Okay, so if we add this now, we'll get an error, of course, because the review entity does not exist yet. Okay, so this is done. Now what we need to do is we need to head over to the company repository. Okay, and we need to make some changes over here. So in this interface, I need to say extends JPA repository, and I'll say company is the entity and long is the ID type like so. So the repository is set now. Now let's head over to company service over here. Now what are we doing in the company service? So in this particular, so not in this one. So, okay, so this has to be an interface, but we created this as a class. So I'll change the definition of this to interface. Okay. So company service is an interface which is being implemented by company service implementation. Okay. So over here, I'm just going to define some methods. Okay. So the first method we are going to make use of is list company like so, and we are getting all companies. So this is the functionality that we are building right now, wherein we are getting the list of all the companies. And here in the company service implementation, I'm going to say implements company service. Now, once you do that, you will be asked to implement all the methods. So I'm going to just do that. Now over here, we need to return the list of all the companies from the database. So for that, I'm going to define a repository. Okay, I'm going to say private company. So company repository, and this can be company repository here. Then we need to initialize it, and we will initialize it in the constructor, and this will be managed by Spring. And over here, what I'm going to do is I'm going to say company repository, dot find all. So this method is going to return all the instances of company that exist in the database. Now let us head over to the controller, like the company controller. And here I'm going to add a mapping that will handle the URL to get all the companies. Okay. So I'm going to first define a REST controller over here. So I'm going to say this is a REST controller which handles the REST queries. And here I'm going to also add request mapping, which will define the mapping for this controller. Okay, so I'm going to say companies over here. Okay. Now over here, I'm going to create an object of company service because controller will use the service object to work with company. And then I'll say generate constructor, and I'll get this initialized with the help of Spring Framework. Now here I'm going to create a method. So I'm going to say public list company, and I'm going to say get all companies. And over here I'm going to just say return company service dot get all companies, like so. And now we need to map this to the URL. So I'm going to say get mapping. So this is a get request, of course. So it will be a get mapping, and we don't need to specify the URL because we have already mapped this controller to companies. So this is a URL that we'll use. So any get request on this URL will give you the list of all the companies. Okay. Now what we need to do is we need to run this particular application. Okay, so you got an error, and the error says parameter 0 of constructor in company controller not found. Okay, and we need to define a bean called company service. So what is happening is it is trying to find, so we are trying to initialize this particular instance of company service with the help of Spring. Now Spring is not able to find Spring service, and there is a reason for this. Now if you go to company service implementation, we have not added the service annotation. So we need to add that, and this will tell Spring Boot that it needs to manage this class as a service. So now we'll run this, and now let's see if the error goes away. So you can see the error goes away. And now let's head over to Postman and see this in action. Okay, so we don't have jobs, in fact. Okay, so we added a job, and I'll get the job. So we have one job created. Okay, now we need to get the list of all the companies. So what I'm going to do is I'm going to replicate this URL. Okay, so I'm going to say duplicate this URL, and I'm going to go over here, and I'm going to say companies. And I'm going to edit the name as well for this. Okay. And then I'm going to send a get request. So we are not going to get any response as of now from this query because there are literally no companies created yet. Okay. But we can even check if the company entity is created in the H2 database. So I'll connect. And here you can see we have company. So if you run company, you don't have any data, but we also have one more table which stores the relationship of company and jobs. Okay, so I'll clear this and I'll select this. So this has two fields, company ID and job ID. So if you expand this, so we are storing the company information in company table, and the mapping of company to job, like which company has which job, that mapping is stored in this particular table. And this table is created because we have specified a one-to-many relationship between the job and the company. Okay, so this relationship is being managed in a separate table. That is what you will notice. So that's how you can create an API to get the list of all the companies. Welcome back. So let us start writing some code to update the companies. So what I'm going to do is I am going to head over to company service over here. Okay. And I'm going to create a new method over here. Okay. And this method is going to just help me update the company. So what I want to do is I'll return the company object here. I'll say company and I'll say update company. And here I'll accept a parameter which is the updated company over here. So you can even skip the return type if you wish to. So what I will be doing is I will be updating the company and returning the same company object. But if you don't want to return anything, you can just have void or something. So if you go over here and in job service, you can see we have updated the job with the help of a boolean. So you can do that way as well. Okay. So now what I'm going to do is I am going to update the company here and I'm going to implement the methods like so. Okay. And here in the implementation, okay, so I'll also need ID. So I should accept the ID like we have done for the job service. Okay. So what I will go do is I'll head over to company service here. Okay. And let me also change this. So I won't return the company object and I'll say long ID like so. Okay. And I'll go over here and I'll just overwrite this like so. Okay. And I'll just remove this. So this is the older one. Okay. Now what I can do is I can refer to the job service IMPL. Okay. And I can do it the similar way. Okay. So I'll just copy this entire code over here. I'll head over to the company service. And here I'm going to paste this entire code. Okay. Now, of course, we are making use of job repository, which is not right. So I'll change this to company repository here. Okay. And instead of job, this will be the company object. So I'll say company like so. And here this will be, so I'll refactor this. Okay. I'll say, let this be company optional. I'll select from the suggestion. Okay. So this is done. Now here I need to change this type to that of company. Okay. And I can update this here and I'll say company like so. And here we need to update the update parameters. Okay. So here we are calling the setters from the job class, which won't work. Okay. So what I will be doing is I will say dot set and I need to set the description here. Okay. And the description can be company. Okay. So this variable name conflicts with this one over here, the parameter. So what I can do is I can call this as company and I can refactor. I can say company to update. So here I can say company to update like so. Okay. This is done. Here I can say company now, company dot get description. Okay. This is done. Then I need the name as well. So I'll say set name and I can say company dot get name like so. Then I also need the we don't need to update the ID, of course. So we need to update the jobs. So I can say company dot jobs, like get jobs. Okay. And rest of the part, I can just remove it over here. Okay. And here I can say company service or company repository. I'm sorry. And we'll update the company. So we will return true over here. Okay. And if the update fails, we can return false. I can even write this in the else statement, like if you wish to. So instead of adding this outside, I can say else like this. Okay. So if company is present, then update, else return false. Okay, so this works perfectly fine now. Okay, so this is saved. I'll hit save. So I'll head over to the controller now. Okay, now here in the controller, what I'm going to do is I'm going to create a new method like so, and I'm going to say put. So this is the put mapping that I'm creating. I'll have an import over here. Okay, now here I'll say update company like so. Okay, and of course this will have a parameter. Okay, I'll delete this over here. Okay, so after update I'm going to return a string. Okay, and I'll also have consistency over here in terms of returning the response. So I'll add response entity over here. Okay, and I'll say string over here like so. Okay, and here I'll say path variable. So we will have path variable which we'll accept in the form of the path parameter, and this will come in as ID over here. Okay, we also need one more parameter which is request body. So we'll say request body company, and I'll get the company like so. Okay, now here I'm going to return new response entity. Okay, and I'm going to say like company updated successfully like so. Okay, and here I'll return http status dot okay like so. All right, I'll move this to a new line. Okay, now over here we need to update the company. So I'm going to say company service dot update company like so. And here I'm going to pass in the ID and update it. Okay, so update company needs company and ID. Okay, so I have passed in ID and company, so it will be company and ID. This should work. All right, so yeah, this works perfectly fine, I believe, and this should work perfectly fine. And I'll also have the URL over here, so I'll pass in ID. So this will be the request parameter that we will accept, and this path variable will come in and sit in this parameter, and request body will have the company which will come in and which will be triggered to the service. Okay, and within service we are updating everything. Okay, so if you go to company service, here we are updating the company. So let us start working towards creating the functionality to save the companies from the API. So what I'm going to do is I'm going to head over to company service. Okay, and I'm going to define the method over here. So if you remember, if you head over to the job service, we have a method void create job. Okay, so what I will be doing is I'll be defining a similar method over here. Okay, we can paste the similar method. I'll remove this import statement over here which got copied. So I'll say create company, and here I'll say company, and this will be the company object. So we are accepting the company object as the part of the method so that we can save it into our database. Okay, now I'm going to head over to the implementation class, and like always, we are going to get an error immediately. And this error is because we are yet to implement this method. So now here, I'm going to write the code to create the company. So I'm going to say repository dot save, and I'll pass in the company object. So this will save the company for me. So we have defined the service. Now let us head over to the controller. Okay, so here in the controller, so not in the job controller, but we'll go to the company controller. Okay, we don't have it open, I believe, so I'll open it from here. So here in the company controller, we are going to create a method and a mapping to save the company. Okay, So I'm going to say public, and I'm going to have string as a response, and I'm going to say add company, like so. And I'm going to pass in the request body, like so. And the company object will be the part of the request body. And what I'm going to do is I'm going to use the service class. So company service dot create company, and I'm going to pass the company object, like so. Another thing is we are using string here, so I'll change this to response entity. Okay, I'll just copy this response entity and I'll specify string, like so. And here I'll add a return statement. So I'll say return new response entity, and I'll say company added successfully, like so. And I'll pass in the HTTP status code as created, added. So we have managed the add company. Okay, now if you scroll up here also, we are returning the list. So here what we can do is, in order to maintain consistency, I'll add a response entity here as well. And I'll add the closing angular brackets. Okay, and here I'll say new response entity, and I'll pass in this object, and I'll say HTTP status dot okay, like so. Okay, so we have some consistency now. Everybody is returning response entity. Okay, also I will head over to application.properties here, and instead of create drop, so instead of creating the schema every time and dropping it, I'll say update over here. So this is also one of the properties that we have here. Okay, so I'll close this. Now what we can do is we have the code written, and I can run the application. Let us test the changes in Postman. So the application has started. Okay, now I'll move to Postman, and here I will duplicate this particular request, which is for posting the jobs. Okay, so I'll duplicate this. All right, and I'll change this to companies, like so. And here in the body, I'll have title. So we need title and description, or we don't need title, we need name. So it's called name. So I can say company 1, and the description can be description. Okay, so I'll just delete this test over here. So description 1, like so. Okay, and I'll hit save. So before hitting save, I'll just copy this URL and modify the name, and I'll hit save. Okay, now let me run this request. So I run this request and it says method not allowed. Okay, I believe I know the mistake that we did. We have not mapped it to any URL yet. Okay, so we need to map the URL. We need to say post mapping here, and I believe that is it. And I'll rerun the application. So the application runs. Now back to Postman, and I'll run this request, and you will see company is being added. And now if you get all the companies like so, you will see all the companies coming out. Now you're getting jobs as well as a part of the response. Okay, and this is because company is related to jobs. Okay, we can even test the put request or the update request. So here I have the request already created, and this is a put request. You can see I have these parameters in the body, and the URL is trying to update the company with ID 1. Okay, if I send this, you'll get 200. Okay, and if you try to get the company now, you will see the name has changed and also the description has changed. This is about creating the company and updating as well. Okay, so both the functionalities are working perfectly fine. All right. Welcome back. So let us start talking about the relationship between jobs and companies. So when we executed this particular URL wherein we got all the companies, we saw that we are getting jobs as well with it. And the reason for this is because in our source code here, okay, and if you go to company, we have defined the list of jobs, which means that every company has multiple jobs. So one company can have a list of jobs that it can relate to, okay? And that is why we have mentioned this annotation here, one to many, okay? But we have only the relationship created from company to that of jobs. So if you go to the job entity, so I have this open here, we have not defined the relationship with company over here. So job as well relates to a company, right? So what I will do is I'll define a relationship over here. So I'll say private company, and I'll specify the name of this field as company, and I'll specify this as one to many, okay? Now, once we have added the field, we also need to add some getters and setters. So I'll say generate getter and setter, and I'll get the getters and setters added. Now, what we have done is we have created a mapping, like one to many mapping with company to jobs. And so this will be many to one and not one to many. So I'll say many to one because many jobs are linked to one company, okay? So what I have done is I have created a mapping. So this is one to many mapping from company to that of jobs. And then we have many to one mapping from jobs to that of company. Now, if I run the application, let us see the output. So the application is started. And if you take a look at the table structure, okay, so let me refresh this structure here, okay, and let me connect. So you will see there is a jobs table. There is a company table. So if you take a look at the job here, so I'll just expand it over here. So job has this column company ID, as you can see, and company does not have any reference to that of job, but there is a separate table company underscore jobs, okay, which is maintaining the relationship again between companies and jobs. So we don't need this, okay. Like this, there is a separate table as well, and you have the relationship defined in the job table as well. So what I'm going to do is, in order to get rid of that table, I'm going to go to company.java, okay, and I'm going to add a property over here. I'm going to say mapped by, and I'll say company. So what this tells is this particular relationship that exists from company to that of job is mapped by a field called company, which exists in jobs, okay? So since we are creating a relationship here from company to that of jobs, we are specifying that within the job entity, we have a field which is also mapping this particular relationship, okay? And after specifying this, if you run the code, okay, and if you head over to the browser and refresh, so we will have to connect again. You will see that separate table which was maintaining the relationship is now gone. So now the relationship will be governed by this company ID column in the jobs table. Okay. So we are done defining the relationship. Now what we can do is we will head over to Postman. Okay. So I'll open Postman over here. Now I'm going to show you by creating a job. So I'll create a job here. Okay, and I'll say send. So we have created the job, but we have a new field now in the job entity, and we have not added that field over here. Okay, so that field governs the relationship. So if you try to get the jobs over here now, you will get the company object as null. And that is because we have not mentioned any company as the input. Now, what I will do is I will add the company over here. Okay, so I'll say company, and since it's an object, I'll add a pair of curly braces, and within that I'll say ID 1. So we want this job to be mapped or linked to the company with the ID 1. Now, one thing over here is if I execute this, I'm going to get an error. So I got an internal server error. Now, why did I get this? So if I head over to my ID and if I click on the console, you will see a huge stack trace over here. Okay. And somewhere over here, you will see an error which will highlight referential integrity constraint violation. So you can see referential integrity constraint violation. Okay. And this is because of company ID. So what is happening is here you are trying to link a job to a company that does not exist. Okay. So if you try to get all the companies, this company does not exist yet because we have not created this company yet. Okay. So what I will do is I will create the company, but let me tell you that you can also handle this scenario without creating a company. Okay. So you can get rid of this error. And how? So I'll show this to you. So instead of like just passing the ID, you can pass the entire company object. So you can pass the company object over here like so. Okay. So here you have all the details that a company needs, okay, for its creation. And if you go to the code over here, okay, we have company as a part of the job. So there won't be any problem with that JSON. You get that JSON, and in controller, you will have to handle the scenario of company does not exist. Okay. So what you will do is when you are trying to create a job, okay, you can, let me show some code over here. So you can say company C is equal to job dot get company. So what you are doing is you are getting the company from this job object, which you are getting from the request body and which we are sending from Postman. So you will get the company over here, and then you will write a if condition to check if this company exists in the database or not. If it exists, well and good, you create the job itself. If it does not exist, then you create the company first and then create the job. So that is how you can handle it. But I won't be handling this. We don't need to. So how our application will work is we'll get rid of this JSON. Okay. So we will be creating company first. Okay. So I'm going to head over to this another post request where we can create company, and I'll get the companies. I have a company now with ID 1. Now I'll run this query. And now earlier I was getting internal server error. Now I won't get any error. So you can see the error does not exist now and the job was added successfully. Now if you try to get all the jobs, okay, we probably got an error. So what went wrong? Let us check. So if I scroll down, okay, so this is the error that we have got. So it says could not write JSON, infinite recursion, Stack Overflow error with root cause. So I'll tell you what happened. So we have company linked to job and job linked to company. So it's an infinite loop over there. Okay. So here we are trying to get the job which will have the company object, and company object will have the job object as well. Because if you take a look at the company object, okay, so we got an error here as well. Okay. So what we need to do to fix this error is in the company.java. Okay. Here I'm going to say ignore from the JSON. So I'm going to add an annotation, JSON ignore. So this annotation is going to remove those recursive callbacks that we are getting. Okay. So I'll rerun the application. Now here in Postman, I will try getting some companies. We don't have companies. So I'll create the company first and then we'll check for company. We have the company. Now I'll try creating a job, and now it got created successfully. And now if I try to get the jobs, okay, earlier you were getting an error and now you won't. Okay. So you get the job JSON with the company JSON as well. Okay. So this is working perfectly fine. We can even test the update. Okay. I believe update is working perfectly fine, but I'll just try updating and I'll run this. So you can see the update is also working fine. So that's about the relationship between company and jobs. So let us start building the functionality to delete a particular company. And what I would request you all is to take this up as a challenge. You can try solving this or try building this functionality by yourself and then come back and watch me solve the problem. Okay. So I would request you all to pause the video right now. So how did it go? I hope you all had a chance to attempt this challenge. So I'll begin with the solution here. So we are first going to create a method in the company service interface, and then we are going to implement it into company service implementation class. So we are going to start with the service layer. So I'm going to say Boolean, and I'm going to say delete company, like so. And I'm going to say delete company by ID, because we are going to need ID over here. So I have this method created. Now, if I switch over to company service implementation, I'll get an error. And I'll say implement methods, and I'll say OK. So here I'm going to write the code to delete the company by ID. Okay. So I'm going to say here company repository dot delete by ID, and I'm going to pass the ID, which is of long type. Okay. So I've done this. Now we are supposed to return a Boolean. Okay. So if the company exists in the database and if it's deleted successfully, then we are going to return true, else we can return false. So I'm going to write an if condition. Okay. And I'm going to say company repository dot, I'll say exist. So you can see exists by ID is a method here. So this will check if the company exists in the database. Okay. And if it exists, I'm going to call in this method here. Okay. And I'm going to say return true. Okay. Like so. So if the company ID exists, then we are going to delete the company and then return true. Else I'm going to return false. So I can say else, and I can return false from here. So this is done. We have set up the service layer right now. Let's head over to the controller and let us create a method over here, which will map to a delete request. So I'm going to say public void and delete company. Now to delete the company, I'm going to need the ID over here. So I'm going to say long ID, and I'm going to accept it from the path variable. Okay. And here what I will do is I'll say Boolean is deleted. So I'm checking if the company was successfully deleted by the service layer. And I'm going to say service dot delete company by ID, like so. Okay. Now based on the value of this Boolean variable, I can say return new response entity. So we need to return response entity. We have mentioned void here, but we should return response entity, and I'll say response entity as that of string. Okay. And here I'm going to say if is deleted, I'll say company successfully deleted, like so. And I'm going to say HTTP status dot OK. All right. And so this is done. Okay. So here I'm going to say else. Okay. The else block is going to talk about return, and I'll return this same response entity object. Okay. But here I'll say company not found. And instead of OK, I'll say not found over here. Okay. And we need to map this particular method to a request. So I'm going to say /ID. So this is mapped to delete mapping over here. Okay. Now I'll rerun the project and let us see how this works in the browser. Okay. Now here in the browser, I'm going to head over to the delete request that we have for jobs. I'm going to duplicate the delete request. Okay. And instead of jobs, I'm going to have companies, like so. I'll copy this and I'll paste it over here. So we have the delete request created for companies. Now if I send this, we get not found, like company is not found is the message. And this is because no companies exist in the database. Fair enough. Now, what I can do is I can create a company. So let me create a company. We created the company. Let us check. So this has the ID 1. Now let me delete this one. Okay, so earlier we got 404 not found. Now if I trigger this, we have company successfully deleted with 200 OK. And now if you switch over to companies, you get an empty array response. Okay, so this is how the delete functionality will work. Hello everybody. Let us start building the functionality to get a particular company. Okay, so I'm going to define this functionality starting from the service layer. So let us open the company service. So also I would request you all that since we have already done the jobs functionality, you can take this up as a challenge and try to write code yourself. And once you are done, you can come back and watch the solution and compare the code. Okay, so pause the video right now and attempt this as a challenge. Welcome back. So I hope you got a chance to attempt this. Okay, now what I'm going to do is I'm going to start by defining a method here in the company service. So I'm going to say company and I'm going to return. So I'm going to say get company by ID, like so. And this will be long again. Okay, long ID here. Okay, I'll hit save and we'll head over to the implementation class to implement the method that we have just defined. Okay, so over here now what I'm going to do is return. I'm going to make use of repository, company repository dot, I'm going to say find by ID over here. And you can see find by ID here returns an optional. Okay, so if you take a look here, this one is optional, the return type here. So I'll select this, I'll pass in the ID. Okay, and I'll say dot or else null. So if the company ID is found, then we return the company, or else we return null. Okay, head over now to the controller. So here in the company controller, I'm going to define the method first. So I'll switch over to the end. I'll move to the end of the code and I'll say public company get company. Okay, and here I'm going to say path variable and I'm going to say long ID, like so. Now we have defined a similar method in the job as well. Okay, so if you take a look over here, so this is the method wherein we get the job, and if it's null, based on the value of job object, then we return different responses. So we are going to write some similar logic. So I'm going to get the company first. Okay, I'm going to say company is equal to service dot get company by ID, and I'm going to pass in the ID. And then I'm going to say if company is equal to or is not equal to null. Okay, then I can say return, I'll say new response entity. Okay, and here I'll return the company object and I'll also return the status. So I'll say http status dot okay. Now the problem is we are returning response entity, but here we have said company. So I'll change this to response entity of company type. Okay, now this is done. Now let me add the else clause over here. So I'm going to say else, and here I'm going to return new response entity. I'm going to say company not found, like so. Okay, and here I can say http status dot not found. Okay, so we are getting an error because we are returning the response entity of company type. So we'll have to do away with this string here. So I'll just remove this and I'll hit save. Okay, now let us rerun. Okay, 1 second. So I'll hit cancel, Before rerunning, we also need to map this particular method to the mapping. So I'll say get mapping slash, okay, like slash, and I'll say ID here, okay, and then I'll run this code. So let us run and see the output. So the project is running. Now over here, I'll duplicate this request, which I have for jobs. Okay. And I'll say company over here. Okay. And I'll copy the companies or I'll copy this entire URL and I'll add it to the name and we will hit save. Now let us try to retrieve the company with ID 4. Of course, this does not exist, so we are getting 404. Now let us create a company. So I created a company, company 1. Then I'll create one more company, company 2. Let us get all the companies. So you have 2 companies now, 1 and 2. Now let us try getting a company. So I'll get a company with ID 1 first. We are getting it, okay. With 2. We are getting it, and if you add 3 does not exist, so we'll get 404. So this is how you can work on the functionality to get a particular company. Welcome to this class. So this is the APIs that we have for working with reviews. So we have the get request to get the reviews against a particular company. Okay, and if you notice all the API requests, we have company ID associated. Okay, so we have post request to add a company, we have get request to get a single review, put request to update a review, and delete request to delete a particular review. So this is going to be similar to the jobs functionality and the company functionality that we have built. We will even have a relationship between company object and the review object, or company entity and the review entity, where we will have one-to-many and many-to-one mapping between these 2 entities. All right. So that's about reviews, and let's get started. So now let's begin with reviews. And what we are going to do is we are going to start defining the review controller, service, and the repository. All right. So I'm going to head over to my project structure. I'm going to collapse all of this. So what I would request you all is you all can take this as an exercise and define all of this yourself. And you can do this by pausing this video right now and attempting it yourself. This will give you some hands-on practice, and then you can come back and watch the solution. So I'll say package, and I'll create a review package. Okay. Now within this review package, I'm going to create a new controller. So I'm going to say review controller, like so. Okay. And I'm going to have one more, which will be a service. So the service will be interface. Okay. So I'll say review service, like so. And then I'm going to have the review repository, which is going to be the interface again. So review repository, like so. So we are done defining the files that we need. Now I'm going to create a class, okay, which will be in implementation package, and I'm going to call this as review service IMPL. Okay. And this particular class is going to implement review service, like so. Okay. Now what we need to do is in the review controller, okay, I'm going to map this as REST controller. Okay. And I'm going to say request mapping over here, and I'm going to say companies / company ID here, like so. Okay. So all the endpoints with this URL will be routed to this particular controller. Okay. And then I'm going to define the review service. So I'm going to say private review service. Okay. and I'm going to say review service here, and we are going to add a constructor. So I'm going to generate constructor for review service. So this will be injected on the fly by Spring. All right. So this is about controller. Now in the review service, we are going to leave things as it is, because here is where all our methods are going to be declared. And then in the implementation class, we are going to define that as the service. So here is our implementation class, and I'll call this as service. Okay. So that Spring Boot knows that this is a service and it is supposed to manage it. Okay. Now in the repository, I'm going to extend it with JPA repository. So I'm going to say extend JPA repository. And here I'm going to add a review. And I'm going to say long. So this is of long type. Okay. Now we don't have the review entity created yet. Okay. So we need to define the review entity as well. We have not yet defined the review entity. So I'll hover on this and I'll say create class review. Okay. So you will see this pop up and I'll say okay. So you can see this class was created in the same package here. All right. And now here I'm going to define the structure of reviews. So I'm going to say private long ID. I'm going to say private string title. So review is going to have ID, title, and it is also going to have a description. Okay, so I'm going to say description like so. And I'm going to say private double rating. So it is going to store the ratings as well. So I'm going to keep the reference to rating. Okay, so this is done. Now what I'm going to do is I am going to create the getters and setters. Okay, so I'm going to say generate getters and setters for all. Okay, so this is done. So we have the entity as well set up. Also, since we are managing this with the help of JPA, or we need to get this to the database, I'm going to call this as an entity. Now the moment I call this as an entity, I need a default constructor. So I'll create a constructor and I'll say select none. So it will be a default one. Okay, and here I'm going to say this will be the ID and this will be generated. So we are not going to manage or generate the ID. It is going to be auto generated with the strategy of identity. Okay, so generation type will be identity. Okay, so I believe that is it we had to define. Okay, so we are done setting up of controller, the service, the repository, and the review entity as well. And this can help us get started for building the review functionality. All right. So that's about this class. I shall see you all soon. Thank you. So let us define the relationship between the review entity and the company. Okay. So what I'm going to do is I'm going to head over to class review.java, where we have the review entity defined. And here I'm going to link this to a particular company. So one company will have many reviews. Okay, so it will come across as private company like so. And we have company. And what I'm going to do is I'm going to map this as many to one. Okay, so this will be many to one mapping. And I'm going to mention JSON ignore over here. Now, there is a reason I'm mentioning JSON ignore, because we will be having the same linking in the company.java as well. So here, if you go to the company.java, here we have the linking wherein we are saying like one company has multiple reviews. Okay, and I'll get this imported over here. Okay, so this will be one to many. And here also I can include the mapped by. Okay, I can say company over here. Okay, so it will be company only because here I'm mentioning the company. Okay, so this is how the relationship between review and company will work. After defining this, we need to create the getters and setters as well. Okay, so I'll just come over here and I'll generate the getter and setter for company. I'll hit save, and in the company.java as well, I'll generate the getters and setters. So we have the relationship set. Okay, let's move on to next. Let us start defining the functionality to get all the reviews for a particular company. So what we are going to do is we are going to head over to the controller, and the URL that we are going to have is /companies/company ID followed by /reviews. And whenever anyone calls this particular URL with a GET request, we are going to return the list of all the reviews for the mentioned company ID. So we'll begin with the service class. Okay. So here in the service, I'm going to have an implementation, and I'm going to say list. So the return type is going to be review. Okay. So we are going to return a list of reviews, and I'm going to say get all reviews like so. And I'm going to return long. So I'm going to accept, not return. So I'm going to accept a company ID. So this company ID will tell us we want reviews for which company, and then we will return the list of reviews in this format. Now heading over to the implementation class. So I'll open the implementation class for this. Now here you'll get a red mark, which indicates that you need to implement a particular method. And after implementation, the error goes away. Now, how do we get all the reviews for a particular company? Okay. Now, for doing that, we will need to say, so I'll say list review. So we need list of review, and I'll call this as reviews, is equal to review repository. So we have not created the repository object yet. Okay. So I'm going to say private review repository and review repository, and I'm going to also add this to a constructor. So I'll generate a constructor. Okay, so Spring Boot will make sure that it auto injects the instance of this on runtime. Okay, and here I'm going to say review repository dot find by. So we need to find by company ID, right? And you can see there is no method for that because this is a custom method that we are trying to use. So JPA repository has a lot of standard methods in, but sometimes you will need to have a custom method. So here we need find by company and then ID. And we need company ID as the parameter. Okay, so this is the method that we are looking for, wherein we are trying to find the reviews by company ID. Okay, and this does not exist. Okay, so what we need to do is we need to tell JPA to give us this method. But how do we tell JPA to give us this method? Because this does not exist. So do we have to write the implementation? Absolutely no. So what we will be doing is here we get a solution. So Intellij is telling create method find by company ID in review repository. So I'm just going to do this, and it is going to create this particular method for me in the review repository. Now we don't need to define the implementation for this because this is an interface. Just by declaring it over here, we are telling JPA that it needs to generate the implementation of this on runtime. Okay, and with this declaration, Spring Data JPA automatically generates an implementation for this method at runtime. Okay, and how does it know what the functionality should be? So it breaks down the method name. So here, if I copy this method name, okay, and if I switch over to Notepad, so what it will do is it will say find by. Okay, so find by means we are looking to find something and we are trying to find it by something. Okay, now what is that by? So here company ID is one field that we have. Okay. So if you run this entire project, you will have company ID in the database. Okay. So we are telling Spring Data GPA that we need to find this entity, all the entities, okay, all the instances of this entity. So review, since we are writing it in the reviews repository. So give us all the records by company ID. And company ID is a field in the review. Okay, so if you go over here, we have mapped this to company over here. Okay, so this is how it breaks down, and on the runtime, it breaks it into this query. Okay, so here I have this notepad, another notepad, where this particular method will be translated to this particular query here. So it will say select star from review where company ID is equal to question mark. Okay, and when you call this particular method like this, so when you say review repository dot find by company ID 1L, so this is one long. Okay, then this question mark is replaced by 1L. Okay, and this is all handled on runtime, so you don't have to bother. Okay, you have to just make sure that you have a field company ID in this particular entity. Okay, and since we are mentioning the many to one relationship here, we will have company ID when this is converted into the table format. Okay, so we have defined this. Okay, and it's up to Spring Data GPA to give us the implementation on runtime. All right, so what we are doing now here, back to review service implementation class. So we are using this particular method. Okay, and we are trying to get the list of all the reviews. Okay, and what we are going to do is we are going to return all the reviews. So I'm going to replace null with reviews. Okay, and we are done. So we have written the method which enables us to get all the reviews by company ID. Okay, now we are going to use this particular method in the controller. So let us switch over to the controller. So here in the controller, okay, I am going to define a method, and let's say the method is public, and I'm going to say response entity, and I'm going to say list of reviews. Okay, and I'll say get all reviews, and here what I'm going to do is I'm going to accept the company ID as the path variable. So that is what we are getting as the path variable over here. Okay, so I'm going to say @path variable and long. Okay, let me scroll up. I'll say long, and I'll say ID. Now I'm going to say return, okay, response entity, and I'm going to say, okay, this will be new response entity, and I'll say this can be like review service dot get all reviews, and I'll pass in the ID and the HTTP status as okay, like so. Okay, so we have this implementation defined now. Okay, and I need to map this to a URL. Okay, so I'm going to say get mapping here. Okay, and this will be going to /reviews. So we are going to say /companies /company ID /reviews. So that is going to be the URL structure, and I'll hit save, and let me run this code now. Okay, let us try testing this in our browser. Okay, so if you head over, so we have not defined the endpoint for creation of review yet, but let us test this. Okay, so I'll duplicate this jobs URL. Okay, and here I'm going to say companies /1/reviews, and I'm going to paste it over here, and I'm going to send the request. Okay, so we got an internal server error. Okay, So it said required URI template variable for method parameter long not present. Okay, so where is this error coming in? So I understood what the error is. Here we are saying ID, but here we are accepting it as company ID. So I'll change this to ID over here. Okay, or let us keep as company ID because we have two IDs now, like the review ID and the company ID as well. So I'll take this as the company ID here. And here we are getting a warning, okay, because we have missed like these angular brackets. Okay, so I'll rerun this code. Let us see what the output looks like now. And now if I do a send request, you will get an empty list of arrays which represents the reviews for a particular company. So right now we don't have any data, but once we have any data, we will see an output over here. So yeah, that's about how you can get all the reviews for a particular company using the review controller, service, and entity. Welcome back. So let us start working on the functionality that will help us add reviews to our application. Okay, so I'm going to head over to the review controller and we are going to talk about the endpoint. So the endpoint that we are going to have is companies/company ID, and I'm going to say /reviews. And in the request body, I'm going to have the review object. Okay, so let me add the post mapping over here. So I'll say post mapping. Okay, and we have the first part of the URL defined here. So it's companies/company ID. So this indicates like against which company we are adding the review. Okay, and then I'm going to say /reviews like so. And I'm going to say public, and I'll say void, and I'll say review, like add review, something like this. Okay, and we are going to have request body, which will be a review object. Okay, I'll say review. And also we have a path variable that we have added in the URL. So I'll say path variable, and it will be of long type, and it will be company ID like so. Okay, so this is what our method is going to be, and this won't be void. So we will add a response entity over here. Okay, so I'll say response entity like so. Okay, so this is what the endpoint is going to be. Now, here are two things we need to keep in mind. We are accepting the company ID and we are accepting the entire review object. Now, why are we accepting the company ID? Because if you go to the review entity, to save a review, you need the company object. Okay, so using this ID, we are going to fetch the entire company object and we are going to add it to the review. So this review that we are getting, we are going to add it over there. Okay, so I'll head over to my review service over here. Okay, and I'm going to define a method over here. So I'm going to say void add review, and I'll say long company ID. So this will have company ID, comma, review like so. Then I'll head over to the implementation class and we'll get the methods implemented. Okay. Now what I'm going to do is I am going to define this particular method. So the step number one would be to get the company object. Okay. So we will say company, and I'll say company is equal to company service. So here is where the problem starts. Okay. So in order to fetch the company, we need company service, which does not exist in review service. Okay. So what we can do over here is I'll create an instance of company service. So private company service here, and I'll say company service, and I'll add that as a parameter over here. So I'll say company like so. Okay, And over here, I'm going to say this dot company service is equal to company service, like so. Okay. So we have this defined. We are getting a small little warning here that this can be final. Okay. So we can take this suggestion and okay, so here it's saying it can be final. So I'll define this as final again, like so. And it says is never accessed. Okay, so we will be accessing it shortly. So I'll say company service here dot get company by ID, and I'm going to pass the company ID over here. So we have the company object come up here. Now I can say if company is not equal to null, let's say, okay. So we'll write the not null condition first. I'll say review dot set company, and I'll set the company object over here. Okay. And I'll say return review repository dot save, and I'll save the review here, like so. Okay. Okay. So we should not return this. Okay. So I'll just add it over here, and I'll say I'll skip the return statement. So we don't need a return statement because the return type we have said anyways, it's void. Okay. So this is done. Okay. So the review object is saved over here. And now if you head over to controller, we need to make use of this review object. So I'm going to say review service dot add review, and I'm going to pass in the company ID, comma, review, like so. Okay. And I'm going to return. Okay. So return new response entity. Okay. Review added successfully. Okay. And I'll have HTTP status dot okay, like so. Okay. Now I'll run this code. Let us run this and let us see what it looks like. So the application has been started. Now we'll switch over to Postman, and I will duplicate a post request here. So I'll just duplicate this companies post request. So we have companies /1/reviews. Okay. And I'll copy this endpoint and add it over here. Okay. And I'll also save this. Now here in the body, we need to add the data. So review has title, it has a description. So I'll say title is review 1. Description is description 1. Okay. And here the rating is 5.0, like so. Okay. So we have defined this, and what we can do is we can trigger this. So let us trigger. Okay, so it says review added successfully, but I believe there's a problem. So let us get the reviews endpoint. So here, if I try fetching the review, it's not added. And the reason for this is the company with ID 1 does not exist. Okay. So we need to handle this scenario wherein how a review is managed if the company does not exist. Okay. So to handle this, what I'm going to do is I'm going to make add review return Boolean here. Okay. And I'll head over to the implementation class. Okay. So here review service implementation. This will also return Boolean then. Okay. And if the company is not equal to null, we will return true. Okay. Otherwise, I'll say we return false. So what is happening is if the company object is found, we add the review, we save the review and return true, else we return false. So false means company object does not exist. Okay. So I'll head over to the controller now. So I'll switch over to the review controller here. And now here we have this returning Boolean. So I can say Boolean is review saved. like so. And here I'll add an if condition. I'll say if is review saved, then you need to return this response entity. Okay. And here I'll say else. And if this is false, then we will say review not saved, like so. So you can add any message that you want. Okay. So I'll say review not saved, and I'll say over here not found. Okay. Let us rerun this and let us test the changes. So the application is deployed now. Now let us try adding the review. Okay, so we are doing a GET request. Let us head over to the POST request here. Okay, and let us try adding the review. So you will get this 404 not found, which says review not saved. And that is because company 1 does not exist. How do you fix this? You create the company first. So I'll create this company here. Okay, company added. Now, if you get the list of all the companies, okay, so if I get the list of all the companies, you have one company, okay, but it does not have any reviews, like you can see. Okay, so what I will do is I will do a post request here and I'll add a review against the company. So the review is added successfully. Okay, now if you try to get all the companies, you'll see you have a review being come up with the company. Okay, and if you try to get all the reviews as well, so if I go over here, okay, and if I try to get the review against a particular company using a GET request, I get the review as well. Okay, so this is working perfectly fine, and the scenario that we faced is very well handled. All right, so that's about how you can add a review against a company. Also, one thing I wanted to mention here, we are using the company service. So here, if you go to the implementation class, we are using the company service in the review service over here. And this is common if you have all the services for different entities in a single project. Okay, so you will use these services across the project. So if you have a large project, there is a possibility that you would add a dependency on a company service in your review service implementation class and use that to get the company data. All right. So this is about how you can add reviews to the company. So let us start building the functionality to get the review, like a specific review for a specific company. So what we are going to need is, we are already getting the company ID here in the parent URL of this controller. And then we are going to even get the review ID from the user. Okay. So what our URL is going to look like is, it will be a get mapping. Okay. And I'm going to say over here /reviews/ I'll say review ID. Okay, like so. And I'm going to select all of this and put this in round inverted commas. Okay, so here I'll say public and I'll say review, and this review needs to be wrapped in the response entity class. So I'll say response entity and we'll have review, and we'll say get review here. Now we are accepting a path variable which is long ID, and this ID is company ID. So I'll just be specific here. Okay, and then we are accepting another path variable which is long, and it is review ID, like so. Now here we are going to make use of a service class, okay, and we are going to get the specified review. So let us head over to the service class and let us define the implementation for the same. Okay, so I'll close all of this and I have review service implementation open here. Okay, so I'll go down, or before going to the implementation, we need to also define the method over here. So I'm going to say review, and I'll say get review, and I'll say long company ID, or I can simply copy. The parameters will be same over here. Okay, so it will be this, and then long review ID, like so. Okay, then let's head over to the implementation class and we will get the methods implemented. Now here we are going to make use of the get all reviews method. Okay, we'll be calling this method internally. So we'll get all the reviews that exist in the table, and then we will filter it with company ID. Okay, so we can say review repository dot find. Okay, or you can find by company ID as well directly. Okay, so I'll say find by company ID, and I'll pass the company ID over here. Okay, so what are you going to get as the response? So you're getting the list of reviews over here. Okay, which is fine. So you can either use this method over here. You can call get all reviews. Okay, and you can pass in the company ID. Okay, or you can directly use this method, which internally anyways this method is using it. Okay, so we straight away use this method, and I'll say list, and I'll say review here, and I'll say reviews, like so. Okay, now what I will do is I need to filter these reviews and get the review with this review ID. Okay, so I can say return, and here I'll say reviews dot. So I'll make use of streams, which is a Java concept. So I'll convert this list of review into stream for filtering purpose. Okay, now I'll say dot filter, and I'll say review. Okay, so I get an auto suggest here, and I'll say review dot get ID dot equals review ID, like so. Okay, and then I'll say dot find first. Okay, so it will give us the first result from the filtered result set. Okay, and then I'll say or else null. So if nothing is found, we return null. So what we are doing is we are converting this list for filtering purpose into a stream, and then we are applying the filter on the stream, wherein we are specifying the condition as review.getID equals to review ID. Okay, and we are getting the first one from this filtered, and then if there is no object found or nothing found, we return null. So that is how we are working with this. Okay, and with this one line of code, it's all done. Okay, so this service is defined. Now what we need to do is we need to go to the controller. Okay, so I'll go over here, and here in the controller I'll say return, and I'll say review service dot get review, and I'll pass in the company ID comma review ID, like so. Okay, and we will wrap this into the response entity. Okay, so let me add a response entity class over here. Okay, and I'll say like so. Okay, and I'll say new over here. So we need to create the object as well. Okay, and we need to add the status code. So I'll say http status dot okay. Okay, I messed up with the brackets, so I need to close the bracket here. So this looks perfectly fine. Okay, so what we are doing is we are returning the response entity object where we are getting the review by calling this method, and then we are returning the HTTP status. Okay, so I'll run this and let us test this in our browser. Okay, or not in the browser, we'll use Postman. So you can test it in the browser as well. It's a get mapping, but we'll make use of Postman. Okay, so the endpoint is a get endpoint. So I'll just duplicate this one. Okay, and I'll say companies /1/reviews/ so let me run this. So you don't have any reviews, so you can pass the review ID, and I'll paste that over here. Okay, and I'll hit save. So we need to create the reviews first. Okay, so I'll close all of these tabs. Okay, so I'll say close all the tabs and I'll get the changes saved. So we have this one tab open. Okay, now I'll create a review. So I'll first create a company and then I'll create a review. Okay, and then I'll go over here and I'll try to get a particular review. So you can see we are able to get one review, and this is not being returned as an array. It is being returned in the JSON format. So if you try to get all the reviews, you'll get in the form of arrays over here, as you can see. But since we are getting a specific review, we are getting it in the form of just the normal JSON, which is not an array. Okay, so this is how you can work with or build the functionality to get a specific review against a particular company. Let us start writing some code to enable users to update a particular review. So what are we going to need from the user? So we are going to need the company ID, the review ID, and the review itself. So if you head over to controller, so we are already in the controller. So we are going to need the company ID. Okay. And then I'm going to define a put mapping here. So since it's an update request, it will be a put request. Okay. And I'm going to say slash, and this will be reviews slash review ID. I'll select this entire thing and I'll put this as a string over here. Okay. Now what I'm going to do is I'm going to create a method. I'm going to say public void, or I should say response entity string, and I'll say update review. Okay. And here I'll be accepting a path variable, of course, which is company ID. Okay. So I'll just copy this. We'll need both these parameters. Okay. So I'll paste that over here. Okay. And we will need one more parameter, which is review itself. And that will come as a request body. Okay. So I'll say review and review. Okay. So this is what our method is going to look like. Okay. And of course, we are going to return saying new response entity. I'll say review updated successfully. And then we can have HTTP status dot OK. Okay. So this is done. Now there is a reason why we are accepting the company ID, review ID and review. So review ID tells us which review is supposed to be updated. The review object tells us this is the new updated review. Okay, so we are getting new updated review from this. This tells us which review is to be updated, and company ID enables us to fetch the company against which we are updating the review. So if you remember in review.java or the review entity, we have the company object. So we need to fetch the entire object based on the ID that we get from the user. So I'm going to head over to the review service implementation here. Or before going over here, I need to also define a method over here. So I'll say void, I'll say save review, or update review would be a better name. So I'll say update review. Okay. Now here I'm going to accept company ID, review ID, as well as the review itself. Okay. And I'll end this with a semicolon, and I'll head over to the implementation class and I will implement the methods here. Okay. So this is done. Now let us start defining the logic over here. So what we are going to do is we are going to say if, I'll say company service. So first we will check if this particular company exists or not. Okay. So I'll say if company service dot get company. So when I say get company, I have this method get company by ID, to which I'll pass company ID over here. I pass in the company ID, I get the response. Now we need to validate this in the if statement. So I'll say not equal to null. So this method is executed. Sorry, not this method, but this statement is executed only if company ID is not equal to null. Okay. And I can say over here, so this is the updated review, right? So I'll say updated review here. Okay. So what I will do is I'll say updated review dot set company, and I'll say company service dot get company by ID, and I'll pass in the company ID here. Okay. And I'm going to say updated review dot set ID. So I'll set the review ID as well, and the review ID is the review ID itself. And then I'm going to say review repository dot save. Okay. And we save the updated review. Okay. Now the thing is, we can even give some feedback mechanism over here. So if this is done, then we can say return, and I'll say true over here. Okay. We can return Boolean. So that's the feedback that we are giving to the controller, or else I'll say return false. Okay. And I can return a Boolean value, and I can convert this to Boolean here. Okay. And this we are doing so that we can also show 404 if we get the false as the result. Okay. So here in the service, I need to update this here. Okay. So once I update, the error goes away. Okay. Now, since we are getting the Boolean result from the service, okay, what we are going to do is in controller, I'm going to say Boolean is review updated, like so. And I'm going to say review service dot update review, and I'll pass company ID, comma, review ID, comma, updated, or review. I'll just mention review here, and I'll just align this a bit. Okay. Now what I'm going to do is I'm going to say if is review updated. Okay. So if review is updated, or I don't need braces over here, so I'll just cut this and I'll paste it over here. Okay. So review has been updated, else I'll again paste the same thing, and instead of okay, I'll say not found and review not updated. Okay. And I'll remove successfully over here. Okay. So this is a code that enables us to update the review against any company. So I'll rerun this. Okay. Let us see the output. So we have the application running. Now what I'm going to do is I'm first going to create a company. Okay. So company created, and I will add a review as well against the company. Okay. Now what I'm going to do is I'm going to duplicate this request, and I'm going to convert this into a put request like so. And I'm going to say, so here the URL will be companies/company ID reviews/review ID. So I'll say 1 over here. Okay. And I'll update the name of this request. Okay. Now here we'll pass the updated review. So this is the updated review that we are sending in the body. So take a look at the put request. We have put, then review, and then we have the JSON body. So this JSON body signifies the fields that we need for review. Okay. And here we have, this is company ID and this is the review ID. Okay. So what I'm going to do over here is I'm going to add the updated string over here, updated, so that we know like the review has been updated. If we keep the update and the old one same, you won't know. So I'm going to send this. You get 200 okay. And if we say, let's say, if we say 2 over here, okay, then you get 404, like review is not updated. Okay. So this is working fine. Okay. I'll just press Ctrl C and I'll hit save. Now let us try getting the reviews. Okay. So if we get this review here, you'll see that it is being updated. Okay. So this update functionality is working well. Okay. And we are able to update the review right from Postman with the help of post request, and that too against a particular company. So this is about the update review functionality. So let's start writing some code to build the delete functionality for the reviews. So what are we going to do is we are going to enable the functionality which will help us delete the review against a specific company. Okay. So we are going to accept. So we are going to go to review controller and we will be accepting a couple of parameters from the user. So first parameter is the company ID, of course, which we are getting over here. Okay. And then we are even going to get the review ID. So I'm going to say delete mapping here. And I'm going to say /reviews/review ID. Okay. So this is a mapping that we are going to have. And I'm going to say public and response entity. And this will be Boolean. Okay. And let me add Boolean here. And here I'm going to say delete review. And so we don't need to return Boolean here. So I'll say string here. Okay. And here I'm going to accept two path variables. Okay. So I can copy it from here. All right. And I'll paste it over here like so. So this is going to be our function. Okay. And on successful deletion, we are going to return a new response entity object. Okay. So this is how it's going to be. So let me paste this over here. So is review deleted is going to be the variable, and I can create a local variable is review deleted. Okay. And here I'll say review deleted successfully, or I can say review not deleted. Okay. So this is going to be the controller. And here now I'm going to assign this Boolean variable a value which will come in from the review service dot delete review. So this method does not exist as of now. So we need to create this method. So to create the method, I'll hover on this and it will say create a method delete review in review service. Okay. So we define this over here. Okay. And then if we go to review service implementation, you can get it implemented here. So now what I'm going to do is we have company ID and we have the review ID as well. So first I'm going to validate this company ID and review ID. So I'm going to say if, okay. So I'm going to say company service dot get company by ID, and I'm going to pass in the company ID here. Okay. Now I'm going to add a condition here if it's not equal to null. So if this is not equal to null, okay, and review repository. So let me move this to the next line, and review repository dot exists by ID, and I'm going to check for review ID. Okay. So if these both conditions are true, only then I'll start entering this if statement. Okay. And within this if statement, I'm going to start writing the code that will enable me to delete this particular review. So now deletion will have some steps. So first we will have to retrieve the review object. Okay. So I'm going to say review is equal to review repository dot get review, or I'm going to say find by ID. Okay. So this is going to be find by ID, and I'm going to pass in the review ID here. Okay. So we are going to get the review first. Okay. Okay. So this is optional. So I'm going to say dot or else null. So null won't be, so we won't get null over here because we are already checking if this review exists or not. So it definitely exists, and we are going to get an object over here. Okay. But we will say company over here. So here we'll have to get the company object. So I'll say review dot get company. And the reason we are getting the associated company is because we want to remove the review from the company as well. Okay. So if you notice over here, in the company object, so let me head over to the company object. We have the list of reviews, and in the review, we also have a company. So it's a bi-directional mapping. Okay. So what I'm going to do is I'm going to say get the company for us, and I'm going to say company.getReviews.remove, and I'm going to say review like so. Okay. And then I'm going to say company service dot update company, and here I'm going to pass in the updated version of company over here. Okay. Okay, so this requires more parameters, I believe. Update company, so it says company and then so company and the ID it has. So I'll say company comma the company ID like so. Okay, so this is done, and then we need to make use of review repository dot delete by ID, and I'm going to pass in the review ID over here. Okay, and with all of this I'm going to return true like so. Okay, and else if this is not a match, then we return false over here. Okay, so what we are doing is we are first retrieving the review, then retrieving the company as well. Okay, and then we are like removing the review from the company reference. Okay, because it's a bidirectional mapping, and then we are updating the company, and then finally deleting the review. Okay, so this is done. Now let us switch over to the review controller. So review controller is all set. Okay, no changes needed over here. Let us run this and let us test how this goes. So the application is deployed. Now here I'll duplicate a request. Okay, so what we need to do is we need company ID and the review ID. So this request I'll just duplicate, okay, because it's a similar request, and I'll change this to delete, and I'll give this name here. Okay, so we have this delete request. Now if I hit send, you'll get 404 not found because there are no companies and no reviews as well. Okay, so first thing first, I'll start creating a company. So I'll create this company and then another company. So there are two companies now. Now if you try to get the list of companies, okay, you will get two companies for now. They don't have any reviews yet. So I'll start posting reviews. So against company 1, I'll add review 1. Then against company 2, I'll add a review again. Then against company 2, I'll add a review with an updated JSON over here. Okay, so this is JSON. Okay, now if you get the list of companies, you will have a couple of reviews. Okay, so the company 2 has 2 reviews and the company 1 has 1 review. Now let us try deleting. So here, so this is where is the delete request? So this is a delete request that we created. We need to hit save for it to appear here. Okay, so we are saying delete the review against company 2 and delete the one with review ID 1. Okay, so I'll send this and we get an internal server error. So let us check what the error is. So we got the error, and the error was essentially because we were not removing the references to a review completely. So how do we fix the issue? So what I did is I added review.setCompany as null. Okay, so this removed all the references in both the ways, like from the company side as well and from the review side as well. So to reiterate, we are getting the company, then we are removing the reviews from using this particular method, and I'm also explicitly setting the company as null over here using this method, and then we are updating the company and finally deleting the review from the database. Okay, so with this I'll rerun the changes, okay, and we'll test these changes in Postman. So in Postman, I'll first create a company. So this is company 1, and then again I'll create a company 2. So 2 companies have been created. Now I'll add a few reviews. So I'll add review 1 over here, like so. And then I'll add review 2, like so. And now we'll try to get all the companies. So I'll get all the companies, and you will see that we have 2 companies, but first company has 2 reviews. Now let us delete the review 1 from company 1. So I'll go over here and I'll say delete review 1 from company 1. So I'll send this, and the review has been deleted successfully. If I put any incorrect number, like if I say 5, which does not exist, you will get an error that it's not deleted. Okay, so this is done. Now if you try to get the companies, you'll find 1 review missing. And if you even run a separate get query, so if I expand this a bit, if you run a get query to get a particular review, so let me get a review. So review 2 exists, but we deleted 1 for 1 company. So that won't give any output. Okay, so this is how you can work on the delete functionality. All right, so that's about this class, and I shall see you all soon. Thank you. So let's start talking about what is a Spring Boot actuator. So Spring Boot actuator is an integral part of Spring Boot applications, and it provides built-in production-ready features to monitor and manage your application. So basically, it's an interface or a tool that you can say using which you can monitor and manage your application. It gives you insight about your running application as to what is happening with it. And you can have like a dashboard or a panel on your application, which lets you what's happening when your code is being executed. So you can think of this like a dashboard that you have in front of you when you're driving a car. Okay, it will show you all sorts of useful information as to how fast you're going, the speed, how much fuel you have left, the temperature of engine, and so on. So essentially, it's showing you the health of the car. And that is what Spring Boot Actuator aims to provide you. So Spring Boot Actuator provides a similar dashboard for your Spring Boot applications, and it lets you peek inside your running application to check things like application health, metrics, the information of the applications, and many more things. Okay, why is this so important? So if you're running your application in production, having the ability to monitor and manage your applications is crucial. And Spring Boot Actuator exactly gives you that. So when you're building a Spring Boot application, no client or your company won't tell you to have a dashboard like this. You as a developer are responsible to make sure that your application is up and running. So this is like a dashboard which developers or engineering team in the backend can use to keep a status check of whatever is happening with their application. Now Spring Boot Actuator comes with number of features, and it includes a lot of built-in endpoints that can give you a wealth of information about your application that is running. So this is the number one feature, which is it has tons of built-in endpoints. Then it has the ability to view real-time metrics. So you as a user get a dashboard wherein you can view real-time metrics. Okay. And there is an endpoint for this /metric endpoints. And it offers you a detailed look at your application metric like your CPU usage, as well as application specific features such as number of active database connections and so on. So despite having so many features, it is also customizable in the end. Okay, so you can create your own endpoints, modify the contents of existing endpoints, and even control the security. So you can add a security aspect, or you can control who you want to access the actuator. Okay, so essentially Spring Boot Actuator gives you something ready out of the package or out of the box, which you can plug into your application to keep track of whatever is happening. And if you want to extend this functionality or want something custom, it has you covered. So you can customize it as well. So that's about Spring Boot Actuator. All right, so let us set up Actuator into our Spring Boot project. So to activate Spring Boot Actuator into this project, we will have to add a dependency. Okay, so Actuator can be activated with the help of a dependency that we need to add over here. So like we have added many dependencies like H2 database, the JPA dependency, and so on. So we will need to add the Actuator dependency here. Now to add the dependency, we need to head over to our favorite website, which is start.spring.io. So here, I'm going to select Maven, and I'm going to say add dependencies, and I'm going to say Actuator. So you can see you have this Actuator dependency coming up over here. It says supports built-in or custom endpoints that let you manage or monitor your application, such as application health metrics, sessions, etc. So application health metrics and sessions, it lets you monitor. So I'll select this. I'll go to Explore tab, and I'll make sure that pom.xml is selected over here on the left hand side, and then I'll scroll down. And here you'll see this dependency. Okay, so I'll just copy this dependency. Okay, I don't need anything else. And I'll head over to my project here, and I'll add the dependency over here. Okay, the moment you paste the dependency into pom.xml, you might see it appear in red, which is fine. So in order to fix this, you need to load the Maven changes. So since we have made changes to pom.xml, we need to reload the dependencies. Now, after the dependencies have been rebuilt, Spring Boot will auto-configure the actuator for us. Okay. So what you need to do is you need to run your application here. Okay. So the application is running. Okay. Let us say actuator here. Okay, so you can see all these jar files are being scanned. Okay, so if you search for actuator, you will see all of this happening. Okay, and then if you go down here, you will see this message being printed, exposing one endpoint beneath the base path /actuator. So this endpoint has now been enabled. Okay, now if I say enter, so this is the last stack trace that we have just before the application started. Okay, and in the beginning there was a lot of scan that happened. Okay, over here, which is like folded. So here we have the actuator endpoint enabled. Head over to browser, and here I'll copy this application URL over here, and I'll say actuator like so. Okay, so you will see a response something like this. Okay, now what you can do is, this is not well formatted. Okay, so you can add JSON, and you can say Chrome. So you will get this plugin JSON formatter. You can optionally install this. So this is not mandatory. Okay, you can optionally install this. So since I am an incognito, I am not able to add the extension. Okay, but you can add it over here, and this particular thing will be well formatted for you. Okay, but what I'm going to do is I'm going to copy this, and I'm going to go to JSON lint. Okay, and here I'm going to paste the JSON, and I'm going to say validate. Okay, so it is going to give me a well formatted output here. Okay, you can see this. This is the output that we got from this actuator endpoint. Okay, so let us decode this output, what we got. Okay, so let me zoom in. So you can see here we have underscore links first. Okay, so underscore links, this is a top level object that will contain the links to different actuator objects underneath it. Okay, so you can see this is the parent over here, which is mapped to links, and you will have child objects under this. So JSON, how JSON works is it has this format of child and parent relationship. So you have this parent object, and then within this you have nested child ones. So this is the parent object. Then you have self. So what is self? So this link points to the base actuator endpoint, okay, which is like localhost etc actuator, which is what we have accessed over here. Okay, so that is what this URL is. Then it says health. So this link represents the health endpoint. Okay, and this endpoint provides the information about the health status of the application. Okay, and that is what the endpoint that you are seeing over here. Okay, then you have health path. So health path is the link that represents the health endpoint with a parameter. So you can see it is the same health endpoint with a parameter in the end. Okay, and this URL indicates that additional path segments can be added to this particular endpoint. For example, if you want to access the health of a particular segment, okay, which you can pass as a path, you can do that with the help of this endpoint. Okay, so it accepts parameter is what all it says. So this is the default output that you get after adding the dependency. And right now you also got to see the magic of Spring Boot auto configuration. So we literally didn't do anything. We just added the dependency in pom.xml here. Okay, so this dependency was just added. We didn't make any changes to the source code. Okay, and just by adding this dependency, Spring Boot knows that, hey, you have added the dependency for actuator, so probably you might want to access it. So I'll enable the endpoint, and automatically the endpoint was enabled. Okay, so initially or earlier, these sort of things were not there with Spring, so we had to manually configure all of this. But with Spring Boot auto configuration, this works like magic. So immediately after you adding the dependency and after rebuilding the project, you have this endpoint ready and you can access this with the basic elements. Okay, these are the basic defaults that you have. Now, if you want to customize, you can, of course, but this is what you get just by adding the dependencies. Pretty sweet, right? So this is about the actuator and activating it into your project. So when you access actuator from the browser, you will see some endpoints. So these are the default settings, and not all endpoints have been exposed yet. And this may be because of the security reasons, but we can configure our Spring Boot application to expose all the endpoints. Okay. Now keep in mind, exposing these endpoints can provide sensitive information about your application. So they are hidden to prevent any potential leak of information. Okay, but for our testing purpose, what we are going to do is we are going to head over to our application and we are going to head over to the application.properties. So this is a file where we will add the configuration to enable the access to the endpoints. So I'll mention actuator over here. Okay, and I'm going to say management.endpoints.web.exposure.include. So this is a property that you need to set and you need to add star in the end. Okay, the moment you add this and if you run this, so let us run this and let us see what happens. Okay, so the application is started, and if you search for actuator, okay, we have the actuator exposed. Okay, let us head over to the browser and let us refresh. Now, the moment you refresh, you will see a lot more appear over here. Okay, and this is because we have exposed everything now. So by mentioning include equal to star, you have actually specified Spring Boot that you want to expose everything. Okay, and you can see the endpoint over here. You have links, then you have self, which is nothing but the base URL for actuator. Then you have beans. Okay, so this is one of the endpoints that exist from where you can access all the beans that exist, and you can scroll through and go through all the different endpoints that you have enabled into your application. Okay, so there are quite a few. Okay, and yeah, I would also want to mention is I have activated the JSON formatter in the incognito mode. It was not working for me, but I have enabled it over here. And if you wish to have the response in this format, like well formatted way, so this is JSON formatter, and you can say JSON formatter like so, and you can just install this Chrome extension. Okay. So this is the extension that you need to add, and it will show you the JSON in the beautified format. Or if you don't want to add any extension, you can just say JSON formatter, and you can go to this website, or you can go to JSON lint. So JSON lint is also one of the popular websites. So this JSON lint, you can just go here and format the JSON and study it. So that's about the actuator endpoints. So when working with actuator, there are quite a few endpoints that might seem overwhelming. Okay. But the goal of this lecture is to take a look at some of the key endpoints. And these are the endpoints that are quite popularly used when building Spring Boot applications or when working with Spring Boot. These are all the built-in endpoints. Okay. So I would also want to mention that Spring Boot also lets you add endpoints on your own. Okay. So let us take a look at the table which talks about the popular endpoints. So this is a table that I have. So we have health endpoint, and this endpoint shows the health information, okay, which is useful for checking the status of the application, like database connectivity, disk space, custom health checks, and so on. We have info endpoints, which displays the arbitrary application information that is commonly used to display. Okay, and it is used to display application version, git commit information, and so on. Okay, then we have metrics, which talks about the metrics of the application. Okay, and it lets you understand the performance and the behavior of your application. Then you have loggers, which allows you to query and modify the logging level of your application. So if you wish to change the logging level, you can do so using loggers. Then you have beans endpoint, which provides you a complete list of beans that are being managed by Spring in your application. Okay. Then you have shutdown, and it allows you to shut down your application gracefully. So these are some of the commonly used endpoints that exist with Spring Boot, and these are sorted in the order of their popularity. Okay. Now, popularity also depends from company to company. So there will be a company which might be using this particular endpoint a lot. Okay, so this endpoint becomes a lot more popular in that particular company. But overall, in general, this is what is generally being used in the market. So these are the important endpoints that I wanted to share with you all. Let us now start talking about the health endpoint that Actuator provides us. So I have my Spring Boot application up and running. And if we scroll down through the list of endpoints, here you will see this health endpoint. Okay. And this is a link. So I'll press Control. If you're on Windows, hold the Control key. And if you're on Mac, you can hold the Command key and you can click on this link here. So this will open up in the new tab, and this endpoint is telling you the status of your application. Okay. So the health endpoint provides the basic health information about the application. Okay. Now here, as of now, it's just telling you that the application is up, and the application goes down, it will tell you down or something. Okay. But we can do more with this endpoint. So rather than having this single piece of information, you can ask Spring Boot to add several health indicators representing different aspects of your application health. And for that, you need to add a property into application.properties. So I'll switch over to Intellij. Now here in Intellij, I'll add a property. So I'll just copy this and I'll say management.endpoint.health. So instead of web, I'll say health. Dot show details. So I'll say show details, and I'll remove all of this, and here I'll say always. So what I'm telling Spring Boot is, show me all the details of the health endpoints over here, always. And I'll save this and I'll run this. So the application is up and running. Now if I refresh, okay, we are not seeing much information. So, okay, so we made a small mistake over here. So instead of endpoints, it should be endpoint, and rest everything is perfectly fine. So health dot show details. And now if you refresh, you will see a lot of information. Okay, so there was a typo over here, and the thing is, the Intellij community edition does not have autocomplete for the properties file. Okay, so if you have Intellij Ultimate, you will get autocomplete if you are building the Spring Boot application. Okay, so this autocomplete feature is not there, which is perfectly fine. Of course, you can install third-party plugins in Intellij and get that activated, but I don't want to install like third-party plugins. Okay, so if you're okay installing third-party plugins, you can do that, but I'll just stick to this. Okay, so now if you head over to the browser, you will see this JSON coming in, and this has a lot more information than what we were seeing earlier. Okay, so let us evaluate each component or each value in JSON. Okay, so here you can see we have status. Now the health status can be up. So up indicates the component is functioning correctly. It can be down, which indicates that the component is down. It can be unknown if the health status is unknown. It also can be out of service and maintenance. So out of service means that the component is temporarily out of service, and maintenance means that the component is under maintenance. Okay, so this is about status. Then you have components tag over here, okay, which has three pieces of information. Okay, now component section provides different components or subsystems of our application. Okay, so number one subsystem is the database, which is represented with DB. So this tag tells you the health status of the database component. Okay, and in our case, the status is up, and it indicates that our database is working perfectly fine. Okay, and it provides additional details about our database, like the database type is of H2. So we are using the H2 database, and the validation query is valid. Okay, now if you scroll down further, you will have disk space information. So this tells you that this particular component is up. Okay, and it indicates that there is sufficient disk space available on the system. Okay, and you can read more about the details over here of the disk space. Okay, so this disk space is being displayed in bytes. Okay, so you can see total is this much, free is this much, and threshold is this much. And here you are seeing the project path, which is fine, and exist is true. If you scroll down further, you will have one more component, which is ping, and it represents the health status of the ping component. Okay, now this indicates that all the components of our application are up and running. Okay, and there are no issues at all. Okay, now if you head over to the code over here, like the application.properties, you can add different values over here instead of always. So you can add always, you can even have never. So if you say never, okay, you won't be shown whatever we just saw. So this is health endpoint, and it can be used to monitor the health of different components that exist in Spring Boot application. Let us start talking about the info endpoint. So I'm here on the actuator base URL, and if you scroll down a bit, you will see this endpoint over here, which is info. And if you click on this, which gives you an empty JSON. So this is an empty JSON object that you are getting. Now, what is this info endpoint? So info endpoint provides information about your application, and this can be statically configured or dynamically generated. So this is a good tool to display your application information like your application name, version, git commit details, and anything that you wish to expose to the outside world. Okay. Now this is empty. How do you add information over here? So to add information, we need to set the information in application.properties. So I'll switch over to Intellij. And here I'm going to add some information. So I'll say info.app.name. Okay. So this is the name of the application that I wish to specify. And I'll say it's a job application. Okay. I can even say info.app.description. So I can say job app built by Embark-X, like so. And I can even specify the version of the application. So I can say version 1.0.0, like so. Now, if I go to the browser, okay, and if I hit refresh, you won't see anything because we need to run the application. So I'll run this application, and when you access the endpoint now, you will see all of this information being populated at the endpoint. So if I hit refresh, okay, we are not seeing the information. So there is one property that we missed. Okay, so make sure that you add this property as well. So you need to say management.info.env.enabled equal to true. Okay. Now let us rerun and let us see whether we are able to get the information. So now if you refresh, you will see all the information being come up at the endpoint over here. So this won't work without adding this particular information. Okay. So once you add this, it will pick up all these variables and it will give all this variable over here from the info endpoint. Now you can add whatever you want over here. So I've added name, version, and description. You can add whatever you wish to, or whatever properties that you want to show or showcase to the outside world. So this is info endpoint for you. Thank you. Let us start talking about the metrics endpoint. Now metrics endpoint is one of the most powerful feature, or the endpoint I should say, provided by the Spring Boot actuator. And it provides a comprehensive overview of your current application states, including various system and application level metrics. Okay. So if you scroll down over here on this page, you should see metrics over here. So you can see these are the two endpoints that talk about metrics. So I'll open the second one here, which does not have the parameter. So if I open this here, you will see these are all the metrics that you can track with this particular endpoint. Okay. So there are lots of properties like the JVM memory used, okay, JVM buffer count, JDBC connections that are active, the HTTP server requests. Okay. You can take a look at disk space that is free, disk space that is in total, the application ready time, the application started time, and so on. Executor pool size. So a lot of stuff you can view from here. It also talks about the JVM memory used and so on. System CPU count, system CPU usage, a lot of information. So all the information that you wish to see about your application, you can take a look over here. But on this endpoint, you are just seeing the list of properties that you can keep track of. Now, how do you view the property itself? Okay. So let us say if I wish to view this JVM class loaded. So I'll copy this property and you'll go to the other endpoint over here. So these endpoints are same actually. So these two endpoints. So here after metrics, you are adding the metric name. Okay. So what you can do is you can click on this. Okay. And instead of required metric over here, you can paste the metric that you copied. So I have pasted jvm.classes.loaded, and it will give me the stats around that particular metrics. So you can see over here the number of classes that are currently loaded in JVM. Okay, and this is the value right now. So these many classes have been loaded right now into JVM. So that is what this endpoint talks about. You can even change the metrics. So I want to see, let's say, jvm.info. So I'll copy this and I'll paste it over here. So you can see the information about JVM as well. So you can see the vendor is Oracle, okay, OpenJDK runtime environment, and so on. Okay, so yeah, you can play around with different metrics that exist over here. Okay, so you can see the disk space that is free. I'll copy this and I'll go over here, paste it. Now you can see the total disk space that is free. This is the value, and this is the path that you get. Okay, and this is the disk space that is usable space for this particular path here. Okay, so there are a lot of metrics that you can play around with and take a look at, and whatever metrics you want to view, you can like view it in the browser this way. So you can see the recent CPU usage of the system application is running in. Okay, so this gives you the CPU usage metric. You have the CPU count metric over here, and so on. Okay, so these are the number of processors in my system, it says. Okay, this is about the metrics endpoint. Okay, you can even view the server information, like we are using Tomcat as our server. So you can see like the active sessions that you have on the server and so on. Okay, so this is a very useful endpoint, metrics endpoint. It is very frequently used when it comes to building enterprise grade applications. Okay, so do play around with this one and do take a look at different parameters that you have. All right, thank you. So let us start talking about the loggers endpoint when it comes to Spring Boot Actuator. So this endpoint is a powerful tool that allows you to view and even manipulate your logging levels at runtime. Okay, so if your application is running and if you wish to change the logging levels in your application, you can do that without stopping the application. And this is really crucial because trust me, if you're building enterprise grade applications, you would want zero downtime. And just restarting application just for changing the logging levels is not fair. Okay, and in production environment, you might have applications that are heavy and that might even take some time to start. So there will be a downtime or considerable amount of downtime if you just wish to change logging levels. But with /loggers endpoint, you can modify the logging levels without restarting the application, which is incredibly useful in debugging and to diagnose the production level issues. Okay, now you can scroll down over here. So since we have enabled all the endpoints, we will have access to loggers over here. Okay, so this is the loggers, and there is another endpoint of loggers, which is loggers/name. Okay, so if you access or if you click on the loggers URL, you will see this information pop up. Okay, so this talks about the different logging levels that exist in the Spring Boot application, and like there are different logging levels. Like you can turn off the logging. Okay, you can have error based logging. So this designates the error events. Okay, this will log only the error events. Okay, then you have info level, which just shows the informational messages and highlights the progress of the application. Then you have debug level, which shows the fine-grained informational events that are most useful to debug the application. Okay, and this goes even finer. So trace is even finer. And warn will only show the warning information, like that are potentially harmful situations. If that might occur with your application, it might show you that. So these are different levels that exist, and that is what it's talking about. Now, if you scroll down, you will see logging levels of different components over here. Okay. So this is our package. You can see it's info. Okay. And this is our application, com.embarkx.firstjob application, and it's set to info. So we are on info level. Okay. Now the question is, I said you can change it at the runtime. So how will you change it? So you can change it with the help of this URL. So this URL followed by the name. Now, what is the name? So name is the name of the application, which is this one. Okay. So I'll add this. Now, if you call this URL, okay, with the details of the kind of logging that you want to change to in a post request, okay, it will be changed. So what I mean over here is, since we need to do a post request, we should head over to Postman over here. Okay. And I'll create a new request over here. I'll say add a request. Okay. And I'll say actuator. And here I'll paste this URL. So I'm calling this URL here and it's a post request, and I'll go to body tag and I'll say raw. Okay. And this will be JSON over here. Now, what request should I send it? Okay. So you need to send the request in the form of JSON, and you need to say configured level over here. So I'll say configured level and I'll say debug. So let us change the logging level of our application from info to that of debug. Okay. Now what I'm going to do is I'm going to send this and you will get 204 no content. Okay. Now if I copy this, okay, and if I switch over to our browser and if I hit this, you will see it's configured to debug. And over here, if I refresh, you'll see it's debug now. Okay. So we have successfully changed the logging level of our application to that of debug. Okay. So we don't see anything over here yet. Okay. But I believe the logs will come up if we try and send some information. So you can see, so logs are coming, but we need to do something to get the debug information over here. Okay. But this will work, and you can see, like in the browser also, it is being reflected as the logging level is changed to debug. So this is how you can change the logging level of your application with the help of this URL. Okay. And you can even view the logging level of different components that exist. So this is incredibly useful for enterprise grade applications. Let's say if there is some issue in your application, you get a production level ticket. So in order to debug that, you need logging enabled. So you don't want to restart, of course. So you can make use of this provided you have actuator enabled. Okay. So this is why actuator becomes really important. Okay. And if you don't want to expose all the actuator URLs, you can just mention, instead of star over here, you can say logger here. Okay. And it will just open up logger for you. Okay. So this is completely possible. We have added star right now. And the reason for that is because we want everything to be exposed since we are learning and it's a test app that we are building. So this is about logger and how it can be used with Spring Boot. So let us start talking about the beans endpoint. Now this endpoint in Spring Boot Actuator gives a complete list of all the Spring Beans that exist in your application. And this can be useful for troubleshooting, understanding, and getting the idea of different dependencies across beans in your application context. Okay. So you have this endpoint over here, which you can see. Okay. So I'll click on this endpoint and it will open up. Now, when you hit this endpoint, you are going to see some JSON response that include a lot of information for every bean. Okay. So you are seeing the context, application, beans, and you are seeing here the bean name. Okay. So this is the bean name. So these are different beans that exist in every JSON. Okay. And under this, you will see the scope. Now, the scope is nothing but the scope of this particular bean. Okay. And this could be singleton, which means only one instance of the bean is created per Spring application context. Okay. So it's a singleton object, or it can be a prototype. And prototype meaning a new instance is created every time a bean is requested. Okay. Also, you might see some custom scope over here if they are defined. Then you have type, which talks about the fully qualified name of the bean class. Okay. And then you have dependencies over here. Now this shows other beans that the current bean depends on. Okay. So if you scroll down, you can see some dependency here for this particular bean. If you scroll down, you have quite a few beans. Okay, the list is very long. So if you take a look at the left scroll bar, it's a huge list. So these are all the beans that are being managed by our application right now and Spring in the backend. Also, you will see aliases over here. So this is the alternative name or the alias name for a particular bean. Okay, now what I can do is I can try looking for our bean. So I can say job repository. So this is one of the bean that we have created, job repository. Okay. And you can see over here the alias. Okay. And you can see the alias name is empty. Scope is singleton. This is the type of the bean. Okay. And the resource talks about like where it's defined. So it's defined in this particular package. Okay. And enable JPA repository is declared over here. You can see. And then you have dependencies as well that have been mentioned. Okay. So these are the different dependencies that this bean has. Okay. So this JSON provides a snapshot of bean configurations and their relationship within this application context. Okay. And this can be really useful if you want to understand the composition of the application or you want to check out some information about a particular bean. Now keep in mind that this is very sensitive information when it comes to building production grade applications. Okay. You cannot have your endpoint being exposed like this. Okay. For your application where anyone can come and see all the beans. Okay. And literally you can search for everything. So here I search for job repository. You can search for company repository as well. So you can see company service. Okay. You can see company repository. So everything that we have defined will come here as a bean. So whatever is being managed will come over here. Okay. So this is what the bean endpoint is. Okay. So if you don't want to enable all the endpoints over here and just the bean endpoint, you can specify bean over here instead of star. Okay. So that's about this beans endpoint in your Spring Boot application. Let us start talking about the shutdown endpoint that exists in Spring Boot Actuator. So this is a built-in endpoint that allows you to gracefully shut down your application. Now, what I mean by graceful shutdown. So shutdown is a shutdown, right? But graceful means that if there are any ongoing requests that are being processed by the application, those will be done and then the actual shutdown will take place. Okay, so it won't abruptly terminate everything. So that is what graceful shutdown means. Okay, so this shutdown endpoint is very useful in scenarios where you want to control the lifecycle of an application from some external system that you might have. So you can call that endpoint from the code. Okay, so if you scroll down over here, you won't find shutdown endpoint. Okay, so you can take a look at all the endpoints that are available. This endpoint is not available or enabled by default. It's disabled, and there is a reason for this. And the obvious reason is the security. So this endpoint is disabled by default because it risks the shutdown of the application. So anyone who has access to this endpoint can shut down your application. And therefore, it has to be used very carefully and appropriate security measures have to be taken. Okay. So how do you enable this endpoint? So you can head over to your application.properties and you can say management dot endpoint dot shutdown dot enabled is equal to true. Okay. So this will enable this particular endpoint. I'll stop and rerun the server. So now the endpoint is enabled. Okay. So if you are enabling the endpoint in your application, just make sure the security measure is taken care of. So this could mean that you can restrict the access of this endpoint to a particular IP location or something like that. Okay. And also I wanted to talk about how you can shut down your application. So you can say localhost. So if you head over to your browser and you say localhost 8080, so let me copy this URL. Okay. So localhost 8080 /actuator/shutdown. So this is a URL. Now, if you try to access this particular URL from your browser, you're going to get an error. And the reason is GET request is not supported on this particular method. Okay. So this particular method supports only post request. So you have to copy this and head over to Postman. Okay. And here you have to add. So I'll create one more request over here. I'll duplicate this one, duplicate, and I'll say shutdown here. And this is also shutdown. Okay. So this is a post request now. Okay. And if I trigger this, okay, it says shutting down by, and that is what the message is. And you will see that our application has actually shut down. So shutdown has initiated and it is down. So this was graceful shutdown. Okay. And this URL or this endpoint can be accessed only using post request. So you can do either a curl request or you can trigger it from the Postman. Okay. Now to enable graceful shutdown, you can also mention server.shutdown and you can say graceful like so. Okay. So this will make sure that the shutdown that happens is graceful from the endpoint. Okay. So this has started now. Okay. Now if you head over to Postman and if you send the request, you'll see the shutdown is done. Okay. So we have set the property to explicitly mention that we want graceful shutdown. So if you are enabling this particular endpoint, okay, just make sure that you are very careful, because in production scenarios, this can be really, really risky and you should know what you're doing in your application. So that's about shutdown endpoint. What's going on, everybody? So in this lecture, we are going to talk about Docker. Now, I would like to teach Docker and give you an introduction with the help of a scenario. And we are going to first understand the problem that Docker solves. And then we are going to discuss what actually Docker is. So let us consider a scenario wherein we have a software development firm and we have two developers working there. So we have Sarah and then we have John. So Sarah is a software developer working on a team that develops a web application. And John is also from the same team. And this team uses a shared development environment where multiple developers work on the same code base. So John is also Sarah's teammate and they use the same code base to push the latest version of the code and also to pull. Now, when working in their code base, they are using several libraries with different versions. Now, let's say John updates a library on his local system. Now, there is a library which has a local version available. So John updates this library on his local machine and he pushes this code to the shared environment. Now, the shared environment also has the updated version of the library which John has just updated. Now, what happens is when Sarah pulls the latest version of the code, she gets the latest version of the library on her system. And this leads to bugs in her application on her local machine because that version of the library which John has updated is not compatible or does not work on her system because of some environmental issues or some conflicts on her system. So the problem that I'm trying to highlight over here is that the developers are working in a shared environment where library versions and dependencies are not well managed. When one developer updates a library, it can cause issues for others due to version conflicts or compatibility problems. Now, this leads to inconsistencies in development environment and makes it difficult to reproduce the issue or debug them. Okay. Additionally, it brings us to a scenario wherein an application is working fine in one developer's machine but fails in a different environment of other developer. Okay, and this causes frustration and like the team has to resolve these issues and it delays the development process. Now, what is the solution to this? Okay, so the solution to this version is Docker. And to solve this problem, Sarah decides to use Docker. So what she does is she containerizes the application using Docker. Okay. Now, what this means is, so the code base moves to a container, okay, which includes the application code, its dependencies, and the required environmental configuration that is needed for application to run. Okay. Now, this is what the scenario will look like then. So Sarah has the container in which her application is running. And this container is like an isolated environment, okay, which has everything that the application needs to run well on her system. Okay. Now with this, Sarah has no longer to worry about conflicting library versions or incompatible environments or any other issues that may be caused because of any version conflicts. Okay. And this issue which Sarah faced just now, wherein the application was working fine on one of her teammates' machine, but it was not working on her own machine, is something that you as a developer might have also encountered several times. And she decided to use Docker for the same. Okay. Now, what will happen in the team here now is, since Sarah has a container or an image of her code, everybody upgrades to Docker. So we have in the shared environment, we have the code base residing into a container, and also on the John's system, we have a container. So everybody has started using the isolated containers which they can use. And this container has everything that the application needs to run and work well. So to summarize this entire scenario, Docker solves the problem of dependency management, compatibility issues, environmental inconsistency by providing with containerization. Okay, it enables developer to pack their application in and their dependencies into container, and this ensures consistent execution in different host operating systems. Okay, and it eliminates all the version conflicts that were happening early on. So let's define Docker. So what is Docker? So Docker is an open source platform that allows you to automate the deployment, scaling, and management of applications using containerization. Okay. Now, containerization is a lightweight virtualization technology that enables you to package an application along with its dependencies into a standard unit, which is called a container. Okay. And with Docker, you can create containers that have everything that is needed for an application to run. Now, this can include the code, the runtime, libraries, and even the system tools. And these containers are portable, which means you can move them across the systems and can be deployed on any system that supports Docker or has Docker up and running. Okay. Now, this ensures that the same container which is running on my system will work on someone else's system the same way like it was running on mine. And this ensures consistency, and it eliminates this phrase in your team that it works on my machine. I don't know why it's not working on yours. Okay, so this is completely eliminated, and you must have heard this phrase many times, like it's working on my machine. I don't know why it's not working on yours. Okay, so this is completely eliminated and managed with the help of Docker. So this is a Docker container that we spoke about. It has code, the runtime, libraries, and all the system tools that are needed for application to function properly. Now, what are virtual machines? So I want to talk a bit about virtual machine, and we will even discuss how virtual machines differ from that of Docker, because if you have been working with virtual machines, this concept of containerization can be a bit confusing as to how it differs from each other. Virtual machines act as computers inside your computer. So what is a virtual machine? It's a virtual machine that exists on your computer. So you can think of a virtual machine as a emulation of a physical computer system. Okay, so if you have a Windows running on your system, you can run Ubuntu as well on your system using this technique of virtualization. Okay, so it allows you to run multiple operating system and applications within them on a single physical machine, as if you have multiple computers within that machine. Okay, and you can imagine this as a powerful computer, and you want to use it to run different operating systems or applications that may not be compatible with each other. So for example, if I want to use a specific software that works only on Linux and I have Windows installed, so I can install Ubuntu as well, or any Linux software, with the help of virtual machines. Okay, so this technology, virtual machines, will help me create an instance of a Linux operating system on which I can use that application. So that is the problem that it solves. So without virtualization, you will have to buy a separate physical computer, or like delete your own host operating system to install the other operating system. Okay, but with virtualization, you can create your instance of virtual machine on your host system. So that is what this means. Like, it acts as a separate computer inside your computer, and each virtual machine behaves like a separate computer. Like I said, it has their own virtual hardware, CPU, memory, storage, and everything. Okay, so it shares some of these resources from the host operating system. Okay, virtual machines are created and managed by virtualization software. So you need a software to create virtual machines, and there are many such softwares available in market. Like, you have VMware, then you have VirtualBox as well. So these softwares provide the necessary things or the infrastructure that you need to run and manage virtual machines on your system. Okay, it also allows you to allocate resources, and you have complete control on that. So let's say if you have a 10 core CPU, so you can decide, if you have 5 virtual machines running, I want one core to be allocated to each virtual machine. If you have 10 gigabytes of RAM, you can think of allocating 1 GB each to each virtual machine. So something like that. So it gives you complete control as to what is allocated to which instance of virtual machine, and you can even control their startup and shutdown. Okay, even you can take the snapshots of their state and take backups and restore. So these are what virtualization softwares. Okay, and the advantage of them is they provide a flexible and an easy way to completely utilize your hardware resources. So you can run multiple virtual machines on a single physical machine, saving space, and you can even reduce costs. Okay, so this is what virtualization is. Now let's talk about how Docker differs from virtual machines. So when we talk about virtual machines, this is what the architecture will look like. So you have your machine over here, then you have the host OS, which is nothing but the operating system that you have installed on your system. For example, if I have installed Windows on my machine, so I have Windows as my host OS. Then we have something called as hypervisor, which enables us to create and interact with virtual machines. So Once you have these things, okay, you can create virtual machines. So this is one virtual machine that I have created. So it has its own copy of operating system. As you can see, it has all the libraries or binaries that are needed for this particular application to run. Okay, so this entire thing is packaged as a virtual machine, and it will use the system resources that can be allocated to this particular virtual machine using the virtualization software. Okay, so this guest OS can be any OS, like you can install like Linux, or you can install any other instance of Windows as well. Like you can install the same OS as host OS as well. So it's up to you. Okay, so you can have multiple versions of virtual machines running on the same system. So you can have one more instance which runs a completely different app. Okay, and this is in a separate space and a separate environment than this one. So for example, this is running on Windows. Let's say the guest OS is Windows. Here you can install Linux and you can run the app B. Okay, so it will have its own libraries and binaries installed again on this particular thing. You can even run the same app again as a separate instance. So here you have a same instance of app B, or not the same, but the separate instance of the same app B. And you have libs and bins, like libraries and binaries installed with any OS of your choice. Okay, so this is what virtual machine is. So you can see like it's a separate computer inside your own computer, which is the host over here. So this is your machine over here. Okay, and you have installed multiple operating systems on top of this, okay, which are running like multiple computers on a single machine. So this is about virtual machines. Now, how does it work with Docker? So with Docker, you have your machine. So this is a machine hardware. You have host operating system, and then you have something called as Docker engine. So this Docker engine is responsible for containers. So you will have like this app. Okay, so this is one container which has application A running. It has all the libraries and binaries. Now, one thing to note over here is it does not have the guest OS. Okay, so this is very lightweight. Okay, so by installing guest OS, you make it a bit heavy. Okay, it needs then high resources and all. But over here, we don't have guest OS. So we don't have an operating system running. So this becomes really lightweight. So it just has the necessary things that are needed for your application to run. That is it. Nothing more than that. Okay. So this is container 1. Then you have another container which runs the app B. And again, this is without the OS. Okay. Then you have the same instance of app B running again as a separate container. So there are 3 containers that are running. Okay. And they are lightweight as compared to the virtual machines that we have over here. And virtual machines become a bit heavy because the entire operating system is installed from scratch as if you're doing a new installation. Okay. So this is about Docker and virtual machines and how they differ from each other. Also, I would want to highlight some of the differences. So I have some parameters over here and I'm comparing virtual machines and Docker containers. So the number one difference is in terms of size. So virtual machines are large and resource intensive. Docker containers are lightweight and resource efficient. Now, the startup time of virtual machines is longer, of course, because a full operating system needs to start. But with Docker containers, almost instant. So the startup is instant as no OS boot is required. So it's pretty quick in startup time. In terms of resource utilization, virtual machines use more system resources like CPU, memory, and so on. But Docker container, on the other hand, will utilize really few system resources. In terms of isolation, there is a strong isolation between multiple VMs because they each have their own operating system. But in terms of Docker container, it is isolated, but it shares the host operating system kernel. That is it. And this is completely fine, I would say, provided that's the requirement. Okay. Then you have the difference of portability. So virtual machines are portable, but they require the compatibility in terms of operating system. And Docker containers are highly portable and independent of host OS. Then we have some more differences, like in terms of scalability. So scaling virtual machine requires creating new VMs. Okay. But with Docker container, it is easy to scale. Like you just need to create more containers. And these containers, like I said, are very lightweight. So when it comes to VM, you need to create highly resource intensive VMs to scale. But Docker is really easy because you are scaling something that is already lightweight. In terms of ecosystem, you need VM specific tools and frameworks. But with Docker, you have Docker ecosystem with a lot of tools out there. Okay. Now, how does development workflow work when you work with virtual machines? So the setup is fairly slower because you are setting up an entire operating system. Okay. But with Docker, the setup is pretty much faster and you need to manage the dependencies for the application that you are running. How is it different in terms of deployment? So in terms of deployment efficiency, VMs are larger in size and they have more overhead. Okay. But for Docker container, it's easier to apply. Like it's easy to deploy Docker containers. All right. So these are some of the differences between Docker containers and virtual machines. So overall, I would say Docker containers are much more efficient, portable, fast, and they're isolated when compared to virtual machines. All right. And that is why this technology is growing really fast and it's becoming very popular in the dev community. So that's about Docker and how it works. I hope you all have a complete understanding of how this particular thing works. And I hope you all enjoyed this explanation. Let us start talking about the Docker architecture and let's understand how Docker works under the hood. By understanding architecture, you will be aware of the important terms and how things are managed behind the scenes. So you have your host operating system, which is your machine OS that you have. So for example, you might have installed Windows or Mac or Linux on your system. So that is what your host operating system is. Then you have these components from Docker, which is Docker daemon, Docker API, and then Docker CLI. Together, they form Docker engine. Now, Docker engine interacts with Docker containers and Docker images with the help of daemon, which in turn interact with Docker registry. Now, what does each component mean and what is their role? Okay, so let us start talking from Docker CLI. So this is a command line interface. So CLI stands for command line interface. It's a client that allows users to interact with Docker. So if you are a user and you want to communicate to Docker, you will execute some commands on the command line, okay, and you will interact with CLI, okay, which is the command line interface. Now, Docker CLI will interact with Docker daemon to get those commands executed. Now, what is Docker daemon? So Docker daemon runs on the host operating system and is responsible for building Docker images and managing containers. So it listens to the user's command via the Docker CLI. And it also interacts with the Docker API and it manages all the Docker objects. So that is what Docker daemon is. Now let us talk about what are Docker containers and what are Docker images. So let's talk about image first. So these are templates with instructions for creating something called as containers. Okay. So you can think of Docker images as a blueprint for creating a container. Okay. So that is what Docker image is. Now from one image, you can create multiple containers. So for example, let's say I have a Docker image for app A. Now for application A, I have already defined a Docker image. So I can create multiple containers using that image for application A. If I want to make any changes to the container, I have to edit the image. So Docker container is a running instance of Docker image. It's a running version of Docker image. That is what a container is. So these two things like Docker images and containers are managed by Docker daemon. Now here we have one more component called Docker registry. So what is a Docker registry? So Docker registry is a service that stores Docker images. Okay. And the images that you store in Docker registry can be public or private. Okay. So if the image is public, it can be accessed by anyone across the world who is using the Docker registry. Okay. And if it's private, it's only private to you and no other person in the world can pull those images. So to get the Docker images from the Docker registry, you have to pull the image and you need to run the image in order to get the containers. Now, if you have a Docker image locally, and if you wish to get that image onto the Docker registry so that you can access it from anywhere, you need to push the image to the Docker registry. So you need to pull the image to get it to your system and push the image to send it to the registry. And all of this is managed with the help of Docker commands. So you can think of registry as a central repository for all the Docker images. Okay. So the use case of why Docker registry exists is because the images are meant to share and distribute across different systems. Okay. So this is the internal version as to how the Docker architecture works. And then I have a different version wherein you can see here you have machine, host operating system, and Docker engine. And you have multiple containers that are running different apps with their own binaries and libraries. Okay. And these are all called containers. Okay. So this is how Docker works. And I hope you all have a fair understanding of the Docker architecture and what are different components beneath. So let us talk about and cement the understanding of some of the concepts that exist in Docker. So the number one concept that we'll talk about is images. So Docker images are like templates that exist, or you can think of them like blueprints that define the container and the dependencies that exist within a particular container. Okay. Now image are the base on which containers are built. So you can say containers are built from images. Then you have containers, and these are lightweight and isolated runtime environments that are created using Docker images. And they provide an isolated and reproducible execution environment for applications. Then you have Docker engine, and this is the runtime that manages the containers. And it provides all the necessary tools and infrastructure that you will need to build, run, and manage Docker containers. Next, let's talk about Docker file. So what is a Docker file? So when you're creating a Docker image, you need to have some sorts of instructions as to what needs to exist in that blueprint. Okay. So that is what Docker file is. So it's a file that contains an instructions to build a Docker image. It specifies the base image, like what all application code that needs to include, the dependencies that it needs to include, and all the other configuration settings. So that is what a Docker file is. Then you have Docker Hub, which is a cloud-based registry that hosts a vast collection of Docker images. You can make use of Docker Hub to share, access, and download public images, and also provide a platform for storing and sharing your own images. So these are the different concepts that exist in Docker. Let us start talking about a bit in depth about Docker registry. So Docker registry, like we know, it's a storage and distribution system for Docker images. So you can think of it like a version control system like Git you have for source code. Okay, so this system allows you to store Docker images with different versions. So every Docker image that you have, you can tag it with a version name. Okay, for example, if you have a web server Docker image, for example, in your project, so you can say version 1.0, version 2.0, and so on. And these images can be pulled from the registry and deployed onto your server. Okay, so if you have a new version of the image available in the registry, what you and your team members can do is you can access them and deploy onto your server. Now, why do we need a registry? So number one reason will be it acts like a centralized resource for all your Docker images. So if you are working in a team and you have multiple developers, then you will need to access these images. Okay, even if you have servers located at a different location, then someone would be deploying the images over there. So how would you share them? So the sharing of images is made simple with the help of this centralized resource registry. Then it allows for easy versioning. So versioning your Docker images becomes easy. So you can have multiple versions of the same Docker image in the registry, and each version is tagged with a different version number. And this allows you or your team members to quickly roll back to the previous version if needed. Lastly, Docker registry allows your images to be shared with the public. So if you are working on an open source project and you containerize it, you would want that image to be shared with the public. So you can do that with the help of registry. So for example, popular databases like POSGRESQL, MongoDB are all available on Docker. Okay, so they have their official images on Docker, and anyone who wishes to use the database, and if they have Docker installed on their system, they can happily use the image and create a container out of that image on their local system. And that will give them a running instance of database without installing the database on their system. So you just pull the container and you just run the container. You have a database up and running. That's the power of Docker and Docker registry. Now we have spoken enough about Docker registry, but what are the different Docker registries available and how do I get my image onto them? Okay, so let us take a look at different registries that are available. So here in the browser, I am on hub.docker.com, and this is a default registry that is being used by Docker CLI and most of the Docker tools. Okay, it is a host for a lot of thousands of public images that are supplied by both individual developers and software vendors or big corporations, making it one of the most essential tools for Docker developers. Okay, so here you can see you have Nginx, MongoDB, Alpine, Node.js, Redis, you have Python official. Okay, so there are a lot of Docker images, as you can see. If you scroll down, it talks about the technology. So it says ship anywhere, collaborate, and automate. Okay, and you can scroll up over here. You can create your account as well, and you can search for different images on Docker Hub. Okay, and if you can even click on these images at the bottom, so you can see the image for MongoDB. So you can pull this image, and this is an official Docker image. You can see it's tagged as official one. It has 1 billion plus pulls, I would say. And you can see over here, there are different tags or versions available. So these are the recent tags or versions. Okay, and you can go to the tags page and you can see different tags and versions along with the command. So you have the command as well to get as to how you can get this particular version. Okay, so you can even search for any of your image you want to. So you can say Python, and you will have okay, so there was a spelling mistake here, Python. So you will have a lot of images in and around Python. You have the Python official Docker image as well. Okay, which is insane. So this is the hub. Okay, this is something that you should be aware of. Apart from Docker Hub, you have something from Amazon. Okay, so this is Amazon ECR or it is called as Amazon Elastic Container Registry. Okay, so if you are using Amazon Web Services for your infrastructure, Amazon ECR also provides the Docker registry as a part of their service. So if you don't want to go outside the Amazon ecosystem, you can use this right on AWS. Okay, and it integrates really well with other AWS services, and it offers a lot of features also. Okay, so you can see the pricing over here. So it has 500 MB of private repository storage per month. So they keep changing this. So you might see something else when you watch this video. Okay, and you can scroll down and read a bit about this tool. Then if you're using Google, okay, like Google Cloud, you can make use of Google Container Registry, okay, which is also known as Artifact Registry. Okay, and it allows you to register and store your Docker images. It integrates really well with Google Cloud Services. Okay, it's a part of Google Cloud infrastructure. So you can read a bit more about this particular tool. Then you have from Microsoft. Okay, so this is Microsoft Azure Container Registry. Okay, and if you're using Azure services, you can use this one if you wish to, and if you wish to stay in the Microsoft's ecosystem. Okay, so this is also a similar registry that is offered by Microsoft. Okay, and you can take a look at how it works. And then you have k8s.io, okay, which is provided by Red Hat, and this is another option. Okay, so it was one of the first Docker registry that existed. Okay, and it still has a lot of features that you can explore. Okay, so this is another option in the market, but Docker Hub is most popularly used right now. Okay, but depending on your requirements, you can choose the one that match for you. So that's about different Docker registries that exist in market. Hello everybody, welcome to this class. So let us start talking about how Docker works with Spring Boot. So initially we'll discuss what all Docker needs to Dockerize an application, and then eventually we'll take this conversation as to how this works with Spring Boot. So to Dockerize any existing application, you need a Docker file. And Docker file is a file that will look something like this. It's a text file that contains a list of commands that Docker daemon uses to build a new image. So each Docker file is a script that has various commands which can be termed as instructions and arguments listed to automatically perform the actions on the image in order to build an image. Okay, so here you can see this is a example file, and now let's debug, or let's go through this entire file and understand what it means. So the first line tells Docker to use official OpenJDK 11 image from Docker Hub as the base image for this image that we are creating. Okay, and this base image includes all the file settings that are needed to run a Java application. Then the next line creates a mount point with the specified path, and it marks it as holding externally mounted volumes. Okay, so this is like a volume that we are creating with the name temp. Okay, then we add the jar file from our target directory to the Docker image. So we have our application ready, and we are assuming that it's ready in the form of a jar file. And we are moving this file into the Docker image, and we are naming it as myapp.jar. Okay, then we are exposing 8080 port to the host machine, which will allow us to access this application right from our system. So since the application will be running inside a container, we need a way to access our application, and that is what this line will do. And then we have this command, which is entry point, which tells Docker what command to run when the container starts. So when the container starts, we are simply running our jar file. So this is a Docker file. It's an example file, and I'm just giving you an example as to how the file is created. Okay. Now let's understand how Docker works with Spring Boot. So with Spring Boot, you don't need to define a Docker file. Okay, and let me switch over to Intellij to explain what I mean. Okay, so here in pom.xml of our application, we have something called as Maven plugin. Okay, so you can see Spring Boot Maven plugin. So we have configured this plugin in our Spring Boot application. Okay, so you can either make use of this Spring Boot Maven plugin that already exists in your Spring Boot application, or you can go with the other approach that I just showed you using Dockerfile. Okay, so you can either create a Dockerfile in your project here. Okay, so here in the root directory, you will have to create a Dockerfile. So you can either create an image that way, or you can make use of Spring Boot Maven plugin. So these are the two approaches as to how Docker can work with Spring Boot. Now, if you're making use of Maven plugin, like everything is automated. So you don't have Docker file, and Docker automatically knows and understands with the help of this plugin as to what all needs to be included into the image for this application to be Dockerized. And that is based on the dependency. So what all is needed is figured out based on the dependency that you have defined here. Okay, and all the properties as well. So on the basis of that, an image is automatically created and you don't need to set a Docker file. So that's the benefit of using Spring Boot with Docker. Okay, there are less hassles. So how does this entire process work now? So let us talk about this a bit. Okay, so Spring Boot internally leverages cloud native build packs to create Docker images without the need of a Docker file. Okay. Now, what are cloud native build packs? So this is a specification created by Cloud Native Computing Foundation, which is CNCF. Okay. So this is a foundation that has created this specification, and it is designed to create container images from the source code without the need of a Docker file. So whenever you are using cloud native build packs to create images, the build packs will analyze your project entirely, and they will choose the right tools and libraries for compiling it. So what I mean by right tools and libraries is, for example, you might need a specific version of JDK or for running Java applications. So that is something that it will figure out. Okay. And it will package everything that your application needs into a Docker image. Okay. And this includes determining the dependencies which would all be combined into this image. So you don't have to worry about this. So if you are using Maven plugin, you are actually using cloud native build pack under the hood, because Maven plugin or Spring Boot uses this internally. Then you have Spring Boot Maven plugin. We spoke about this. So this is a plugin that is configured and which triggers the cloud native build packs. Okay, and it packages your entire application into a jar file first, and then it hands it off to the build packs, which will then take it ahead from there. Also, there is a process called layering. So build packs use layering to create separate different parts of the Docker image. Okay, and they call it layers. For example, one layer may have the JVM, and another layer can contain the application dependencies, and third layer may have your application itself. So this allows Docker to cache layers separately. And if you're building Docker images again and again after few changes, so let's say you make one change and then you create a Docker image, and then you do another change and you create one more Docker image. So if you're creating subsequent builds of Docker image, then this layering technique is cache. So all the layers are cache, and it speeds up the subsequent builds that you might create later on. Okay. And this is because you might only change certain parts of the application and not everything. Okay. So it does not need to repackage and redo everything itself again. Okay. So this layering technique helps speed up the process. Then we have something called as Paketo build packs. So the Spring Boot team works closely with Paketo build packs project. So it's a project to ensure excellent support for Spring Boot application. Now, what are Paketo build packs? So these are implementations of cloud native build pack specification, and they provide JVM and other tools required to compile a Spring Boot application into Docker image. Okay. Now, after all of this, we have the result, and the result of the process is in the end is a Docker image. And this Docker image can run in any Docker compatible runtime. Okay. It has everything that your application needs within the Docker image. And this includes JVM, your application dependencies, and your application itself. Now, what is the benefit of using this approach? So the number one advantage is there is no Docker file needed. Okay. So the build packs handle everything that would be normally done in a Docker file, and they do it automatically based on the analysis of your project. Then you get sensible defaults. So the build packs provide sensible defaults for a wide range of project types, including Spring Boot applications. Then you have consistent environments. So this ensures that your application will run in the same environment where it was built. Security. So build packs can keep the base images and libraries they use up to date, which helps in maintaining the security. Layering and efficiency. So the separate layers about which we discussed right now, okay, these layers can be cached and reused, okay, provided that you are changing. So when creating a new image, if you're changing only a particular part of the application, the rest of the layers will be unchanged and they will be reused. So which will increase the speed dramatically and it will give you images faster. Also with Spring Boot, the process of building Docker image looks really easy, and it's really simple, so it can be compared to running a single command, okay, or running a simple application without needing to understand the specifics of how Docker images are built. So with Docker file, you need to put in the step-by-step information of what all your image will need. But all of this you don't need to do when you are using the Maven plugin and Spring Boot. So that's the benefit that you have. So that's about this class, and that's about how Spring Boot and Docker work together. Welcome back. So let us start containerizing our job application. Okay. So what we are going to do is we are going to make use of Spring Boot Maven plugin features to containerize this application. And we are not going to define the Docker file. All right. So how would you go about this? So we will need to run a command in terminal to create a Docker image. So I have this notepad here and I have already written this command here. You can see. So this part here, the first part of the command is about Maven wrapper. So we are using Maven wrapper script. Okay. And this is already included in our project. Okay. It's a script that using which we can execute the commands. Okay. Then we have this part over here. Okay. Which is the Maven goal that is provided by a Spring Boot Maven plugin. Okay. And this goal builds the Docker image from the Spring Boot application using cloud native build packs. Okay. So our application will first be converted into a jar file and then it will be transferred over to the image. And then you have this part here, okay, this entire piece of code here. So this is a Java system property that is being passed to Spring Boot build image goal. So this is the image goal that we have and we are passing this entire property to it, okay. And the D flag over here, like -D, is used to define the system property. So in case you are setting the image name over here, okay, you can set the image name using this particular tag over here. Okay, so you can replace this image name over here and you can add whatever name you want to. Okay, so the image that will be created with this name. So we will be copying this entire piece of command and we'll exclude the image name over here. So we'll add the image name later on. But before executing this command, what I would want you all to do is you should switch over to browser, head over to Docker Hub and create a free account. Okay. So enter all these details like the username, email, password, and agree to the terms and service. like verify that I'm not a robot and sign up. So once you've created the account, okay, you will be presented with this kind of a screen. So once you have registered, you will be shown this screen. Okay, so you can continue for free. So it's just giving you different options of Docker, and these are paid versions. We don't need a paid version right now. So I'll continue free, and it is asking me to verify my email. So I'll just do the verification. All right, so I'm done verifying my email, and this is the logged in version. Okay, and this is my username, tcode007. Okay, so you can choose the username you want to. All right, so we are done creating the account on hub.docker.com. Now back to this command here, I'm going to copy this part of the command. Okay, and we'll head over to Intellij. Now here I'll go to the terminal by clicking on this icon on the left hand side. Okay, and here I'll paste that command. So just make sure that you are in the root directory of the project. Okay, so we just need a terminal. You can run this command even outside Intellij in PowerShell or like a normal terminal if you're on Mac or Linux. So the inbuilt terminal should do the job, but make sure you navigate to the root directory of the project. Okay, and I'm going to specify the image name. So I'm going to say tcode007, which is my username, / I'll say job app image, like so, and I'll press enter. So we got this error here. Okay, and yeah, this says build failure. So there is a possibility that you might get this error. Now how to solve this is you need to add 2 inverted quotes like for this command, this entire command. Okay, so I'll just copy this entire command here. Okay, and I'll just paste this over here like so, and I'll hit enter. So now you will see a lot of processing that is happening. Okay, so this will take some time, so you will have to wait for a while. Okay, we got another error. Okay, and let me check what this error is. Okay, so this error says that it failed to connect to Docker daemon. Okay, which means Docker is not running on my system. So before running the command, just make sure that Docker is up and running. So I'll just turn on Docker and I'll just launch the Docker desktop that we have downloaded. So Docker engine is starting because in order to create an image, you need to have Docker up and running. So this will take some time. And once the Docker engine is up, you can go ahead and run the image. So the engine is up. Okay, now I'll go over here. I'll run this again. And now let's wait as to what happens. Okay, so there are no issues as such. Okay, and you can see it has started. You'll see everything on the console. So Paketo build packs. So it's getting the images from Paketo build packs and it is getting the base image. So just take a note of what all processing is happening on the console for a while. Okay, and you can see it's pulling the entire base image of the builder. Okay, and Paketo build packs is something that is used in this entire process of image creation. So this will take some time. Okay, so the entire process is done, and let us take a look at logs and understand what all happened. Okay, so if you scroll up here, you will see a lot of processing that our application went through. Okay, so here you will see a lot happening. So if I scroll up, you will see, so here there were quite a few build packs that were being used, and these were from Paketo. So these were all fetched. You can see the entire fetching that happened. Okay, these were all fetched locally and they were run, and then there were a lot of layers that were created. So if this is a lot of processing, and then if you scroll down over here, okay, you'll see adding layer. So these were all the layers that were created in our application. Okay, so you can see adding layer. This is certificates, and there is one more layer that was created, and so on. Then there is a layer on security, and then there is a layer on config. Okay. There's a layer on image title, image version, the Spring Boot version as well. Okay. So all of this was created and there was a layer. So there was a layer for a lot of stuff. Okay. So layering happened. All right. And then our Docker image was built. So this is our Docker image that has been built. Okay. And we got this message, build success. Okay. So the image is completely built now. Now, what do we need to do? So now we can push the Docker image to the Docker registry. Okay. And how do we do that? So for that, we need to run a command. Okay. So we need to say Docker push, and I need to say my username. So my username is k8s, and I need to, so I'll copy this entire thing. So k8s/job app image. Okay. And I'll paste it here. Okay. But I'll also mention one thing. We have not yet logged in from the Docker CLI. Okay. So in order to push images, you need to log in. But let us see what error message we get. Okay. So it says access denied. So I need to say Docker login here. Okay. And it will ask for a username. Okay. So I can say k8s007 like so. And I can give the password. So enter the password and say enter. Okay. And it says unauthorized. Okay. So there is some problem. I'll try again. Okay. So login finally worked for me. And the reason it was not working is because I was entering incorrect username. So it was k8s007 and not k8s. So silly mistakes, but that is fine. So I have succeeded to log in onto my terminal. And now I can say, we can run the command docker push. Okay. So we have this command. So I'll say docker push k8s007 job app image. Okay. And I'll run this. Now, the moment I run this, you will see that everything is happening. So you can see it's going to this repository. So this is my repo against my username. And you can see the image is being prepared and it's being pushed into pieces. Okay. So it will take some time depending on your internet connection speed. But once this entire process is done, you should have your application up and running on, sorry, it won't run. So the image will be up there on Docker Hub. Okay. And you can see that it's done. So let us head over to browser. And here I'll head over to repositories tab here. Okay. So I'll say repositories. And here you can see we have this image here. So if you click on this, you will see this is something that we have pushed right now. Okay. Using this particular command. Okay. We didn't specify the tag name. Okay. But we just pushed it. Okay. Now we don't have any description, so you can add a description. Okay. And yeah, so you have your first Docker image that you created. Okay. And this Docker image has your Spring Boot application and it is available on Docker Hub. All right. So that's about this class. And I hope you have your own image as well right now published on Docker Hub. So if you follow the steps that I outlined in the lecture, you should have done this too. So that's about this class. I shall see you all soon. Thank you. Let us start discussing about different Docker commands that exist and are commonly used. Now, I'll mention one thing before talking about Docker commands is this might seem a little bit overwhelming, but don't worry and don't get afraid, because these Docker commands you will eventually learn when you start using Docker regularly. So it might seem like a long list, but actually if you are using Docker in your day-to-day life or when building applications, you will get quite familiar with a lot of commands. So the intent of this lecture is not to tell you to memorize all the command, but just understand like these are the different commands that are available and this is how they are used. And these all things you can also do with the help of command line tools. So that's the goal. So let's start talking about. So this is the first command that I want to talk about is docker pull. So this command is used to pull the image from the Docker repository. Like let's say we have pushed an image to Docker Hub, and you can use this command to get the image from Docker Hub onto your system. Okay. This command is used to push the Docker image to Docker Hub. So you can specify Docker push, then your username /image. This command is used to run Docker container from the image. Okay. So you say Docker run, and then you have IT. So I means interactive. Okay. IT stands for interactive. D stands for detach mode. Okay. Detach mode means you can, so basically if you run in non-detach mode, you can't do anything else on the terminal. Okay. And if you close the terminal, the container stops. So if you run in detach mode, it runs as a separate process. And -P stands for port mapping. So you might want to map the port of the container to that of host machine. So you can do that using port mapping. So here you can specify host port and the container port. Okay. And here you are making use of name, and this is the name of the process and the image. Then you have docker stop command, which is used to stop a running container, and you can specify the container ID or the container name. Then you have a command to start a container. So you have container ID and or container name that you can specify. Then you have docker rm command, which is used to remove a stopped container. So if you want to delete a container that has been stopped, you can make use of docker rm. Then you have docker rmi image ID or image name. So this command is used to remove an image from a local storage. So images that you create will occupy some storage. So you can get rid of them when you run this command. Then you have docker ps, which is used to get the running Docker containers. And this will give you all the containers that are running. Then you have docker ps-a, which is used to show all the containers which are stopped as well as running. Then you have docker images, which is used to list all the images on the host. Then you have this command, which enables you to access a running container. So if you want to log in to a running container from the terminal, you can use this command wherein you say docker exec it and you specify the container name or ID followed by bash, and you will log in from the terminal into that particular container. Then you have docker build -t username image. So this is used to build an image from the Docker file. So if you have a Docker file defined in the registry, in the current directory, so this dot over here specifies the current directory. So it picks up the Docker file and creates the image, and the image is created with this name. Then you have docker logs. So this particular command is used to get the logs of a particular container that is running, or a container that exists. So there might be scenarios wherein you might face some issues running the application within the container, and you might want to check the logs. So this command is really helpful there. Then you have docker inspect, which gives you the detailed information of a particular container. So these are all the Docker commands that I wanted to highlight. Okay. You can even run these few commands in your terminal and check yourself. So here I am in my terminal within Intellij. I can say docker images, and this is going to give you the images that exist on your system. Okay. So here you can see we have created the image for job app. So you have that image. Then you have Paketo build pack builder and run image as well. Okay, which is needed for Spring Boot applications. Then you can say docker ps, which gives you the list of all running containers. So we don't have any running container. Okay, so we didn't get any response over here, but it will give you container ID, image, command, and all the other information. So this way you can try out some of the commands and play a bit. Now let us run the Spring Boot application that exists within the Docker image. Okay, and for that we'll have to run the Docker image. So we already have this image on our local machine. Okay, so if you don't have, you can pull this image from the remote registry and you can make use of Docker pull command. So Docker pull and the image name will bring you this image onto your local system. But I already have, so I'm going to first copy the name of this image. Okay, and then I'm going to say Docker run, and I'll say -p 8080 colon 8080 space, and I'll paste the image name. Okay, so this is a command that I'm running, and I'll say enter. So you can see now our Spring Boot application is running. So it says started first job application. Okay, so let us understand this command that we just triggered. So we say Docker run. This is used to run the Docker image. Then we have -p 8080 colon 8080. So here we are mapping the port of container to that of the local machine. Okay, so our application will be running on 8080 port within the container, and we are saying like map the port on my local machine to that of the container because we need to access our application, right? So we are doing this mapping, and once we do that, we run this and we have our application running. Now if we head over to Postman, and let's say if I try to get the list of all the jobs, okay, we get an error. Okay, now let me see what the error is. So the error has to do with the foreign key where the company ID didn't exist. So I'll try another query where I'll create a company, or I'll create a job. Okay, so I'll create a job, and you can see job added successfully. I'll add it twice, and I'll go to /jobs URL, and you can see I have 2 jobs over here, up here. Okay, so our application is working perfectly fine. Okay, I can get the list of companies as well. Okay, so let me get the list of companies. You can see this is the companies, and you are able to access your application like any other application as if it is running on your local machine. Okay, and that's the beauty. And if you see over here, it's not running in Intellij. So Intellij application is stopped. Okay, but the problem here is this has blocked our terminal over here. Okay, so if you don't want this terminal to be blocked, what you can do is I'll say Control C over here, or Command C, you can say. It will forcefully stop the application. Okay, and now you can press the up arrow. So this will bring up the previously run command, and it was the run command that we just executed. Now you can run this in the detach mode. So you can say space -d. So you can just add this flag which tells Docker to run this image as a process in the detach mode. So now if you press enter, you'll see that we get this ID over here. Okay, and now if you say Docker PS, so this command lists all the running containers. So if you do this, you'll see you have like this image, and this is the container ID. So this is the ID that we got over here. Okay, so yeah, so this is the ID and the container is running. Okay, you can even get the logs of this particular container. So I can say Docker logs, and I can paste the ID over here. Okay, so you can see these are the logs of our container. Okay, so all the logs are printed over here because we executed this logs command. Okay, so this frees up the terminal, and if you run Docker PS, you can see that it's running as a container, and still you can access your application. So if you want to get the list of all the jobs, okay, you'll get empty list over here. So application is working perfectly fine. It has been containerized and it's running in Docker container as a process, and we have exposed the port 8080 and we are accessing it through the local host port 8080 and we are able to access it like any other application. So that's the beauty. So yeah, I hope you all have been able to successfully follow these steps and also containerize your Spring Boot application. Welcome to this class. So let us start talking about PostgreSQL and why we should use it. So what is PostgreSQL? So PostgreSQL is an object relational database management system, or you can say ORDBMS, okay? And it is often referred to as Postgres. So this is an database management system that places a strong emphasis on SQL compliance and extensibility. So it's free and open source, which means that it is accessible for anyone who wants to use their database for their needs. So we'll head over to the browser and here I'll search for PostgreSQL. Okay, so I'll say PostgreSQL and you'll see this official website over here. Okay, so it's postgresql.org. So I'll go to this website and you can read more about this tool over here. Okay, so it's a powerful object relational database system. Okay, and it has been in development for 35 years. Okay, and it's known for its strong reputation for reliability, robustness, and performance. Okay, so it's a quite popular database management system out there. Okay, you can check out the website and back to the slides. So why is PostgreSQL popular? So the number one reason is SQL compliance. So PostgreSQL follows the SQL standards more closely, okay? And it makes the life easier, using which you can create more and more applications. It is also known for extensibility. So PostgreSQL allows you to define your own data types, operators, indexes, and so on, okay? Performance. PostgreSQL has a reputation for being robust and good with performance, especially when you write complex queries. Also, PostgreSQL is known for strong community support. Okay, so since it's an open source platform, this particular database management system has a large community. Okay, and there are regular updates, improvements, and development that happens. Data integrity. So PostgreSQL has strong emphasis on data integrity. Okay, and if you are building an application that needs data integrity, so PostgreSQL might be the best choice. Let us talk about why are we choosing this particular database. So we will be moving our application to PostgreSQL. So why would we do this? Why choose PostgreSQL over H2 database? So H2 is a very capable database and has an advantage of being embedded in Java, which is really convenient. Okay. However, when it comes to building large application, like large production grade application, PostgreSQL has lots of advantages. So the number one advantage would be scalability. So PostgreSQL is really scalable and it enables you to work with high volume of data and supports lots of concurrent users. Feature set. So PostgreSQL has richer feature set as compared to that of H2. Okay, and it supports a broad range of SQL standards, data types, and functions. Ecosystem and tools. So PostgreSQL is really popular out there and it has a very broad ecosystem. Okay, it has a wide range of GUI tools like graphical user interface. You have libraries, third-party support, community support, and so on. So PostgreSQL is really ahead in the game here. Durability. So I would say PostgreSQL is much more durable and it is often the best choice for production grade environments due to its durability and robustness. While H2 is the best choice for development and testing for quick start. So to summarize, while H2 has its own use cases, okay, especially when you are building lightweight applications and doing some rapid prototyping, but PostgreSQL comes out to be more powerful, flexible, and scalable solution. making it a superior choice for developers building production grade applications. So that's about PostgreSQL. So let us understand the dependencies that we need to add to configure our job application to work with PostgreSQL. So what we are going to do is we are going to head over to our favorite website, start.spring.io. Okay. And I'm going to select Maven over here. I'm going to go to add dependencies here on the right hand side. And I'm going to search for PostgreSQL driver. Now, this is a driver dependency and it's a JDBC driver that allows Java programs to connect to PostgreSQL database. Okay, so I'll select this. We will head over to Explore. And here you will see the dependency being added for PostgreSQL. So what I'm going to do is I'm going to simply copy this dependency, head over to Intellij. Now in Intellij, here you are going to paste this particular dependency here. And this is in pom.xml. Okay. So you will get red marks, which means like you need to reload Maven changes. So here you will also see this icon appear. So I'll hit this icon and now you will see the Maven dependencies are being resolved. So yeah, once the Maven dependencies have been resolved, like you should see PostgreSQL appear normally. Okay, so the red marks have gone. So what we have done is we have added the dependency to work with PostgreSQL. So let us now configure our project to work with PostgreSQL. So we have our dependency added. Now to do some additional configuration, I will head over to main, resources and application.properties. So far, we have just added the dependency, but we need to tell our application as to where to connect, what is the database username password, and some other details which will enable our application to work with PostgreSQL. Okay. So what I'm going to do is we have here the configuration for H2 database. So I'm going to add a comment here. I'm going to say H2. Okay. Like so. And okay. And I'm going to comment all of this. So how can you add these comments on Windows? You can press Control and / on Windows and Command and / on Mac. All right. So yeah, I'll scroll down or we can add over here itself. Okay. So I'll say PostgreSQL. Okay. Now here we are going to first define the data source. So this is the property that we'll set. So we'll say spring.datasource.url. Okay, and here we'll say JDBC :PostgreSQL, and I'll say : 2 / I'll say localhost : 5432, and I'll say /job app. So here we are saying JDBC : PostgreSQL, which means that we are using PostgreSQL database. And we are running an instance on localhost at port 5432. So this is the default port where PostgreSQL runs. And job app is the database where we will connect. Okay. So this is done. Now we need to say username and password. So I'll copy this and I'll paste it over here. And I'll say username is equal to embarkx. So you can choose the username of your choice. Okay. So I'll copy this and I'll paste this below and I'll rename this to password like so. So this is our username and password that we are specifying. So in short, these are credentials using which our application will authenticate itself with the database. Okay. We also need to specify spring.jpa.database, or which specifies which database we are using. So I'll say PostgreSQL. So this is the value that I have specified, PostgreSQL. Then we need to say spring.jpa show SQL. So this is a property that we had set with H2 database. So we are going to set this to true again. And this setting is useful in development, and the reason is because of this setting, Hibernate is going to print all the SQL statement onto the console. So Hibernate is a JPA implementation. Okay, so it is going to print everything onto the console. And then we are going to have this property as well, which talks about whether the database should be created or updated. Okay, so we can say create drop for now. Okay, so this tells Hibernate or JPA to automatically create and drop the database schema based on the entity class. Okay, and create drop means that the schema will be created when this session is created, and it will be dropped when it's destroyed. Okay, now we need to also mention the database platform. So we'll say spring.jpa.database. So database hyphen platform. Now here we will be specifying the dialect. So this tells Hibernate which dialect it should use. Okay, now what is a dialect? So dialect is a configuration of SQL generation. Okay, and it varies from database to database. So since we are using PostgreSQL, we will say we want to use org.hibernate.dialect. So you can see different suggestions here. So I'll say PostgreSQL dialect. PostgreSQL. You can see there are a lot of suggestions over here. So if you say SQL Server, you have SQL Server dialect as well. Okay, so I'll say PostgreSQL dialect. So this is a dialect that I'm specifying here. Okay, so yeah, here is the auto suggest. Okay, so this is the one we are using. All right, so these are the settings that we need to do in order to configure our database to work with PostgreSQL. So I hope you have a clarity of each and every setting. Okay, and I hope you have configured the same for yourself as well. Welcome to this class. So let us start talking about Docker networks. So we would be discussing Docker networks with the help of two Docker images that we would use. So one image we would use of PostgreSQL. So this is a database that we are going to need, using which our application is going to interact. Okay, so it will host our database, which our job app is going to interact with. This is one image that we are going to get. And then we are also going to need a PG admin, which is PostgreSQL admin. So this is an admin panel that you get to work with PostgreSQL. And it is one of the most popular open source like administration tool, okay, for PostgreSQL. Okay, and it's being used by a lot of developers out there and a lot of companies as well. Okay, and you can see it works with different platform here. So you can read more on this website. So if you search for PG admin, you will be taken to this website, which is pgadmin.org. And if you hover on the screenshot, like you will see this image come up, and this is what PG admin looks like. Okay, so what we are going to do is we are going to take these two images and we are going to talk about the concept of Docker networks. So what is a Docker network? So Docker network allows a communication between multiple Docker containers. So if you are running multiple containers and if they need to communicate with each other, you will need to make use of this concept called Docker network. And as the name suggests, it's a network that works with Docker containers. Okay, so using this network, we are going to communicate across the containers. All right, but let us understand how this works. Okay, so what I'm going to do is I am going to head over to Intellij and I'm going to open up the inbuilt terminal. You can use any terminal of your choice, like if you're using some other operating system, or like if you're using Windows, Linux, or Mac. You can use any terminal, but just make sure you are inside the root directory of your project. So you can run Docker commands from anywhere in the system. as long as you have the Docker app running. So this Docker desktop is running. So I can use Docker commands from literally anywhere. But there is a reason why I tell my students to run the commands from the project root folder is because if you're building images, so images, I mean image of your application that you have created. So if you need to create an image for this job application that we create, you need to be in the root folder. Okay. It's just best if you are in the root folder and if you use that as your main working directory on the terminal as well. So that really helps. And with Intellij, if you open up the terminal, you are by default logged in to the root directory, as you can see over here. All right. So this is about terminals. Okay. You can use any terminal of your choice. So I'll be using Intellij terminal over here. Okay. Now what we can do is I'll use docker run command. Okay. So if I say docker images, I'm going to get the list of all the images. I don't have an image for PostgreSQL. Okay, so what I'm going to do is I'm going to say docker run. I'm going to say -d because I want this image to run in the detach mode. Okay, I'll say name over here and the name will be db. So that is the name that I'm going to give. Okay, I'll say -e and I'm going to set some parameters over here. So I'm going to say Postgres _ password. So this is a password that we are setting. Okay. And -e allows us to set environmental variables that the PostgreSQL image uses. And here we are using the environmental variable to set the database password. Okay. So I say Postgres password is equal to like my secret password. So I'll just enter password, or you can just enter a password, say, of your choice. So I'll enter this password, right? And now what you can say is you can specify which image you want to run. Okay. So this is the image name, Postgres. Now I'll say enter. Now the moment I say enter, you will see this message like enable to find the image Postgres latest. So we have not specified which version we want. So you can specify the tag or the version after a colon here. But if you don't specify that, it will by default pull the latest. And you can see it pulled latest. And it was also able to detect that we don't have the image locally. Because when we did Docker images, we didn't find the image locally. Okay. So what it did is it pulled the image for us. Okay. So the pulling was complete and it started the image as the container. So it started the container from the image. Now, if we say docker ps, not hyphen. So you're going to see this container is up and running with the name db. Okay. So this is a Docker container that I have now. Now I need to run a second container. Okay. And this is of pgadmin. So I can say docker run -d. Okay. And now I'm going to specify the name. I'm going to say pgadmin like so. I'm going to say -e and I'm going to type in pgadmin _ default email. And the default email is admin@admin.com, something like this. So I'm just setting up some hypothetical email over here. Okay. I'll say -e and I'll say pgadmin _ default _ password. So here we are setting the password. Okay. And I can say the password as this one. Okay. And then I need to get the pgadmin image. So I can say /pgadmin like so. Now I'll press enter. Okay. Let us see what happens. So it will again say that it cannot find the image locally and we got the error. Okay. Okay. So this image was not pulled and we got an error. So I'll change the image name to pgadmin4. Okay. And you will see that the image was pulled, okay, and it worked. So I can say Docker images, you have the image now, pgadmin 4, and if you say Docker ps, you will see like the image is running, okay. Now let us see if we are able to communicate across containers. Okay, so these are two containers that are running right now. Okay, now I have a notepad over here, okay, wherein I have all the commands written. Okay, you can see all the commands here. Okay, now what I will do is I'll run this command. So this first part of the command allows us, so docker exe allows us to execute command in a Docker container. And when we say IT, we are making use of interactive console. So input and output, we are making use of input output of a particular container. And then we specify the container name. So here is where we are executing the command. And this is the command that we are executing. So we are saying ping this particular container. So essentially we are saying from pgadmin container, ping database container. Now what is ping? So ping command, if you're not aware of, it's a tool essentially to check the reachability of a network, okay, whether a device is connected to a particular network. So it checks if we are able to communicate with this particular container over here, okay. So I'm going to copy this docker exe it pgadmin, and here in Intellij, I'm going to paste this and I'll press enter. So of course you get an error, bad address DB, which was expected because you don't have network connectivity between these two containers. Okay. Now what we need to do is we need to remove both the containers over here. Okay. So I'll remove both the containers. So I'll say rm-f, which is force, remove db and pgadmin container. Okay. So we tested how like Docker container cannot communicate without a Docker network. Okay. So now I remove these two. Okay. Now if I say Docker ps, you don't have any running containers. So first we need to create a Docker network. I'll create a Docker network using this command. Okay. So I'll head over to, let's say, Intellij. I'll paste this. Okay. And we have a Docker network created. Okay. Now, what we need to do is we need to say docker run, and now I'm running the same command. So here initially I run an instance of Postgres. Okay. So I'm running an instance of Postgres again, but this time I'm adding this value over here. So I'm saying network, my network. All right. So I'm going to copy this and I'm going to run this. So I'll say paste, enter. So we have this container now running, but this time it is making use of my network, okay, which is the network that we just created using this particular command here. Okay. Now I'll even run the pgadmin with the help of network. Okay. So I'll run this again, pgadmin 4. We have this running. Now if I say docker ps, you will see both these containers are up and running. Now what I need to do is I need to run the ping command again, okay, in a similar way like I did earlier. So I'll say paste over here and I'll say enter. And this time you can see like the network information, it's working fine. So earlier, if you scroll up, we got bad address, and that is because they were not on the same network. But this time we are making use of a network. So I'll stop this, otherwise it will continue going. But you can see there were 18 packets that were transmitted and received through the network. Okay, and we tried communicating from pgadmin to that of db. Okay, so this illustrates that when containers are in same network, they can communicate with each other using the container names as host names. So here we made use of container names. So ping db. So db is nothing but a container. So if you say docker ps, you will see a container with this name running. Okay. So we used container name as host name, and we saw an output with the help of ping command. And what is ping command? It's a tool to check network reachability for a particular host. Okay, and it's a quick way to verify that whether we can reach out a container or a device over the network. Okay, which is very vital if you wish to interact in future. Okay, now why do you need to communicate across containers, you will ask? Well, it's really important to do communication across containers. The reason is we have PostgreSQL running on a container, right? So here we have two containers. So this is pgadmin and Postgres. So they both are running right now, but how do you communicate? So pgadmin needs database. So it's a admin tool, DB admin tool, right? So it will have to connect to the database, which is PostgreSQL. So how would it create a connection? Because Postgres is running on a different container. And for that, we need Docker networks. And Docker networks is an amazing tool, okay, to help you communicate across containers. So that's about Docker networks in a practical way for you. Welcome back. So I wanted to introduce you all to some more parameters when you create PostgreSQL and pgadmin and when you run it as a container. Okay, so this is the updated set of commands that we should use in order to make use of PostgreSQL. So here like -d stands for running the container in detach mode. You have the name of the container that you have specified here. Okay, so I've changed the name to Postgres_container. Then you have the username and password setup. And here we are also setting up PG data. Now this specifies the data directory for PostgreSQL. Okay, and here we are even specifying a volume with the help of -v command. So -v mounts a Docker volume named Postgres to this particular path. And this is a path within the container. This is used to persist the PostgreSQL data. Since we'll be working with data, so we need this volume. And I also need to map the container's port to our local host so that we can work with it. So I've said -p, which is the parameter that you can use to map the container's port. So here I've said 5432 on host should be mapped to 5432 within the container. And then I have added this particular container to this network, Postgres, and I have specified restart unless stopped, which means that the container should be automatically restarted unless explicitly stopped. And here I have the Docker image name. Okay, so this is the updated list of commands. Okay, you can customize the parameters if you need, like you can customize the name and all if you need to, but these are the parameters that we should use to run Postgres. We also have the similar command for pgadmin, wherein we are even mapping the port over here. Like 5050 on localhost is mapped to 8080 within the container. And 8080 is where the pgadmin service will run within the container. Okay, so I've specified these parameters and we will see these parameters in action. Well, we took a look at the configuration that we need to do for our Docker containers. And well, it's a matter of time that our application grows and we need to create a lot more container for using a lot more services in our application. So with growing list of containers, how do you manage them? So do you manage them all with the command line? Yes, you can run Docker commands and manage your containers from the command line. But there is a better way to manage your Docker containers. And let's talk about this amazing tool called Docker Compose. So Docker Compose is a tool for defining and managing multi-container Docker application. Okay, so you as a developer can define all the containers that you wish to have for your application. And with a simple command, you can run all your containers at one go. So here we have to manually run all these commands with all these configuration. And if anything changes, we have to rewrite the command. You have to make sure you save these commands in Notepad and so on. But I don't want to manage things this way. So Docker Compose is a brilliant tool that enables us to manage all of this efficiently. So what you have to do is you have to create a Docker Compose file, which is a YAML file, and you can define the configuration of different Docker containers. And these containers will be run as a service. And within that single file, you can define everything related to Docker. So you can have your container definition, you can have the network definition, volumes, and so on. Okay. So I have an example Docker Compose file, which I have created using these commands. Okay. So let me open the file here. So this is the file for Docker Compose. Okay. So this is Docker Compose.yaml. It starts and looks like this. Okay. So it starts with service tag. And let us talk about each of the tags that we have over here. So we have services tags, okay, which is used to define services. So this is a keyword that exists and it is used to define the services that makes up your app. Okay. Now services are nothing but containers in Docker. Each service that you define runs as a container. So if, for example, under service tag, you can see this is one service. And this is another service. So there are two services that exist. Okay. So after service, you have the containers, okay, that you wish to create. So these are all the container definition that exists. And within Postgres, so you are saying over here, the container name, the image, the environmental variables that you are setting, the environment that you are creating, the volumes, the ports, networks, and some other parameters if you wish to specify. So you can specify all your configuration this way and you can run this with a single command. So what will happen is in the older approach wherein you had to run all of this individually. So you have to run this command, then run this command. And if you want to stop anything, you have to go and stop manually. Okay, so you have to run those many stop commands for every container that you have. And let's say if you're building a huge application and if you have like tens and 20 or like hundreds of containers that you're running, it becomes cumbersome. Okay. So Docker Compose makes your life easy. So you have the single file with which you manage everything. You have the network definition here at the bottom. And here you have the volume as well. So the volume definition is also something that you have mentioned. So I'll copy this entire file. We'll head over to Intellij. I'll minimize this terminal and here in the root folder. So here I'll say new, I'll say file and I'll create a file. I'll say docker-compose.yaml. Now this is a YAML file that is created and with this, you will also see an option to install Docker plugin. Okay, so you can install if you wish to. Okay, so I'll get this installed. So you can see Intellij has some good support for Docker as well. Okay, so I'll minimize this. We have the YAML file here. I'll paste the configuration that I just created. Okay, and you can see with the help of this plugin, now you can see we have the option to run this particular service right from here without the command. Okay, so if you just hover on this, you will see the command docker compose up. So this is the command that you have to run this entire file with the help of Docker Compose. Okay, so if you want to start all the containers that you have defined, you need to say Docker Compose up. Okay, so you can see this command coming up, Docker Compose up. And if you want to run it in detach mode, you can say Docker Compose up -d. Okay, and if you want to run a single service, you can say Docker Compose up Postgres, the service name you have to specify. And the service name is Postgres. Okay, so this is a really good tool and it allows us to work efficiently with Docker containers. So I'm going to save this and I'm going to head over to PowerShell. Okay, so here I'm in the root project directory. Okay, and if I say ls, I have, okay, I'll head over to first job app. And if I say ls, I have docker compose.yaml. So you need to head over to the directory where you have created the docker compose file, and you need to say docker compose up. Okay, now the moment you say this, okay, docker compose is not a command. So I'll run this command again. Okay, I'll say docker compose up. And when you run this command, you will see like pgadmin is being pulled and Postgres is also being pulled, and it is being pulled in form of layers. So you can see over here. Okay, and you will see the entire status appearing. So initially the command didn't run docker compose. So it was not being identified because there was an issue with Docker installation on my system. So I just uninstalled Docker completely and installed a fresh download. Okay, and once I did that, I started Docker engine like Docker desktop, and then I have the command running. So for Docker Compose to work, so Docker Compose is a separate tool, but it comes inbuilt with Docker desktop. Okay, so if you have Docker desktop installed, Docker Compose should work for you. Okay, and once you run this command, you will see like the entire processing being done. So first the image was pulled, like these two images. Then the network was created. Then the volume was created. Then this volume was also created. And then after doing this, container was created. Okay, and then the containers were attached. Okay, and then like all the processing happened. So you can go through the entire stack trace. Okay, and you can see what all happened. Okay, so you'll see like the entire processing happened. Okay, so everything worked fine, and this is Docker Compose. So right now we have run Docker Compose, but we have not run it in detach mode. So what you can do is like we won't be able to use this terminal. So because we have not run it in detach mode. So whatever logs appear, they'll appear here in real time. So I'll stop. I'll say Control C, or if you're on Mac, you can press Command C and it will forcefully stop the container. You can run this in detach mode. Okay, but before running, I'll check Docker PS. So none of the containers are running. Docker image. Okay, sorry, Docker images, and you will get two images over here. Okay, now what I can do is I can run Docker Compose up -d, and this will run this in detach mode. So you can see it has started in detach mode, and you can say Docker PS to check if the containers are running. Now the question is, how do you check for logs? So here, when you don't run in detach mode, you can see the logs. Okay, you can see all the logs, what is happening. Now let's say I want to check logs for a particular container. So you can copy the container name. So Postgres_container, and you can say Docker logs and paste the container name. And this will show you all the logs that has happened for that particular container. Okay, so isn't this wonderful? Docker Compose is one of the wonderful tools to work with Docker, and I highly recommend using it. So you can see how with a single file, which is dockercompose.yaml, you have everything defined over here. Okay, now imagine doing this like in the terminal, like running all of these parameters in terminal. Okay, you would have to create a notepad file, and you would have to save all the commands that you're executing so that you can reuse them later on. Okay, it's really cumbersome, but this makes your life much more easier. So with terminals, you also have to make sure like you create networks first, then you define volumes, and then you attach the volume and so on. So you have to be in sequence when you're working with terminal. But with Docker Compose.yaml, you just specify what you want, and Docker Compose takes care of everything. Okay, and it's a really useful tool, and you will often hear Docker Compose when you're working with Docker. So that's Docker Compose for you. Well, now that we have our containers running. So you can see Docker PS and you'll see the container is running. Now we should access pgadmin from localhost and we could work on creating the databases. Okay, so you can see over here localhost colon 5050 port is mapped to pgadmin within container 80 port. So you should be able to access pgadmin dashboard with this port over here. Okay, so I'll copy this and I'll head over to my browser and I'll say localhost colon 5050. Okay, and I'll say enter. So you can see we get the welcome screen. All right. Now here it's asking us to set a master password for pgadmin, and this will be used to secure and later unlocked safe passwords and other credentials. So just be careful of what you're setting over here. I'll set a password for myself, a simple one that I can remember. So I'll say OK. And now here you have this dashboard. So for our application, if you head over to application.properties, you will see this configuration for PostgreSQL. So we have specified that we need this database job app with username embarkx and embarkx. So I'll create this particular database in PostgreSQL with the help of pgadmin. So back to our browser. Here I'm going to say create, and or instead of right clicking here, you can even click on this link over here, add a new server. So we need to add a server, okay, and we need to specify the credentials. Okay, so I'm going to say Postgres container, like so. You can specify any name here. Then we go to connection tab. We'll say Postgres as the host name because that is what the host name is. Okay, so that's the service name with which we are going to access it. 5432 is the port. Okay, maintenance database, I'll leave it as default. Username, I'll keep it as this username here. Okay, and the password also I'll specify here, and I'll say save. Okay, now the moment you say save, you will see this connection appear over here, and if you expand on this, you will see the list of the databases over here. Okay, so you have this database coming up over here. Now we need to create a database here. So I need to say database, and the database name is job app. Okay, I'll say save. Okay, this database is created and you can see everything around this database here. So you have different objects and here you have schema. So if you click on this, you will see this open up like the public schema, and you can go over here and expand these tables tab. So there are no tables right now created. Okay, but you will see the tables information appear over here. And this is a general dashboard for what is happening on the server, okay, on the database server. So it gives a very nice view to see what all is happening on your server. So transactions per second, tuples in, tuples out, okay, the database sessions and so on. Okay, so there is one active database session, which is us. So you can really use this as a tool to monitor and manage your PostgreSQL database. So this is how you can access the pgadmin interface, and this pgadmin interface is something that is running in the container. We have not installed pgadmin onto our system. We have not installed PostgreSQL onto our system. Okay, everything is running within a Docker container, and we are using localhost colon 5050 port, which we have mapped to the default port where pgadmin is running within the container, and we are able to do the magic. Okay, we have in fact also connected to the database now, like the PostgreSQL database server, and we have created a database within that server. So it's amazing. So that's about pgadmin. So with our database setup, I'm really eager to start our application and see the application running on the PostgreSQL database. Okay, so let us run our application and let us see if we are able to successfully run this application or we land up in errors. So I'll click on this run icon at the top. Okay, and we will see the application starting. Okay, so we will wait for a while and we should see. Okay, so the application has started fine. Okay, there were no issues as such. Let us head over to pgadmin and let us see if the tables were created successfully. Okay, so when you start the application, you should see the tables being created here. So I'll say right click and we will have to refresh here to refresh the information. And the moment you refresh, you will see 3 tables appear. One is the company, the job, and the review. And if you expand each one of them, you can see the columns as well. So here you have columns, constraints, indexes, and other objects. Or if you don't want to use this view, you can say company. You can right click on company or the table that you want to, and you can say view or edit data, and you can see all rows over here. Okay, so you will see this query being automatically executed and you will see the rows appear over here. So right now we don't have any data that exists in this particular table. So we are seeing 0 rows of 0. Okay, but we are seeing the columns here. So we have ID, which is primary key and it's of big int type. We have description, which is of character type, name, which is of character type, and it's of varying character type, which is varchar. So yeah, table setup is done completely fine, which means our application is now able to talk to the database that is running within the container. And this is a Docker container where PostgreSQL database is running. Okay, now let us try creating some companies, some jobs, and even some reviews with the help of Postman. So here, if I try to get a list of all the jobs, of course, I'm going to get an empty list. So let me create my first company right now. So I'll create this company here. I'll say company 1 and description 1. So if you go over here, we had empty company table. Now, if I say this post request, let us fire this, you'll see company added successfully. And if you come over here and if you rerun this query, so I can click on this run button, or you can go back here, refresh and say view or edit data. But I'll say rerun and you will see the company data appear over here. Okay, so this is working perfectly fine. Now let me create a job, or let me create one more company. So I'll have 2 companies. Okay, I'll send this post request and then I'll create a job. Okay, so I'll create a job against the company ID 1. I'll say software engineer needed 1. You send this, you get 201 created. Okay, 201. I'll create another job. Okay, and this time against company 2. I'll send this and you see job added successfully. I'll even add a review. So I'll say review 1. Okay, I'll send this and then I'll run review 2 and I'll send this. Okay, now let us get everything. So let us try to get all the jobs. You can see you have the JSON of all the jobs with company, reviews. Okay, you have the second job with second company but no reviews, because both the reviews that we added were against the company 1. Okay, you can even get the company from here. Okay, so I can get the list of companies. So the moment I run this, you will see the company information come up. Okay, and reviews also should work fine. Now if you go to pgadmin and if I refresh everything, okay, now if I run this company table query, you will see 2 company here. Let us see the review information or job information first. So you will see there are 2 jobs that have been added and they are added against 2 companies. We can even run for review. You can see there are 2 reviews that have been added with the rating that of 5. So we have successfully set up our application working with PostgreSQL. So our application has been able to connect to PostgreSQL and it's working really, really well. We are seeing all the queries being executed via Postman and the data is being entered into this database. Okay. So that's about this class. I shall see you all soon. Thank you. Let us start talking about the world before microservices. So before microservices, the application used to be built using monolithic architecture. And as the name suggests, monolithic architecture is a unified model for a software application. Okay, you can think of it like a big container where all the functionalities of the applications are interconnected. Okay, so you can think of this like you have a user interface, business logic, data processing. You will also have database operations, all of that packed into a single unit. Now, when you build a monolithic application, you are essentially creating one large code base for all different functions that your application performs. Now, monolithic architecture has everything unified, so everything is packed into a single component. You can also think of monolithic architecture as a design where all the application or all the components in an application are interconnected and interdependent. Okay, so you will have all of this packed into a single logical executable unit, like I mentioned. Okay, and hence the term monolithic. So here I have our job application right now, which is in the monolithic form. Okay, you have company, reviews, job, all inside one project. Everything is interlinked. Okay, and it's also running on a single server. So when you access this application from the browser, you are essentially sending requests to this one server that you have. And within this, you have multiple components like company, reviews, and jobs that are interconnected. And all these components talk to the database. Okay, and database is also the shared database, which is a single database used for all company, reviews, and jobs. So that's about the world before microservices. So let us start talking about the problems with monolithic architecture. So monolithic applications are tightly woven fabric. Okay, so they are like a tightly woven fabric. And if you try to pull one thread out of it, it can cause the entire structure to unravel. Okay, so this means if you wish to or if you want to update or modify a specific feature, we might have to redeploy the entire application. And this can lead to longer development cycles, okay, and also deployment cycles, increasing the time it takes to get the changes out to the user. Okay, so let us take a look at some of the problems that we typically face with monolithic architecture. So the number one problem would be difficulty to implement the changes. Okay, so like I said, monolithic applications are like tightly woven fabric, and if you want to implement a single change, there is a possibility that you might have to touch upon multiple modules because they all are interlinked. Even if you don't have to touch like different modules, if the change that you are making is specific to a single module, then to get the changes to effect, you have to deploy the entire application. Okay, so even if it's a small change, it results in all the components being redeployed. Okay, and if your application is huge enough, the deployment cycle can be longer. So a small change will lead to difficulty depending on the size of the project. The next problem that we have is the lack of scalability. Okay, so with this architecture, we face challenges when it comes to scaling our applications. Okay, so you can't just scale a specific function or a module. So for example, if you have a lot of users signing up, okay, so let's say you are working for a e-commerce application, okay, and let's say you have a lot of users signing up and there is a lot of traffic on the inventory module, okay, because there is a huge sale going on, let's say. So suppose it's Black Friday, okay, so lots of users are signing up and there is lots of traffic on the inventory module, okay. So there are sellers accessing this inventory module, there are like users ordering stuff, so inventory is also moving fast. So inventory module is getting a lot of traffic. Now how do you scale inventory module? Okay, because there is only one module that is being used a lot as compared to the other modules. So there might be different modules, like let's say you have a module which allows users to raise a support ticket. There might be a module which allows users to, let's say, make payments and so on. But like if a specific module is getting a lot of traffic, you can't just scale that module with monolithic architecture. Okay, so in order to scale that module, you have to scale the entire application. Okay, and what I mean by scaling the application, I mean like creating more instances or scaling up the servers and all. Okay, and just scaling up everything for a single module is not at all cost effective or resource efficient. Okay, so this leads us to another problem where we face challenges in the lack of scalability. The next problem that you will have or everybody faces is long-term commitment to a single technology stack. Now what does this mean? Okay, so monolithic applications require you to commit to a single technology stack for a long time. Okay, and this can limit your flexibility to try out new technologies. So technological world, like if you see around, technology changes really fast. Okay, and you absolutely want to make best use of the tools that are coming out in market. Okay, because this particular field of technology is rapidly evolving, and not being able to adapt to these new changes can leave your application lagging behind. For instance, let's say you have used a particular language or a framework for building your monolithic application. And few years later, let's say a more efficient language comes along, okay? And you want to use it, but because your entire application is built with this old framework or old technology, migrating to a new stack will involve rebuilding the entire application and a total overhaul, which is costly, and it will also be resource and time consuming. So you might want to stick to the old stack in that case, okay, because that would be the best decision. And in that case, you are then committed in long term to that particular stack. So that's the third problem. The next problem that developers often face is application complexity and its effect on development and deployment. Okay, so in the beginning, monolithic applications are simple, but as your company grows and as the application scales, the complexity grows. Okay, and complexity makes it harder to understand the entire application. Okay, it slows down the development, it makes the deployment task like a huge task. Okay, so even if you want to deploy a small thing, you have to deploy everything, like redeploy everything. And there are increased chances of bugs, okay, because everything is interlinked. Okay, so this is another problem that typically developers face. Another issue is slowing down of IDEs. Okay, so since the code base grows really large in size with the scale, it can lead to slower performance, and you might need a powerful CPU, like a machine with a powerful CPU or higher RAM. And you might even face challenges in using the IDEs because you are loading a huge code base and you are doing the local development. So this can impact the productivity of your team members, the developers, and also impact the overall speed. So this is often overlooked when it comes to monolithic application, okay? But large code base is not good, okay? Then with large code base and a lot of components, you will also face issues like increased application start time, okay? Because you have a lot of components in your application, and there might be several tasks that might happen at the application start. So you might want to initialize different components. You might want to fetch different dependencies and so on. So even if a small part of the application is being used by the user, you still need to load everything. Okay, and this can lead to slower like application start time. Okay. Then the large project size. Okay, so this is of course related to the large code base. Okay, so large project size makes it challenging to manage and maintain the application. Okay, and then you have like deployment for small changes. So if there is a small change, if you tweak even a small thing, you need to redeploy the entire application. So this is not good. Okay, also team collaboration and autonomy. Okay, so there are multiple teams that are working on different parts of a monolithic application. Like for example, if you have an e-commerce app, you will have a team for like e-commerce store, and you will have team for e-commerce inventory or the seller side and so on. So there are different teams working on different files. Now coordinating the changes, managing dependencies, resolving conflicts, okay, leads to a lot of issues. Okay, and this could lead to a lot of delays. It leads to difficulty in maintaining a smooth development workflow. Okay, so team collaboration and autonomy is a problem. Okay, so that's about different problems and challenges that developers typically face when working with monolithic architecture. Let us start talking about what are microservices and why do we need them. So what are microservices? So microservices structures an application as a collection of small autonomous services. Okay, what does that mean? So in monolithic architecture, you have everything as a single application. But with microservices, you can separate the components into different services. Okay, and they all work together as if they are a single application. Okay, so each service runs a unique process and communicates through a well-defined lightweight mechanism to serve a particular goal. Okay, and goal can be anything. Now, the term microservices is nothing but an architectural style, okay, which is used to structure a particular application in a particular way. Okay, you can compare microservices with the analogy of islands. So there are small islands that are interlinked. Okay, they have their own rules, processes, but they all are part of the same structure. Okay, so in microservices, every service is a self-contained unit that works with other microservices that exist. Okay, and under the hood, they all complete the application. Okay, so let us talk about how microservices work. So microservices work by breaking down the application into small services which form the core function, and each function is deployed and developed as a separate standalone services. Okay, so you can think of this like we have our application job app. So you have three core components, like we have company, job, and review. So you can separate these components. Instead of having a single app that has three components, you can have three different apps with each component in it, and they all have their own copy of database. Okay, so database is also separate. Now the question is, how do these microservices communicate? So they communicate with each other with standard protocols like HTTP or HTTPS. Okay, and the communication is essential because they are functioning as a single application and not the separate one. So this is our job application, but if you think of this from another example like e-commerce application, you can have microservices for handling inventory, for handling user authentication, for handling payments processing, like for handling the seller side of the application, and so on. Okay, so each service that exists is responsible for having its own data, own functionality, and handling their part of the role on their own. Okay, let us talk about some of the principles on which microservices operate. The number one principle is the single responsibility principle, which says that Each microservice should have one single job. For example, if we take an example of e-commerce website, there can be individual services for product, inventory, order processing, and so on. And they all, like every microservice, has a single responsibility. Independence. So, this principle says that each service should be able to operate independently without having any dependency on other service. And a change, or if you are making any change or functionality change or code change in any one service, it should not impact the other service. Okay. Then decentralization. So instead of having the entire application as one body, okay, each service manages its own database, its own code base, and its own data model. So this is decentralization. Failure isolation. So in case of a monolithic architecture, if a particular component fails, the entire application fails. But when a microservice fails, it doesn't take the whole system down. Okay. The rest or the other microservices continue to function as normal, but only one service could be down. So this leads to this principle of failure isolation. Continuous delivery and deployment. So since each microservice is independent and isolated, each microservice can be updated independently, and it gives room for doing more frequent and reliable releases for every microservice. Since the code base is also small, and this gives a lot of autonomy to the developers. So that's about microservices. So let us start talking about how can you overcome the challenges of monolithic architecture with the help of microservices. So microservices addresses a lot of problems that exist in monolithic architecture. Let's talk about each one of them. So the number one problem that microservice solves is scalability. So in microservice architecture, you have multiple services. Each service is separate and can be scaled individually. So you can scale up a service or you can even scale down. This means that if certain parts of your applications are experiencing high demands, for example, you have an e-commerce applications and you are onboarding a lot of sellers. So the seller side of the application has high demand. So you can just scale those services that are in demand to meet or fulfill a demand. Okay. And this is without having you to scale the entire application. So in our example, if seller side of your application is having more demand, you can just upscale the microservices that are providing the functionality for the seller side. You don't have to scale the user side. Okay. So this is one major advantage. Okay. And this gives you a lot of upper hand. So let's say if you are running a Black Friday sale and there is tremendous traffic that's coming on your website. So there will be high traffic on your product listing page. There will be a lot of transactions. So payments need to be scaled. You need to scale up the inventory microservice as well. So this way you can decide, okay, these are 4 microservices that I need to scale up to gear up for this sale. Okay. And you can even monitor those 4 microservices only because you know that the other side of the applications are not going to get that much of traffic because these are the parts that you're marketing actively. So that's scalability for you. Then flexibility. So this architecture, like microservices, provides the flexibility to use different technologies for different services. So since every service or every microservice that exists in your application is independent of each other, you are free to choose which technology to build a particular service on. Okay. So if there is a new technology that comes in and if you want to migrate a couple of microservices to those new technology, you can happily do that. And the rest of your application can stay in the older tech stack. So this is completely autonomous and it gives you a complete control as to which technology stack you should adopt to stay up to date and innovative. Simplicity. So microservices simplify application development and deployment. So what they do is, with microservices, if you have a large complex app, you have to break it down into a smaller and manageable system that are interdependent or that are not dependent from each other. Okay. Now each of these services can be developed, deployed, and managed and even scaled independently. And this reduces the complexity that you have when all the components are interlinked. Okay, and this makes development much more faster. It makes the code base much more simpler, and it allows for continuous development, deployment, and delivery, as the changes are also fast since one service does not have dependency on other service. So this is what simplicity means. So imagine if you have a new developer joining a team. Now, if you have a monolithic architecture, the new developer will be onboarded into a pretty large code base. Okay, so he will have to go through all the files, how different components work together. But imagine in case of microservice, if he has joined the inventory team, he has to just go through the code base for inventory. Now that code base will be much more smaller, okay, and it won't be overwhelming. So as a result, the new developer who has just joined would be quickly onboarded when you are using microservices, and it will be easy for him to understand the application. So that's about microservices. Now let us talk about Netflix. So Netflix is a very popular case study or a real world example of microservices. So this streaming platform was initially built in monolithic architecture, and then later on the company decided that they should use microservices to overcome the scalability issues that they were facing when they were using monolithic architecture. So as Netflix grew, they experienced a significant increase in traffic. Okay, so the web app experienced a lot of traffic, and their monolithic architecture was not 100% able to handle the load, leading to downtime and so on. So this impacted the customer experience and reputations and so on. So they decided internally to transition into microservice architecture, which is why they have broken down the application into hundreds of separate microservices, and each microservice is independent and allowing the internal team to handle the increasing traffic and ensuring high availability. Okay, so this way Netflix has been able to scale and maintain great user experience because of microservices architecture. So you can just Google about Netflix microservices and you will get articles around this case study as to how Netflix adopted this popular architecture. So that's about microservices. I shall see you all soon. Welcome back. So let us start talking about the changes that we are going to do to our application so that we can migrate to the microservices architecture. So this is our application so far, which is being run right now as a monolithic architecture on a single server. So we are going to transition to an architecture that looks something like this. So we have a browser from where we are sending a request to the application, and we are having 3 microservices in our application. So this is the company microservice, the job microservice, and the review microservice. Now each microservice has its own database. So you can see review database, there is a job database, and then you have a database to store the company. And every microservice is also running on its own server. So there are 3 different servers that we are running. So this section is going to be about this transition wherein we refactor our application to start accepting requests from the browser. So company can receive the request from the browser. The job microservice can receive the request as well. And the review microservice can even receive the request. And this here can be browser or can be Postman. So this is what we are going to implement with our application. So how are we going to structure our microservices? So we are going to have 3 applications running on 3 different ports. For example, we have company microservice running on port 8081. We have jobs microservice running on port 8082. And reviews will run on the next port, which is 8083. And these 3 microservices are going to be 3 separate Spring Boot projects. So in order to create separate microservices, you can create separate Spring Boot projects so that you can configure all the dependency that microservice will need. So that is what we are going to do. So we are going to break down a single application which is in monolithic architecture into 3 different parts, and they will be responsible for running as a single application. So for the end user, it will be like they are interacting with a single application, but in the backend, you have 3 different microservices running on 3 different ports. Okay, so that is how we are going to structure. So let us begin creating our first microservice, which is the job microservice. So here I am on our favorite website, which is start.spring.io. And we will have to create the microservice using the Spring Initializer tool. So I'll choose some configurations over here. So I'll say we need a Maven project. This is the version of Spring Boot that we want. Language is Java. I'll specify the group over here. So group ID is com.embarkx. And the artifact can be job ms, like so. And here I can say microservice for job application, like so. I've selected jar and the packaging can be jar, and we are using Java 17. If you want to choose any other version of Java, that's completely okay. You can choose to do so. Now, in terms of dependencies, we will add a few dependencies, like we'll say web. So we will be creating a web application. Then I'll add dependency for JPA. Okay. So I'll say JPA. And let us check our project as to what all dependencies we had. Okay. So we have Spring Boot Starter Web, we have the JPA dependency, we have H2 database, okay, and then we even have the PostgreSQL as well, okay. So let us add PostgreSQL. So I'll head over and here I'll add PostgreSQL. So you can either create the microservice with the H2 database and then later on migrate to PostgreSQL. So I'll do that. I'll later on switch to PostgreSQL and I'll have H2 database here. Okay. So our configuration is done. Let us generate the project. Okay. And you can even go to explore and check whether everything is added. So this is what we need. So what I would request you all is to download this project and come back and open the project with Intellij. So I have downloaded the zip file here and I have extracted the zip file here. Okay. Now what I can do is I will switch over to Intellij. I'll go to File, Open, and I can open the project. So I can select Job Microservice like so. I'll say OK. And you can open this in a new window. Okay. So I'll say a new window and it opens up like so. So we have another instance of Intellij running and you have the job microservices appear over here. Okay. So it will do some indexing and our project setup is done. Okay. So this is our microservice that has been created. Okay, we have successfully created a separate application. Okay, and we will be working on this further. So I have the job microservices project open in a separate instance of Intellij. Okay, so I have this one open here and the monolithic application open here. So I have moved this to a separate desktop. Okay, now what we are going to do is we are going to move all our code in the form, like all the code that relates to job will come into job microservice. So what we are going to do is all the code that relates to job application will move to job microservice. So I'm going to create a package here. I'm going to call this package as job. Okay. And I'll head over to my application here and I'll open the Java folder. Now, whatever Java job related files I have, I'll just copy this entire package. Okay. So I can delete this one, in fact, because I'm copying the entire package itself, and I'll paste everything over here. So you can see we have all of this being added here. Okay, so we have copied all the files. Now, when we copy all the files, let's see what all errors we get here. So the number one error that we are getting here is company. So company does not exist. Okay, so every job has a company entity over here, and it is a many-to-one relationship. Okay, so we will have to refactor this because we can no longer access the company. Okay, what I'm going to do is I'm going to remove the many-to-one mapping, and instead of company, I'm going to have long, and I'm going to store the company ID like so. So let me make the view bigger, and so we don't have anything in the constructor, but here we have getters and setters. So I'm going to remove these getters and setters. Do we have anything else? No. So I'll just add the getters and setters for this new field that we have generated. So I'll say getters and setters, company ID, long, like so. Okay. Now I can also optimize the imports. So here we don't need the company. Okay. So I'll remove this import statement here. Okay. So this is job. Now let us take a look at the job service. Now here everything looks fine according to me. So we have this find all, then we have create a job, then get job by ID, delete job by ID, and update the job, which is okay. Let me also open up the service implementation. So here, of course, we are getting some errors now. So let us take a look. So the error is because the package has changed. So I'll have to re-import all of this. Okay, so I'll say job service. Here I'll say job repository. And here I'll say job. Okay. So I've imported everything and rest all looks superb. So there are no changes to be made here as well. Now let us head over to controller. So here in controller, let us see if there are any red marks. So I don't find any red marks over here. Okay. And I believe the controller also looks good. Okay. Now what we can do is let us head over to application.properties, and here we will have to set up some configuration. Okay. So I'll have to say server.port. So we need to run this particular service on 8082. So I'll mention that as the port. Okay. I'll also have to say, like, I have to configure the H2 database. Okay. So I'll say Spring data source dot service URL dot default. Oh, sorry. Data source dot URL. Okay. And I can copy the URL from here itself. So here in application.properties, we had this configuration. Okay. So I can just get all of this configuration. Okay. And save a little bit of typing. So I can paste it over here like so. Okay. And let me uncomment this. So this looks good. We'll keep the database URL also same. If you want, you can change it. Okay, that's perfectly fine. But since it's an in-memory database, we can keep the URL same. And rest all looks good for me. Okay. Now what we can do is we can run our application. So I'll say run. So I'll go to this job ms application file and I'll run this. Let us see the logs. So we are able to run the application. Okay. And the application has started. Now let us switch over to Postman and let us check. So here in Postman, what I'm going to do is I am going to create a new, and let me tell, a collection. So I'll create a collection here and I'll call this collection as job ms. Okay. So this is job microservice and I'll duplicate a few URLs. Okay. So first of all, I'll close all the tabs. Okay. And I'll save all the changes. Okay. And I'll get everything closed. Now I can duplicate like the post request here. Okay, I'll duplicate this one and I'll move this one to this microservice folder, and then I can get all the jobs. So I'll duplicate this one and I'll move this to microservice folder, and so all the URLs that are related to jobs I'll duplicate and I'll keep them separate. Okay. So instead of doing this, you can even make use of environmental variables. Okay. In Postman. So here I have this done. Now I'll replace the port numbers. So I'll say 8081/jobs and I'll say 8081/jobs like so. Okay. Now here I'll say, so this will also be 8081 and I'll copy this and this will also be /jobs. Now same goes for all the URLs. Okay. So we need to modify these URLs so that like we have a clear distinguish between what is microservice and what is not actually. So I'm just doing this. So we are done. Okay. Now what I can do is I can run this to fetch all the jobs and we get an error. Okay. So this does not work. Let us check what happened here. Okay. So the application is running, let me see, 8082. Oh, sorry. So this is on 8082 and we are trying to access on 8081. So we have entered the wrong port number. So this needs to be 8082. So jobs is on 8082. So I'll just change the port number everywhere. So after doing all the changes, okay, just make sure you save all of them. And now let's try to access the API to get all the jobs. So here you can see you are getting no response. Okay. Let me create a job. So I'll post a job and this is the job body that I'm trying to post. Okay. Of course, the company does not exist. Let us see what happens. So you will see job added successfully. Okay. It's 201 created. Now, if we try to get the jobs, you'll see the company ID is null. Okay, so we have added company ID and that is null. So how do we add company ID here now? So I'll say company ID. Okay, and since it's no longer an object here, so I'll change the request to that of this. Okay, and I believe this should work. Now let me add one more company or one more job. Okay, and let me track the output. So you will see company ID appear now as 2. So this is the request and this is how you're supposed to send the request to create a job. Okay, now we are maintaining the relationship here with the company. Okay, so the company ID is 2. Now if you try to get a single job, okay, this API should work fine. So if you say job with ID 2, it will give you the job with ID 2, which works fine. And you can even delete the jobs. So this job with ID 1 is deleted now. And if you try to get all the jobs, you have only one job now. So the one with ID 1 is deleted. So yeah, we are done refactoring our application and we have moved the code to the microservice structure. Okay, so here now this particular job application is independent of like all the other dependencies and it is running as a standalone service. Welcome back. So this time we will move on to create the company service. Okay, and we are already on our favorite website, which is Spring Initializer, which is at start.spring.io. So we are going to define some configuration for our company service here. Okay, so I have some configuration already set over here. So I'll select Maven, Java is selected, and the latest version of Spring Boot is also selected. So this is something that I'll make sure. Then I'll keep the group same like com.embarkx, and instead of artifact I'll say company. So I'll say company ms, and here in the description microservice for company application, and the package name is auto generated. I'll make sure that jar is selected with Java version 17, and I'll also have these three dependencies added. So we'll have Spring Web, Spring Data JPA, and the H2 database. Okay, and I can explore if I want to, like I can check the dependencies, how are they being added, or I can download the entire project structure. So what I would suggest is download the entire project structure and let's get ready to import this application into Intellij. So I have downloaded this project here, which is company microservice. I will get this extracted over here. So I'll say extract here. So we have this folder here. Now what I will do is I will head over to Intellij IDEA. Okay. And I'll say file, open. And here I'll collapse job ms and I'll switch over to company ms. So I'll select this company ms over here, which is company microservice, and I'll say okay. Now when I'm being prompted like where would you like to open the project, I'll say open in new window. So you can open it in this window as well, but the thing will be the job microservice will go down. So this instance of Intellij will shut down. It will close the job service project and then open company microservice. So you can do that, or else I'll choose new window. So I have new window. Now I'll move this window to a new desktop so that it's easy to work around with. Okay, so I did a full screen to company microservice, and here we have the entire project structure. Okay, we have all the dependencies that we added on Spring Starter website. Okay, now what we need to do is we need to head over to the main folder over here, and we need to go to the monolithic application we have over here. So we need to copy the company folder. So I'll copy the company folder that we have, and I'll paste this company folder here in this package. I'll say okay. So I have the company files coming up over here. Okay. Now let us go through each file one by one. Now in the company entity, we have a mapping for jobs and we have a relationship for reviews. Okay. We can keep this relationship by storing the IDs. Okay. So we can have IDs over here like private long job ID and private long reviews, something like that. Or long won't work. We will have to store the list of values because it is many to one, like one to many. I'm sorry. So what I will do is I will remove this. Okay. And I will even remove this from here. Okay. And I'll delete this from here. Okay. So this is done. Okay. So I'll hit save. And I'll fix the imports over here. Okay. So imports are fixed. Now I can go to controller over here, and in controller I'll check for anything. So there is nothing that requires my attention. Let's go to service. So in service also, I believe it looks good for everything, and I can go to implementation class. So let us take a look over here. So this has a few errors, okay, and the reason is because the package has changed, so this should be removed, and I need to re-import everything. So I'll say company service here. Here I'll say company repository, and here I'll say company. So I believe the error have gone, and I need to remove this line here wherein we are setting the jobs, because this setter method does not exist. So yeah, it's all clean now, and I'll hit save, and company controller is working fine as discussed. Okay, so it's all good. Now let us configure some details like properties. Okay, we need some properties that we need to add over here. So here I can say server dot port is equal to 8081, because we want this microservice to run on 8081. Okay, now let me check the configuration for this particular microservice. So this is a job microservice. I'll copy the configuration for H2 database. Okay, and I'll add the configuration over here. Okay, now what we can do is we can run this microservice. So I'll go to company MS application, and I'll run this particular microservice. So let us wait to see this running. So it has started the application. Now we'll head over to Postman, and let us try querying the microservice. Okay, so what I'm going to do is I'm going to expand this a bit so that I can see. Okay, so let me close all the tabs. I'm going to save everything and close. Now here I'll duplicate this request. Okay, and I'll also create a collection here. So let me create a collection. So this is a new collection. I'll say company MS, which looks good. Okay, and I'll expand this. Let us move this over here. Okay, so this is moved, and then we have the put request for company, which I'll duplicate. Then we have the get request for all the companies, which I'll duplicate. And then we have a way to get a particular company, which I'll duplicate again, and a way to delete a company. Okay, now you can select all of this. Okay, so I'll select all by pressing Control on my system, and I'll move all of this to company MS like so. Now let us change the port numbers. Okay, so I can say 8081 here. Okay, and we'll update the port for every request that we have. So this is 8081. This will be 8081 as well. Okay, this will be 8081 too. And this one will be a new port as well. So here, since our microservice is running on a new port, we need to make sure that the ports are correct. So we are done with the changes now, and let us start testing. So let us first get all the companies. So I'll get the list of companies. You are getting an empty array list, which is fine. Now let us try creating a company. So here I have a company that is being created. So I'll say company 1. It's created, and I can get the company again now. So you will have this company that exists. You can get a particular company. So I'll say give me the company with ID 1, which works well. Company with ID 2, which says not found. And you can even delete the company. So this will also work fine. Okay, so all the endpoints are working well with this microservice. Okay, so I hope you have been able to follow this refactoring part, and you are able to access all the company URLs. Okay, the URLs that point to the company microservice. So one mistake here that I can see, this would be 8081 and not 8082. Okay, So this is how it should be. And now if I run this, it will be deleting the company. And if I try to get this should work. So yeah, so we are done refactoring the company microservice. Let us begin creating the review service, and we will head over to Spring Initializer. Make sure Maven is selected, Java, and the latest version of Spring Boot. And here I'm going to say review MS, and I'll rename this to review. So rest all the configurations remain the same, like company and job microservice. So we need to make sure packaging is jar and Java 17 is selected, and we need to have these dependencies added. Okay, now I'll hit generate and I'll download the zip file. So I have downloaded the review microservice zip file. Now I'll extract this file over here, and you will see this folder appear, review MS. Okay, so this is our source code. And now what we need to do is we need to head over to Intellij, and I'll say file, open, and we will open the review microservice. So I'll collapse all of this and I'll select review MS. I'll say OK, and I'll open this in a new window. So here we go. We have the project up and ready for review microservice, and we will start refactoring the code here. So right now I have the review microservice open in Intellij, and this is a new window of Intellij IDEA. So what we can do is we can go through the structure over here. Like you can check all the dependencies that we have added. And here under main Java, I'm going to add all the source code that we need for this microservice to function properly. So I'm going to head over to our monolithic application here. I have it open. And here I will copy the review folder or the review package. And I'll go to my microservices application and I'll right click and I'll say paste. So I've added all the code that existed in my monolithic application, and we will start going by each file one by one. So let's take a look at the review file. Now over here we have a many-to-one mapping wherein we are mapping company object over here. So instead of having the company object, we don't have company object in this particular microservice. So what we will do is we will say private long and company ID, like so. And I will scroll down here. I will remove these getters and setters, like so. And I will generate the getters and setters, like so. Okay. So this is done. We need to clear some imports as well. So the imports are optimized as well. Okay. So the review class is done. Now let us take a look at the review service. So this looks good. And if we take a look at the implementation, this will have some issues. So I'll remove all these import statements. These issues are just because we have changed the package name. Okay, you can even refactor the package. So if I say review MS over here, and if I remove this part, okay, so if I copy this, so company service does not exist. So we will get rid of this. Okay, now here I'll say review MS, and review MS. So this should work perfectly fine. Okay. Now over here, we have this dependency added for company service, which we will have to get rid of, since microservices should be standalone and they should not be dependent on anything. Okay. So I'll remove it from the constructor as well, like so, and I'll get this deleted as well. Okay. Now let us scroll down and let us evaluate the dependencies that we have. So here we say long company ID. Okay, so we are getting the company ID, and here we are getting the company object. So instead of getting the company object, we will have to say review.setCompanyID. Okay, so I'll have to delete this. Okay, and I'll have to remove this if condition as well. Okay, so here I'll have to say review.setCompanyID. Okay, and I'll have to pass in the company ID over here. Okay, so you can add a validation to check if the company ID is null or something like that. Okay, so I've kept this validation here. All right, so this will check if company ID is not equal to null. Okay, and we will add one more validation where we'll check and review is also not equal to null, like so. I'll scroll down here. So get review looks perfectly fine. There is no need to change this. So get review gives us the list of reviews that we have. Okay. Okay. So here I believe we are filtering by the company ID. Okay. So this should work fine. Now, if we scroll down to update review, okay, here we are making use of the company service object. So here I can just check if the company ID is not equal to null. Okay. So in fact, we don't need the company ID over here. So I'll get rid of this. We just need review ID and the updated review. Okay. So here I can say if review ID is not equal to null, then what we will do is we'll say updated review. So here I'll create a review object. So we need the review object to exist. So I'll say review updated review. So review is equal to repository. So I'll get the repository dot find by ID, and I'll pass the review ID over here. Okay. So we are getting the review by ID here. Okay. And this is saying that it has to be optional. So I'll say or else null. Now we can validate against this. Okay. So if the review is not found, okay, then we can say, so I'll get rid of this. Okay. So I'll say review dot set, and I'll set all the fields. So I'll say set title. So updated review dot get title. I'll duplicate this review dot set description, and I'll get description here. I'll duplicate this again, review dot set rating. I'll get the rating here. Okay, and we can set the company ID as well. So rating, title, description are done. We can set the company ID as well. Okay, and we will save the updated review over here. So I'll save the review over here, like so. Now I'm getting on an error on this like override annotation over here. So I'll go over here, and here I need to get rid of the company ID. In fact, we'll have to get rid of company ID from all. Okay, and the reason is we don't want any dependency over here. So let's see if we can do a lot of things without getting the company ID. Okay, so we had company ID for validation. Okay, but we don't have the company entity over here. So we don't need, so we can remove it from a lot of places. So from here also I'll get rid of this. Okay, and here I am going to say review is equal to get review by ID, or I can say repository dot find by ID, and I can pass the review ID over here. Okay, and since this is optional, I'll have to say or else null. Now I can say if, so I'll remove this. If review is not equal to null, okay, then what are we doing? So I'll just get rid of all of this, and I'll say review repository dot delete. Okay, I can say, you can even pass the review directly, or you can delete by ID. Okay, so I can delete by object itself. So I'll delete this and I'll return true, or else I'll return false over here. Now since we made a change over here, so I'll go to review service and I'll get rid of this over here. Okay. Now we have company ID in get review and add review. Okay. So let us go to get review. Okay. So here we are getting the review by ID, and I don't think we need company ID over here. Okay. Now why are we getting rid of company ID over here? Because it's a separate microservice now. Okay. And we don't want any dependency on the company ID. If you want to get a particular review, you can directly pass in the review ID. Okay. So here find by ID, I'll say. Okay. So here instead of reviews, I'll just get rid of all of this. Okay. So you can say return review repository like so dot, and I can say find by ID here, and I'll pass the review ID. Okay. Dot, I'll say, or else. Okay. So this returns an optional. So I'll cut this and I'll say review is equal to, or I'll say over here, or else null, like so. So if we don't get the review, we are passing in null. Okay. And here in review service, I'll get rid of this thing over here. Okay. Even for adding review, let us see if we need the company ID. So for adding review, I believe we need the company ID. And that is because we will be saving the company ID over here. Okay, so we're checking if the company ID is null or not, and then we are setting the company ID, which is okay. So this is done. Now let us take a look at the controller. So here in the controller, if you take a look at the URLs, these URLs are dependent, or so they talk about the companies over here. Okay, but this is a separate microservice, right? So let me switch over to PowerPoint slides and let me explain this better. So these are the URLs that we had in our monolithic architecture, using which we define the URLs for the review entity. Okay, and as you can see in our current design, we have reviews nested under companies. Okay, and this implies that review service needs to know about company service. But in microservice, this is not the right approach. So in microservices, you need to be able to operate reviews independent of the companies. And that is why we need to restructure these URLs. So the new URLs can look something like this. So these are the new URLs. And as you can see, like here, we were accepting the company ID as the URL parameters. But here we are taking it in a different format. So here this was being presented to us as the path parameter. Okay, like within the URL path we had company ID, but here we are taking it as the query parameter. Okay, and this is a difference, and this allows us to change the URL. So it allows us to define the URLs starting from reviews, /reviews. So whenever you are saying /reviews, it means you are accessing the review microservice. Okay, so this would be the right approach. And you can see over here, post, we have passed the company ID over here. So here, instead of path, like having the parameter in the path, we are passing it here in the form of query parameters. Okay, and whenever we need review ID, we are passing that as a part of the path. Okay, so that is not going as the query parameter. So let us do this restructuring. And the reason for this restructuring is because our microservices are loosely coupled. They have their own domain of responsibility and they need to know less about each other. Okay, so they need to be independent. So we are moving towards independence here. Okay, so I'll switch over to my ID. Okay, and here in the controller, we will have some definition. So this would change to /reviews. So I'll say reviews. Okay, here. Let us take a look at, so this thing is okay. Now let us take a look at individual mappings. So you have /reviews. So here /reviews is not needed actually, because we have a REST controller mapping at the top, or request mapping annotation at the top. Okay, not the REST controller, I meant request mapping. So we have this, and this one should work perfectly fine. We don't need any changes here. And we are adding a path variable here. So this is not a path variable now. So this is now a request parameter. Okay, so request parameter, and we'll call it company ID, like so. Okay, now over here, this is the post request, like the post mapping. Okay, so we don't need to specify this. Okay, we can skip this because we have the parent request mapping there. And here we were accepting this as the path variable. Okay, so company ID was coming in as path variable. So I'll change this to request parameter. Okay, so request parameter means it is coming in this format now, like after the question mark. Okay, and path variable was like this. All right, so we just need to restructure that. Okay, so I'll restructure this, and request body is review. Okay, now what we are doing is, when adding review, we are checking if the review is saved, we are giving the response, and if not saved, we are returning an error. Okay, so this is the method or the mapping that enables us to get a particular review. Okay, so here I'm going to say, so this will be /reviews, and this can go, so this is defined over here at the top. So I'll say /review ID, and here we'll say get review. Okay, and here we don't need the company ID. Okay, so because we have changed the method here in the service, so if you go to this method, we have removed the company ID. Okay, so if you come to controller, we'll get rid of the company ID, and we can get rid of this entire path variable. Okay, like so. Okay, so this is sorted. Now if you scroll down, we have this put mapping, so we can get rid of this. Okay, and this will be the put mapping. Now here we have path variable company ID. Okay, so path variable company ID is not needed. Okay, we can get rid of this here, because if you take a look at the update review, so here we don't need the company ID now. Okay, so here I'm going to like just remove that variable, and I'll get rid of this part as well. Okay, so this is sorted now. Okay, we have the path variable for review ID, and the request body is review. Now if we scroll down over here for delete mapping, so here I am going to like remove this part. Okay, because this is a part of request mapping now with the controller, and here we are accepting the company ID again. Okay, which is actually not needed, and we have already modified this method. We have removed the company ID, so we can get rid of this. Okay, so our microservice is sorted now, and it's it's independent of company. Now let us run this and let us test our changes. Okay, so I will run this. Okay, let us see if this runs without any issues. Okay, so we missed something. So it's trying to run on 8080, and the thing we missed is the configuration of application.properties. Okay, so I'll switch over to company microservice, and here I'm going to copy the application.properties that we have set up. Okay, now in review microservice, I'll paste this application.properties. Okay, and I'm going to make the modifications in this particular file. Okay, so I'm going to change the port, which is 8083. Okay, and rest of the configurations remain the same. Now let us run this. So let us see if we are able to successfully run this particular application. So this works perfectly fine. Okay, now let us switch over to Postman. So here in Postman, first I'll create a collection, a new collection. I'll call it review MS. Okay, and I'll close all the tabs. Okay, I want some less noise. Okay, So here now we have changed a lot. Okay. So what I'm going to do is I'm going to expand this a bit and I'll duplicate everything. So I'll start selecting all the URLs that we have used to work with reviews. Okay. So these are all the URLs. I'm going to say right click, duplicate. Okay. We duplicated them. Now I'll copy all of them. So I'll select all of them. Okay. And I will move them. Okay. So I'll move them to the new collection that I have created. Okay. Here. All right. Now we are done. Now let us work on each of the URLs. Okay. So this is the URL that enables us to get the list of reviews. Okay. So this gives us the list of reviews against a particular company. Okay. But now this will change to getting the reviews. So let me head over to the controller and let us see what all we are accepting. So I'll close this and I'll close this. Yeah. So here if you scroll down, so if you are getting the review, so this is a delete mapping, get mapping, post mapping and get mapping. So this is getting all the reviews and we are passing the company ID. Okay. So now if you go to the implementation over here, okay, here, so we are getting the reviews by company. Okay. So this is going to change. And here, what we are going to have is it will first point to 8083 like so. Now, after changing the port, I'm going to restructure this URL. So I'm going to say reviews like so. And I'm going to say question mark company ID. So I'm going to say company ID and I will be caps. So just make sure you don't make any typos and I'll pass in 1 over here. So the moment you add this thing over here, you will see that this particular part is automatically filled in. So this is the query parameters. Okay. So you can actually remove query parameters from here and you can even come here and you can add the parameters or you can directly type in like I did over here. Okay. So if you want to save with some typing effort and want to avoid some syntax errors, you can make use of this interface over here. Okay. And we have passed in 1 over here. Let me say send. We will get empty array list, which is perfectly fine because right now no reviews exist. So I'll just copy this URL and I'll give this as the URL name over here. Okay. I'll hit save. Now let us try creating a review. Okay. So we are going to add a review into the system. So here I'm going to again say reviews like so. Okay. Now this is a review against which company. So I'll pass in the query parameters this way. So I'll say company ID. Let us add it against the company 1. Okay. And here in the post request, I'll change this to 8083. And let us check the body. So body is also perfectly fine. Okay. Now let us see by triggering this request. So you can see review added successfully. Let me copy the URL and let me replace it over here. Okay. Now let us try getting the reviews. So I'll go to the previous tab and I'll get the review, like all the reviews for company ID 1. You can see this works perfectly fine, right? So this is done. Now let us try getting a particular review. Okay. So what I'm going to do is I'm going to head over to this request URL. I'll first rename the port. And I'm going to say reviews/1. Okay. And let us trigger this request. So this works perfectly fine. Okay. And the reason it's working fine is if you go to controller to get a review, like to get a particular review, this is the mapping that you have. And this is what you define here. Okay. So it works perfectly fine. Now let us try updating a review. Okay. So I'll say 8083. Okay. I'll say reviews. Okay. And reviews/1. So let us try updating this review and I'm going to pass these parameters. Okay. So in the body over here, we will also need to specify the company ID. Okay, so I can say company ID and I'll say 1. I'll keep this as 1 itself and I'll send the request. You can see review updated successfully. Now if you try to get the review, so let me get the review. You'll see we have the updated review right now. Okay, and the put request works fine. So I'll update the name over here. I'll hit save. Okay, for this one also I'll update the name and I'll hit save. Now let us test the delete one. So I can say 8083 reviews /1. Okay, and if I run this, so this deleted the review. Okay, and if you try getting the review now, you don't have any reviews. Okay, so everything is working perfectly fine. I'll just update the name here. Okay, so we have successfully refactored our review microservice to work in the microservices architecture without any dependency. Now here in this refactoring, we made use of path variables. So here we made use of path variables. So this is a path variable. And here we use the query parameters. So you can see the query parameters. Okay, so both were used, and query parameters is something we use for the first time. So why are query parameters being used and what are they? So query parameters are optional parameters in a URL, okay, that modify the behavior of the request. So if you take a look at a website, you will notice the pagination functionality. Okay, so let me show this to you. So if you go to Google, okay, and let me go to google.com and let me search for, let's say, Oracle Java. So I say Oracle Java, I get some results. Now if I scroll down and if I go to second page, okay, you will see some query parameters over here. Okay, you can see this is the search result. Like this is a search query. Okay, you have start equal to 10. So start equal to 10 means I'm starting from the 10th result, which means I'm on page 2. Okay, so it has all the information about this particular request. So if I change this to 1 and if I say enter, okay, it didn't work. So start is equal to 1. So if I change this to 0 over here, start equal to 0 and ed, like VED is equal to 0. And if I hit enter, you will be returning to first page. Okay, so this is the first page now. So these are query parameters on the basis of which Google works and gives you the search results. Okay, now when do you use path variables? So here you saw we were also using path variables. So when you pass a parameter in the path itself, okay, it talks about the hierarchy. Okay, that is used to signify hierarchy over here. Okay, so within reviews, you give me the one with ID 1. But here, since company ID is not the part of this microservice, we have accepted it as a query parameter. Okay, so that is why we changed this structure like this. Okay, so this will be like the design decisions that you will face when you are designing your APIs. Okay, you can't have an API in review microservice that starts with company, because company does not exist in this particular entity. Okay, so that's the structure change what we did. All right, now this is how we have been able to refactor our microservice. So I hope you all have a good idea as to what we did and why we did, and I hope you all have been able to follow along. Okay, so that's about this class. I shall see you all soon. Thank you. So now we have our microservices set up. So if you take a look at the project, okay, I have 4 instances of Intellij IDEA running. Okay, so here I have one instance. Okay, and this is the job microservice. Then I have another instance which is the company microservice, and this is up and running. And then I have review microservice instance which is up and running. Okay, so you can either work this way or you can combine all 3 projects into a single view. Okay, and let me show you how you can do that. Okay, So what I'm going to do is I'm going to stop review. I'm going to close this project review. I'm going to also close the company MS, and I'll close this. Now within job microservice, okay, you have job microservice here. Okay, so I'll just close all of this. Okay, now what you can do is you can click over here on Maven. Okay, so this is the Maven icon that you will have to the right hand side. And what you can do is you can add the other two microservices as Maven project. So let me show you what happens when you add. So I'll say add Maven projects. I'll go to company microservice. Okay, and I'll say okay. Now the moment I do this, the company microservice project will come up over here. Okay, you can see over here. You can even add the review microservice. The moment you do that, it will come up over here. So with this, what we are doing is we have a single view for all three microservices. Okay, so let me close all the tabs. Okay, these are our microservices. All right, and you have a single view. So let me show you. If you go to services over here, so this is the services icon over here. Okay, let me open this services. So here I am seeing the services related to Docker. So I'll just collapse this. So by clicking on this icon here, and you can click on add a service. Okay, so I'll say run configuration type. Okay, I'll select application, and you can see the application job microservice application has come up over here. Okay, so this is added. So you can either run the application by right click and stop, rerun, and you can do all the operations from here itself, or you can go to the microservice. So I can open job microservice, src, main, Java, and I can even run it from here. This is perfectly fine. So there are no issues as such by clicking on this red icon. Okay. Now let us do this for both the other microservice. So I'll go over here, main, Java, and I can open this company microservice, and I'll run this. The moment I run this, you will see this service appear over here. Okay. And you can see both of them are running now in a single pane. So here you have company microservice, you have job microservice. And if you click on job microservice, you will see the logs for job microservice. If you click on company microservice, you will see the logs for company microservice. Okay. Now let us start the review microservice. So here I'll go to src, main, Java, review microservice, and I'll run this. And you will see review microservice also appear over here under the service tab. Now from here, you can manage all three microservices. So you can select and stop a particular microservice. If you have made any change, you can select and rerun from here. You can click on this icon here. Okay. So all of these things are possible. Now, if I want to stop, I can stop at one go. Like I can stop all of them, or I can click on the top icon over here at the top. If you click on this, it will ask you which service you want to stop. If I want to stop all three, I can say stop all three. But right now what has happened is we have got a unified view and a single view for all the microservices, where we'll be able to make changes in the single view. Okay, so we don't need to switch different windows. So you can follow either of the approach. Okay, you can either have different IDE windows for different microservices, or you can like configure it this way like I'm doing. So it's all up to your preference and how you prefer or how you want to structure your project. So this is about this class. I just wanted to show you how you can get this unified view, and you can also test all three microservices. They all are running together at one go. So you can see here company microservice 8081, job microservice 8082, and review microservice 8083. So 8080 port is left. If you want, you can run the monolithic app that we created on 8080. So it's the default port for that application. All right. So this is done, and we have a better view for microservices. So let us now configure our microservices to work with the PostgreSQL. Okay. So right now, if you head over to the browser, okay. So let me open the browser and let me go to localhost :8080 and let me say h2-console. So you have different versions of, so on 8081 you have, so one second, I'll copy this, I'll go inside. So this is the H2 schema or the H2 database interface for the company microservice. You can open the similar one for, I can say 8082, and you can log in there, and this is for job. Okay, you can see all job related information here and the schema here. And this one 8083, so this is the one that we have defined for reviews. Okay, so there are 3 H2 consoles that exist. Okay, now what we need to do is we need to get these changes migrated to PostgreSQL. So what I'm going to do is I'm going to first make some configuration changes in our application. Okay, and I'm going to close all the tabs. I'm going to switch over to application.properties file for all my microservices. So this is for company. Okay, so let me do it one by one. Okay, so I'll first comment this. Okay, so I've commented this part. Now we'll switch over to our monolithic application, and we have already defined the PostgreSQL configuration. So I'll add that here. Okay, and here instead of job app, I'll say job. So this is the database that I will use. Okay, also one more thing we need to add is we need to add the dependency. Okay, so for dependency you can switch over to start.spring.io. over here you can say PostgreSQL explore. Okay, so this is the build.gradle. I'll select Maven and you'll get the pom.xml generated. So if you scroll down here, you have this dependency. So I'll copy this and I'll add this to my company microservice. So if I scroll down here, I can add it anywhere over here. Okay, now I'll reload these Maven changes. Okay, also I'll have to restart the company microservice. Okay, so I'll be doing that shortly. Okay, so I believe the changes are done. Let us check if PostgreSQL container is running, because if we are trying to create the database connection, if we restart this microservice, what will happen is we are trying to create this database connection. So the PostgreSQL instance should be up and running. So let us check that. So here in PowerShell, I'm going to say docker ps, and you can see the Postgres container is up and running. Okay, and you can access it from 5050. So we need to access it via pgadmin. So I'll have to go to localhost 5050. So I'll go over here in the browser and I'll say localhost :5050. Okay, and this loads the pgadmin browser. Okay, now I'll select the Postgres container which we had created. Okay, and what I will do is I will create a new database over here and I'll call this database as job. So that is a database that we just defined in the microservice, because this is where we will connect. And right now here we don't have any schemas. Okay, so here if you see, you don't have any table over here, not schemas. So we have schemas, and under schemas we don't have any table. So if I go back to my project here, okay, so I did a small mistake. So in the company microservice, I have added the job database. So I have to say company over here. Okay, and since we are in company microservice, I need to create a database with company, not job. Okay. So I'll create a database with company name, and this is empty. So don't worry about the job database that we created, because we'll anyways use it when we configure the job microservice. So that's fine. So we have the tables empty over here. Now what I can do is, let me rerun this microservice. So I'll go over here. I'll select company microservice. I'll select rerun. So this will restart my microservice over here. Okay. And you can see it's started. Okay. Now, if you switch over here and if you refresh, you have this table here. So this is working perfectly fine, and we have migrated the company microservice to that of PostgreSQL. Now let us do the same for job as well. Okay. So I'll collapse the company microservice. I'll open job, src, and I'll go to main, resources, application.properties. Okay. Now within this properties file, I will add the configuration that we have added for company. Okay. So I'll add it over here like so. Okay. And we will have to comment these part. Okay. So I'll just create some room here and I'll comment this. And instead of company here, since we are in job, I'll say job over here. I'll keep the rest of the details same. Okay. And this is a pom.xml for company. So we need to open the pom.xml for that of job. Now what do we need to do? Yes, we need to add the dependency. So I'll add the dependency here, reload the Maven changes, and I'll rerun the service. Okay. So I'll go to job microservice, I'll rerun. So the application reruns and it's running now. Now, if you go to job database, so here, everything was empty earlier. Okay. It was empty. Now, if I hit refresh, you will have the job table appear, which means it's working perfectly fine. Okay. Now let us create a database for review. So I'll say create a database, review, save. Okay. Now let's connect the review microservice to our database. So I'll copy the dependency and I'll head over, I'll collapse this. I'll head over to review microservice and I'll add the dependency here. Done. I'll reload the Maven changes. So I'll have to open the application.properties file here. I'll comment all of this and I need to copy the configuration from here. So I'll get all of this configuration into this application.properties and I'll change the database name here. So we are done. Now let me rerun the review microservice as well. So I'll rerun. So the application has started, as you can see. Now let us refresh. So if you go to schemas and if you go under tables, you will see the review table appear over here. Okay. So which means that we have successfully connected all three microservices to three different databases. So these are three different databases in PostgreSQL. As you can see, this is running in a Docker container. Okay. And you have three microservices connect to it. Okay. So we have successfully completed the migration from H2 database to that of PostgreSQL. Hello everybody, welcome back. So what we have done is we have configured all the three projects that we have, like the company microservice, job microservice, and the review microservice to point to PostgreSQL. Now what is happening is here in the monolithic application that I have. So in this particular application, here I have a docker compose.yaml file. All right. And I am managing the containers from here. So what we can do is we can even move this file into any one of our microservice. So I'll just copy this, okay, and I'll switch over to our ID, and I can choose any of the microservices. So I'll go over here, and here I can say give me a file, and I can say docker compose.yaml, like so. And here I'll paste the exact same settings that I had in my monolithic application. So you can go through the settings again if you wish to, okay? But what I want to do really over here is I want to manage my Docker containers from my microservices. So you can add this file anywhere, like wherever you wish to. Ideally, this should be in the root of the project, okay? So since you have company microservice, job microservice, and review microservice, so this can be ideally in the Spring Boot project, like Spring Boot folder over here. So you can see courses/Spring Boot, but we are not seeing that directory in Intellij, and I wish to manage this right from within the Intellij. So what I've done is I've taken any microservice and I have created a Docker Compose file over there. All right. So you can see this appear over here. And now what we can do is I will turn down the Docker containers that I had started from my job application, like the monolithic application. So I'll switch over to Windows PowerShell. And here I am in my monolithic application. So I'm going to say Docker compose down. So this is the command to turn down the Docker containers defined within the Docker compose file. So you can turn them up by saying Docker compose up, but if you say Docker compose down, like it will just take everything down and it will remove the containers. Okay, so this is done. Now what I can do is I can migrate to one directory up, and I can say company microservice, and you can see I have the Docker compose YAML file. So I'll just clear the screen. I'll say Docker compose and I'll say up. So this is again going to create the containers for me. Okay. So you will see the containers appear over here. So you can see the container was up and running. Now what you can do is you can head over to the browser. Here in the browser, we will access pgadmin. And you will be asked to enter a password. So I'll enter a password and we will add a server here. So I'll again say Postgres container. Okay. And in connection, I'll enter the connection name. So I'll say Postgres, username is embarkx, and I'll add the password as also embarkx, and I'll hit save. So we are connected to the Postgres SQL container. Okay. Now what we can do is here, if you see, we have some database requirements. So we need databases like review, company, and job. So I'll go ahead and I'll create all the three databases. So I'll say review, save. I'll say company, I'll hit save, and I'll even create a database for job. I'll hit save. So we have everything set up now. Okay. So this was a bit of repetitive thing because earlier what we had done is we had created the PostgreSQL databases in that of the instance that was created from the Docker YAML file, and this Docker YAML file was from the monolithic application. So I just moved things here. Okay. Now you could have directly run this. So you could have directly gone, and instead of saying Docker compose down in the monolithic application, you could have directly run it from here. But the thing is, you would have got a conflict. Okay. You would have got a container name conflict. Okay. We could have managed this. So we are all set now. Okay. This was a little bit repetitive because what we had to do is we moved the Docker compose file. So this was a bit repetitive, but now we are all set to work and all set to test our application. So now what we can do is we can start all our services and we can begin testing our application. Okay. So I'm going to start the job service. I'll even select the company service and I'll start that. We'll have review service as well. So let us keep an eye on the logs. So you can see here, this service is started, the job 1. We have company also started, and then we have review also started. So what we can do is we can switch over to Postman and try accessing these services. So now here you can see in pgadmin, which I have open here, you can see some activity happening, and this is all about creating the tables here. Okay, so if you go over here, you will see the tables being created because we just started the services. Now what we can do is we can head over to Postman and I can go to Job Microservice. I can say get me all the jobs. Of course, you won't get any data right now. So what I can do is I can create a job. Okay, so I'll create this particular job. Let me see what happens. So job has been added successfully. I'll even create a company. Okay, so I'll create this company 1. I'll create this company 2. Okay, and you can even get the list of companies. So you can see it's working fine. And if I try to get the jobs, you will see the jobs are also coming in. Also, let us add something to the reviews. So I'll add this particular thing to review against the company ID 1. So this is added successfully. And now if I say get reviews, you will get the reviews here. Okay. Now we can head over to PostgreSQL like pgadmin and you can refresh it over here. Now here, if you go to tables, so under tables, you'll see company and we can say view all rows. So you can see over here that the data that we were adding is being saved into the database. And you can check this for all the services. So you can go to job and schemas and I can scroll down to tables. And here also I can see the data being added here. So we have added 1 job so far. Okay, you can see all the information coming in. You can even go to review here and here under schema, you should be able to see all the tables. And if you click on the table and if you try to see the data, you are going to see the data appear over here. So it's working perfectly fine. Our configurations have been perfect and things are working flawlessly with the database. So this is about the testing. You can do some more testing. You can play around with different API calls and see how the data is being reflected into the database. All right. Thank you. Hey there, welcome back. So let us start talking about inter-service communication in the world of microservices. So microservices architecture, as you already know now, is an architectural style that structures the application as a collection of small loosely coupled services. So in microservices world, our application is looking something like this. So we have 3 services. We have company service, job service, and the review service. And these services are running as their own processes. They have their own memory and they might be even located on different servers. So ideally, microservices are deployed on separate servers and they also have their own database which they are interacting with. Now, what is happening is we have a client like a browser or a mobile app or any sort of client that can access our services. So user will be accessing our services from a particular client. Now the thing over here is user is not aware of the inner details of our services and we don't even want to expose this to them. So for a user or for anyone in the outside world, our application needs to function as a single unit. So outside world should not be aware or does not need to be aware of the inner details. Like a user won't care whether you have different microservices running on different systems or how your application is structured. What does a user care about? User cares that he's sending some request and he needs a corresponding expected response from you. So user is not aware of behind the scenes, and user expects that your application functions as one single unit. Now, since these microservices are running on their own, they have their own separate processes, and also they need to be projected as one single unit. There is a need for these services to communicate with each other so that they can function as a single unit and a cohesive system. Now, this is where inter-service communication comes into picture. So what is inter-service communication? In simple terms, it is a method through which microservices in an application talk to each other. And this communication between services can happen synchronously or asynchronously, and we can use protocols like HTTP or REST messaging. And we can use protocols like HTTP or REST or messaging. Now, why is this inter-service communication important? Like I mentioned, we need to function, or all the microservices need to function as a single unit. And in microservice architecture, each microservice has their own memory space and they run in separate processes. And for one service to talk to another, there will be a need to serialize the messages in a common format and to send them over the network. So this makes inter-service communication a fundamental part of any microservice architecture. Now, there are different ways to implement inter-service communication. And the number one way is synchronous communication, and then we have asynchronous communication. So synchronous communication mode uses synchronous request response mechanism where the client waits for a response from the server before proceeding. And this can be achieved through HTTP based protocols like REST or even SOAP. And in asynchronous communication, microservices can work asynchronously and they can communicate with the help of message queues or message brokers like RabbitMQ, Apache Kafka, or AWS Simple Queuing Service, which is SQS. Now, what happens in this case is the sending service publishes the message to a particular queue. So there is a queue that we will have in that particular system. And the sending service will publish the message to the queue, and receiving service will consume the message when it's ready. So there is a possibility that whenever a message is being sent, the receiving service is not yet ready. So we take help of queue over there where the message is queued, and whenever the receiving service is ready, it consumes the message. You could even use synchronous communication, but this is much more synchronous. And we make use of protocol like HTTP or RPC based communication. So this choice depends on your specific requirements. So this is about microservices intercommunication, and I hope you all have a clarity as to why it's important and what it is. Hey there, welcome back. So let us start talking about what is REST template and why do we need it. So what is REST template? So REST template is a class in Spring framework that simplifies the HTTP communication between two microservices. Now you can use this for communicating between microservices, and it does so by abstracting the lower level details into a very high level, easy to use methods. So you can use this particular class to send HTTP requests to your RESTful web services and also consume the responses. So why do we need REST template with microservices? Of course, we'll be using it to interact between different microservices that we have. So let's say we have job microservice and a company microservice. So if these two microservices need to communicate or exchange any sort of data, then we can use REST template, and we will be making use of HTTP protocol using which we will send HTTP requests, and we will even handle HTTP responses. So what are the advantages of using REST template? So let us talk about some features and advantages. So the number one feature or the advantage that we have is abstraction. So REST template abstracts the complexity of the HTTP communication, and it provides a simple method-based API for client-side HTTP access. Now this simplifies the code and reduces the chance for errors that might occur otherwise. The next benefit could be versatility. So REST template can handle HTTP methods like get, post, put, delete, and so on. The next benefit or feature could be conversion. So REST template can automatically convert the responses into desired data types. For instance, you can receive the response as string, JSON, or even XML, or even directly as a Java object. So this is one benefit. It reduces a lot of complexity and a lot of repeated stuff that you need to do. Error handling. So REST template also offers good error handling abilities, like it throws a specific exceptions for different HTTP status codes. Then we have integration. So REST template is a Spring library and it is available in the form of a class, like you have to make use of a class, and it is well integrated into other Spring features. So this gives REST template an edge. And if you're working on a Spring application, using REST template will make things even smoother. So since Spring Boot is based on Spring, we can easily make use of REST template for our needs. So compared to other methods of inter-service communication, REST template stands out due to its simplicity, tight integration with Spring. However, it's worth noting that REST template is blocking, which means it waits for the server to respond before continuing with the execution. So what I mean over here is, so if you have two microservices, and if microservice 1 is sending some communication to microservice 2 with the help of REST template, so this communication that is being done will wait for the server to be available. Okay, so basically the other server on the receiving end should be responding immediately to this API request. So it's real time and it's not asynchronous. So it is synchronous or real time is what I can say over here. And this could be a disadvantage in scenarios where you need features such as non-blocking or asynchronous features are needed. Then in that case, this might not be helpful. So in that case, you need to go with some other alternative. But REST template is still a good choice to begin with microservice communication within different services that we have. So that's about a REST template and an overview as to how it works and what you need to keep in mind. Welcome back. So let us see REST template in action. So here I am on Intellij IDEA and let me collapse everything. Okay. So I have 3 microservices. Now let us say I wish to communicate with the company microservice right from within the job microservice. So job microservice will be communicating with the company microservice and we will be communicating with the help of REST template. And what are we communicating? So we will be doing an API call wherein we get a particular company from this particular microservice. So what I'm going to do is I'm going to head over to jobs microservice. I'll switch over to Java and let us say we have this controller here. So within this controller, we are getting all the jobs from this particular GET request. Now I'll go to this particular GET request service implementation here. And here I'm going to make use of REST template. And using REST template, I'll get the company details as well. So what I will do is I'll say REST template. So you can see this drop down appear from org.spring framework. So I'll select this and you'll see the package being imported. So it's org.spring framework web client and you have REST template class within this package. Now here, let me collapse this. So whenever we are making a call to get all the jobs, we will print the company ID of any one particular company ID. So we are just going to demonstrate how we can make use of REST template. So I'm going to say REST template here is equal to new. So we are creating an object of REST template here. Okay. Now we have the object. Now using this object, I'm going to make call to the company microservice. Okay, so I'm going to say REST template dot, and you can see different methods here. Okay, so I'll say get for. So I'll make use of get for object here. Okay, and I'll specify the URL over here. Okay, now what is the URL? So I'll go to Postman. I'll open the company microservice and I'll get this URL here. This one to get the company details. Okay, and I'll come over here and let me paste this URL here. So I'll try getting the company with ID 1. Now here, if you hover on this, okay, you will see you have this string. So the string is nothing but the URL that I'm passing. Now we need to have the class object. Okay, so I can say company here, company.class, like so. So here we have specified the company class. So what the second parameter does is it will wrap, or it will convert the response that we are getting from this request here into a specific class. So since we are getting the company class object, we can map it to the company class. But the problem is we are within job microservice and we don't have the company class over here. So we will have to create the company class here. So what I can do is I can add a package over here. Okay, so I'll just collapse this, or I'll say new Java class. I'll say external dot company. So I'm specifying that I need this package, this class within this particular package. And this package, if it does not exist, it will create it. Okay, so I'll just press enter and you will see this package being created and also the company class. Now what I can do is I can go to company microservice here, and within the company microservice, I'll copy this here and I'll come over here and I'll paste this. Okay, now there are a few things that we don't need, like we'll remove the package declaration. We don't need this jakarta.persistence because we are not persisting this. We are just using this to keep a track of company. Okay, so I'll just remove all of this. All right, so we have the class ready. Now here I will import this class. Okay, so I'll import like so, and you can see the class has been imported. Okay, now we have kept the package name as external because these are all external classes. Okay, so we have done this. Now what will happen is whenever you are making a GET request, and this is a GET request that is in action to this URL, and the response that you get will be mapped to this particular class over here. Now what I can do is I can get the object. So I can say company like so. Okay, so we have the object that is being assigned to company, and now I can just simply print it on console for now. Okay, so this is not a good practice. Okay, but for the purpose of demonstration, I'm just printing it onto the console, and I'm not using any logging framework or anything like SL4J or anything. Okay, so I'm just demonstrating this. So we have get name, and I can even print the ID as well. So I'll say get ID like so. Okay, now I'll hit save and let us rerun this particular service here. So I'll go to services and I'll rerun the job microservice. So let me rerun this. So you have the microservice up and running without any issues. Let us head over to Postman. Now let us try getting all the companies. So you have a couple of companies added here, and from the job microservice, if you try to get all the jobs, we were printing the company information. So I'll get all the jobs. Okay, you don't have any jobs, but let us check the console here. Okay, so here in the console you will see company 1 and company ID. So we are getting the name over here. Okay, and if you take a look at the name here, okay, so let me show you the name. So this is company 1. Okay, if I update this particular company name, so if I update to this, and if I try to get the name, you can see we have the company name of the company with ID 1 updated like this. Now if I try to do a get request again, we don't have jobs yet. But if I scroll down, you can see again we have the company details printed. And this is because we are printing it with the help of the REST template. Okay, so this gives us the proof that we are able to communicate to company microservice from job microservice with the help of REST template. So as you can see, REST template was very useful in this particular scenario, and it helped us even map the response to a particular class. And we could just do this with the help of a simple method. So this is the benefit of using REST template. Like, it has abstracted a lot of details. Like, a lot of details are hidden from you, like making a call to this particular URL, then getting the response, reading the response over the HTTP protocol, then seeing the response and mapping it to every field within the company or any class that you specify. So this everything is being done by a REST template under the hood, and it takes away a lot of hassle from developers like us. So that's REST template for you. Welcome back. So let us start talking about the DTO pattern. So DTO stands for Data Transfer Objects. So it is a pattern which is used to transfer data between software application subsystems. Okay. So in context of API, so if you have to talk about DTOs with respect to APIs, it can be useful to design the structure of the data that you want to expose over the API. All right. So what I mean by this is, if you want to have some custom structure or the response structure, then you can make use of this pattern to implement in your microservices or any REST API, not only in the microservices, and you can play around with the structure this way. So this gives you a better control of the structure as to what users are seeing. Now, with the help of DTOs, which is Data Transfer Objects, you can retrieve the necessary data from microservices. So right now we are talking about microservices. So if you are implementing DTO, you can fetch the data from different microservices independently, and you can map them to the respective DTOs. So let me give you an example. So here I have a job microservice and company microservice. Now let us say to the response, okay, to the user, I wish to show the job object as well as the company object. So whenever a user calls a job API, I wish to even provide the company information along with that job. For example, if we are getting all the jobs from the job microservices, I wish to provide the company JSON as well along with every job instead of just ID. Okay, so this can be possible. Okay, you can give a custom response to the job microservice. But how? So you can add a data transfer object or DTO within this application. And what this DTO can have is, it can have objects to both these classes, and then this can be converted into the response to the user. So this gives you a better control as to how you can manage what is being shown to the user. Now, without the help of DTO, this would have been a bit difficult, but DTO makes your life much more easy. So without a further ado, let's head over to our IDE and let's start implementing it. So here in Postman, if you query jobs, so I believe we don't have any jobs right now. So if I create a job and if I query job, you will see we get only the job information along with the company ID. So I don't want this ID, but instead I wish to show the entire company JSON, which depicts the company information who posted this job. So this is my requirement now. So we will be implementing this with the help of DTO. So let us head over to Intellij. So here we are going to implement this thing within find all, because find all is being called when you are calling a get request on /jobs. And this is the controller method which is responsible for returning all the jobs that exist in our application. So we are making call to jobservice.findAll. So this is where we are going to implement this. Now, what is a DTO? So DTO is nothing but a class that you can create, and this is the class that represents what user sees. Okay, so I'm going to create a class over here. So I'm going to create a package first. So I'll say give me a, okay, so I'm creating this in company. We should not create this in company because the response we are getting is from the job. So I'm going to come over here under job. I'm going to say package, and I'm going to call this as DTO. So this is our DTO package, wherein we are going to have all the DTO classes, and I'm going to create a new class. So we can say job, so job here with company, and I'm going to add DTO in the end. Now let me get this created. Okay, so I have Git configured, so I see this pop up again and again. So I'll say don't ask again. Okay, it's asking me whether I should add this file to Git. So we have this DTO configured. Now, what is the response that we want? So the response we want is of job. So I want job here, and I also want company. So this is what my response structure will look like. So my response should have job JSON as well as the company JSON. So I can say private job like so. Let me get this imported, and here I can say company. So I'll say private company, and I'll say company like so. Okay. So what we are doing is we are creating an object of job class and a object of company class, and this is what is going to be shown to the user. Now we need to add some getters and setters. So I'm going to get Intellij to auto generate these for us. So I'm going to say getters and setters. I'll select, and we have the getters and setters here. So we have the DTO object or DTO class set up. Now I'll head over to job service implementation class. Now here is where we need to do the magic. So here what we will be doing is we will be making a REST template call to the company object, and we will be doing this for every job object that we have because we want to add the company object to every job object. Okay, so what I can do over here is, let us say we can I'll just take this. We can delete this in fact, but let me see if I can reuse this code. So first I'm going to say list, and I'm going to create the list of jobs over here. Okay, I'm going to call this as jobs, and here I'm going to say job repository dot find all. So what we are doing is first we are getting the list of all the jobs with the help of the repository class that we have. Sorry, not the class, it's an interface, but this is what we are making use of. So now what I need to do is I need to create a list over here, and this list will be of the DTO. So I can say job with company DTO, and I'll say job with company DTOs, and this will be new, and I'll give this the type of array list like so. So this is an array list which represents this particular class. So it has list of this class objects. Okay, now I'll make use of this REST template call. Okay, so we create an object of REST template here, and we add a for loop. So what we need to do is, why are we adding a for loop? So for every job object, or for every job that we have in this list, we need to get the company object, and every job object has a company ID. So what we need to do is, with the help of for loop, we need to iterate over the list of jobs. We need to fetch the company ID from the job, and we need to make this call to the company microservice, and we need to get the company object and add it to the DTO like so. Okay, so I'm going to say for each. So for each loop will be easier. I'll say job, and this will be of job type. Okay, now here I'm going to say iterate through the jobs list, which is at the top. I have declared it, and here I'm going to start writing all the code. So the first line, what we are going to do is we are going to create. So I'm going to say, so we are going to create an object of this TTO class. So I'm going to say job with company TTO like so. And here I'm going to have new job with company TTO like so. So now since we have created the TTO object, we need to add the company object as well as the job object. Okay, we need to add this both to this TTO object, and then ultimately this TTO object is what will go into this list, and this is the list that we will be returning. Okay, so we need to even change the return type over here. So that is something that we'll do shortly. So I'm going to say over here job with company TTO. So this is the object here, dot set job, and I'll pass in the job object. So we have the job object, which is what we are iterating with. Okay, and here I'm going to now make a call to the company microservice like so. So I have the call also ready here. So I'm just going to press enter here. Okay, so these are the two parameters that I'm passing, but instead of one here, I need to make this as dynamic. So I'm going to remove one here and I'm going to concatenate here. So I'm going to say job dot get company ID. So we are calling the company object. So we are calling the company microservice and we are passing in the company ID to get the corresponding company object for the respective job here. Okay, so for every job we are getting the company ID and we are telling company microservice, hey, give us the company with this ID. All right, and it's being auto mapped to this particular class over here, which is the company class, which is something that we have specified already. So this headache is taken care by REST template, wherein it does the API call on the HTTP protocol, like using HTTP protocol, and the response that it gets, it is mapped to this company class. Now, what do we do with this company class? Yes, you guessed it right. We will set it to the TTO. So I'll say set company. So job is already set. Now, after getting the company, we set the company. So we have job set here, company set here. Now, what do we do with this object now? Yes, we need to add this particular object to the list which we have defined here. So I can say job with company TTOs. Okay, so I can make this as a bit small so that this looks a bit cleaner. So I'll say TTOs dot add and I'll say job with company TTO like so. Okay, so this is our source code so far. And what we need to do is we need to get rid of these system.out.println statements, which we use to understand how a REST API call works using REST template. Okay, so we have removed that. And now we need to return something here. So we don't need to return now the list of all the jobs, but instead we need to return this object here, which we are creating with every iteration of for loop. Okay. Now, the moment you do this, you start getting all red marks because the return type you have specified is of job type. But now you are changing the return type to that of job with company TTO. So I'll change this to job with company TTO. Now, the moment you change this, okay, like you are overriding this from the service class. So let us head over to service. So this is the interface here, okay, and here we need to add this over here, okay. So I'll hit save. This error goes away. So our service class is now sorted. Now where the issue is or where the issue can come, the issue can come in the job controller. So in the job controller, we are returning the list of jobs over here, okay. So you need to change this to list of jobs with company TTO. Okay, so I just changed the return type here and all the red marks have gone now. All right, so now let us take a look at what we have done so far. So what we want to do as a requirement is we want to have a response structure for getting all the jobs, wherein we are just right now giving only job as the response. So we have the job object as the response. What if we want to add company object to every job? So in order to do that, and in order to have better control on the response, we used DTO pattern, wherein we created a DTO class which has the representation of job and company. And from here, we are creating, or we are getting all the jobs first from the database. We are creating a list that we are going to return, and this is a list of job with company DTO. We create an object of REST template, and then with the help of this for loop, what we are doing is we are iterating through the every job object here. So we have jobs over here. So for every job object, we are getting the corresponding company, and within this for loop itself, we are constructing the list over here. So we are creating this object here, job with company DTO, and this object is something that we are adding in this particular list for every API call that we do. And ultimately in the end, we are just returning this list that is being constructed. So this is the entire mechanism that we are using, and this is how it is going to work. So that's about this class. This is how you can make use of DTO patterns. So now, after implementing the DTO pattern into our microservice, it's time that we test the changes. So we have made changes only to the job microservice. So we just need to restart that service and not the other services. Okay, so the microservice was restarted without any issues. Now, if you head over to Postman, and if I say, give me all the jobs, there are no jobs, of course. Do we have companies? Yes, we do. We have a couple of companies. Let us create a job. So I'll add one job, and I'll add another job, let's say. So we have added a couple of jobs. Now let us try and get all the jobs. Now let us see what the response look like. So here you can see like you have the entire company JSON as well as the job JSON. So this is the job object, and here you have the company object. Okay, and this is being shown to the users as an output. Okay, so it's clearly working. What we can even do is we can simplify this method over here. So with the help of this for loop, we are converting the job object and the company object into DTO. Okay, so what I can do is I can move this entire thing into its own method. Okay, so I can say private job with company DTO, and I can say convert to DTO like so. Okay, and here I can have the opening and curly braces like so, and here within this particular method I'm going to accept a parameter. I'll say job like so, and let me paste this thing over here. So we don't need the for loop coming in over here. Okay, we are passing this object as the parameter. So I'll just get rid of this. Okay, I'll even get rid of this here. Okay, and here instead of adding this to job with company DTOs, I'm simply going to return the job with company DTO like so. So whatever DTO object we have created is what we are returning, and we are not adding it to the list. Okay, now here we are getting an error for REST template. Okay, so what we can do is we can move this particular object creation to this method here like so. Now what we need to do is we need to make use of this method here. So we can make use of this method with the help of a concept in Java called streams. Okay, so here instead of returning the list, what we can say is we can say jobs dot, and I can convert this to stream. So this jobs is nothing but the list of all the jobs that we are getting. Okay, so I'm converting this to stream. I'm saying dot map, and I'm mapping this function to every object of the job. Okay, so and then here I'm going to say collect and I'm going to say collectors. Sorry, so it got auto-populated, collectors to list, like so. So what are we doing over here is we are making use of Java streams. So this particular statement here, jobs.stream. So this stream method is called on the jobs list, and this method converts the list into a stream. Now what is a stream? So a stream is a sequence of elements that can be processed in a pipeline. Okay. Then we are making use, or we are chaining a method called map over here. And this particular method is an operation. So map is an operation that is applied to the stream that we get over here in the previous step. And this particular method takes a function as an argument, and this applies the function to each element of the stream. So what do we have in the stream? We have the jobs object. So if there are 10 jobs in our application, we will have 10 job objects within the stream. And we are applying this particular function with the help of map to every object in job. Okay. So now this mapping function will convert. So this function is being called for every job object, and we have this definition over here. And for every job object, we get the response that is then collected over here. Okay. So with the help of this, so this is an operation, collect operation, and it is used to collect the elements of the stream into a new collection. Okay. And here with the help of collectors.toList, I'm using this particular method here, and this collects into list implementation. Okay. So with the help of this, I'm specifying that I want the output to be collected into the list implementation of the collection. Okay. And then this is returned as the result, as you can see over here. So with the help of this, we are able to obtain the list of job with company TTO, and this objects represent the jobs along with the associated companies for us. Okay. So let me rerun this again and let us see whether this worked perfectly fine. So this is just another way of doing the same thing, and we did this with the help of streams concept. And we have even modularized the code. So we have separated the repeated task into a method, and a code is considerably reduced and looks simpler. So now since our microservice is up and running, let us head over to Postman. Now here we won't have any jobs. So let us add a couple of jobs. So I'll add one job, and I'll change this to 1, and I'll add another job. Now if you try to get the jobs here, you will see similar result. So the output has not changed, and this is working absolutely fine as expected. So yeah, we have tested the DTO pattern successfully, and it is helping us communicate and have a better control on the response that we are showing to our users or consumers who will be using the API eventually.